And we're live. Awesome. With that, I would like to welcome everybody to HashiTalks Canada and just welcome to you, whether you're tuning in for a good morning, afternoon, or evening, wherever you're coming from. We're really excited to be kicking off the very first HashiTalks Canada today. And I'll just give a quick introduction. My name is Jackie Grinrod. I'm a developer advocate here at HashiCorp, and I will be one of your MCs for the day, along with Jason, if you'd like to introduce yourself.
Sure. Good morning, good afternoon, good evening. I'm Jason Harley, as Jackie said. I'm a member of the HashiCorp Ambassadors Program, and I am a customer architect at Honeycomb.io. I'm really excited to see these talks and see what the Canadian HashiCorp user community has been up to.
Yeah, it's really nice to kind of work with like a home-based kind of event today. So we're both based out of Canada. So just before we kick off, I just would like to remind everyone that we would love to have your comments and questions in the chat. But as you engage with us, please do keep in mind that we have a code of conduct. In general, please be welcoming, inclusive, and friendly and patient. Be considerate, respectful, and professional. And if you have any questions about what the code of conduct looks like, you can check it out at hashicorp.com/community-guidelines. And with that, I think we're ready to kick off. How do you feel about getting started?
I'm into it. Our first speaker is Jenna Penderson from AWS. She's a senior developer advocate, and she's going to talk to us about bringing software development practices to your infrastructure.
Thank you, Jason and Jackie. Hi, everyone. My name is Jenna Pedersen, and I've been a software engineer turned developer advocate, and I work at AWS. I've been writing software for nearly 20 years, maybe actually a little bit over 20 years. And this is actually one of my favorite topics to talk about, which is software engineering best practices. And I am excited to talk about actually bringing it to your infrastructure as well. So let's get going. Can we share? Yes, can we share? There we go. I thought that was already up. Okay. So just a fun fact about myself. I once had the phrase automated test fanatic on my business card. So if you're wondering, I think very highly of automated testing. I have since taken it off my business card. I actually don't have business cards anymore. But I think very highly of it, but I am very, very much less dogmatic about it. I want to make sure that we are testing the right things, spending the right time in the right place. And I think there is a need for a happy balance between testing and actually being able to move fast. And so I do think there is a place for automated testing or even manual testing in pretty much everything we do, whether that is learning a new framework or building a high skill app for the cloud. And again, like the thing that we're going to talk about today is like figuring out how to find a happy balance between what kind of testing is right for the situation and how much to do. So let's just review what infrastructure as code is. It lets you automate deployments of your infrastructure. And this lets you facilitate both scaling and quicker repeatable deployments. The best part about this is that it's also code. And this means that you can version control it, you can code review it, you can test it, and you can push it through your CI/CD pipeline, the different stages. So I'm sure you've all earned this badge, the Works on My Machine badge. I certainly have. And with infrastructure as code and working in the cloud, there's more that can go wrong when we are working on more than just our own computer, our own machine, our own very narrow space of an environment. So when we are pushing changes to the cloud, whether that be through infrastructure as code or it's even manually, there is a larger blast radius here. And instead of it just, if it breaks, if something does go wrong, what ends up happening is it might not work on, it might work on your machine and it might work in your account and it might even work in one region that you're working in. But if it's broken and you push it into a different region or a different account, you aren't going to catch that until you've actually provisioned that software or those resources. So you have more resources, more regions, more customers, and more dollars that are impacted when things do actually go wrong. So it's not just an isolated occurrence. So in the next 25 or so minutes, we're going to talk about treating your infrastructure as code, as actual code, and minimizing that blast radius. We'll talk about the different types of testing, using test-driven development to make sure you're building what you need and only what you need. We'll talk about testing your infrastructure directly, so testing what's actually provisioned in your account or in that region. And then we'll talk about integrating all of this into a CI/CD pipeline. So we know that the cloud makes it a lot easier and quicker to provision our infrastructure. But again, like I mentioned, there's complexity with that scale. So maybe you're writing infrastructure code to replace all your EC2 instances with the latest Graviton 2 instances. You've tested it in your AWS account, and then you go to push it to the production account. And something goes wrong. So in this case, the EC2 limits, maybe they haven't been increased for that custom AMI, or maybe it's not even available in that account. So either way, we have to roll back our changes and try again. So infrastructure as code is one way that we can manage that complexity, especially at that scale. Automated testing is yet another way. So with automated testing and bringing some of these software engineering practices to our infrastructure, we're able to build quality in from the start, just like we would with our application code. Now, when we talk about bringing testing to our infrastructure, it's still important to consider the different types of testing that we're going to use. So just like we do when we build this test strategy for our application code, we're going to do something very similar for our infrastructure code. This here is a variation of the testing pyramid. It's been around for many years. And the tests at the bottom of this pyramid are going to be cheaper and easier to create and to maintain. They also give us quicker feedback. And this is as to when something goes wrong or when something does actually go right. And so they're more fine-grained. They're testing one small chunk of logic or configuration. And that's why it's called a unit. So one chunk is one unit. The tests at the top of the pyramid, those are going to be more expensive to write. They're more expensive to maintain. They're also often more brittle. So in the case of our infrastructure tests, they are going to be more complex because it involves spinning up and tearing down actual resources in the cloud. So with our unit tests, we are testing the actual code itself. We're not actually testing resources in the cloud. With integration tests, we are actually creating those resources and testing those directly. Again, like I said, tests at the top of the pyramid are more expensive. So manual tests are going to be the most expensive. They're most time consuming. And we want to not have as many of those. We want to have a balance of the fast, quick, cheap tests with the more expensive tests, or the ones that are more closer to the actual infrastructure that we are going to be using in production. So those that are at the top are going to reflect reality a lot more, but they're more expensive when it comes to our time and dollars and just maintaining that. And so that's why we have to have that balance. So if you're test driving your application code, why would you not do the same for your infrastructure code? The benefits of test-driven development include reduced defect rates. There's actually research out there that talks about specific numbers. I don't remember what they are, but there's research that talks about how test-driven development can actually lower the number of defect rates that you're seeing. And it brings them earlier in the process so that they aren't as impactful as if you had found that defect in production. It also improves the overall design of what you're building because you're doing it in increments or iteratively. Keeps you focused on requirements so that you're building only what you need and when you need it, and nothing more. When you're building extra things, the nice to haves or what's not actually a requirement, you tend to find more defects in that area because it's not what you actually needed. It can also it keeps you focused on smaller chunks, those units that we talked about, so you can make sure that those pieces actually work independently of each other. And then it also serves as documentation for your team. So a lot of times when I go into a new code base, the first thing I look at is the unit tests or any other tests that are there, just to see. I'm also looking to see if there's any sense of the quality that the team is adding to their code base, but I also am looking to see what functionality is supported, what the features are, what the team thinks are the expectations of those requirements and of that code. And then finally, test-driven development gives you confidence in what you're building. So it gives you the confidence to be able to refactor something. It gives you the confidence to be able to build new, whether it's new infrastructure on top of your current set of resources, or it is adding new logic or functionality to an existing application. So this is the test-driven development flow. You can follow the same red-green refactor flow that you would when you write your application code. So the way this works is you start with a failing test. So you write that failing test. You get it green by writing only enough production code to make it pass. And then you make it better by refactoring it or adding the actual functionality that you're trying to implement. So in the examples that I show in just a minute, we're going to go through this process so you can see how it works, both with unit tests and even with some integration testing. So what is a unit test? Let's talk about that. These are the tests that are going to be at the bottom of that testing pyramid. They are the cheap and fast tests. They are quick to run. They're quick to give you feedback. It exercises a small part of your application or your infrastructure, so one unit, and verifies that it's correct. They, like I mentioned, they're quick. They can be run frequently. So if you're running them locally on your machine, you get quicker feedback for your local development processes. They help us communicate requirements to our team, and they can also be run in your CI/CD tool. Now, traditionally, these unit tests are isolated from other resources, so or external APIs. So what that really means is if in the case of when I'm testing my application code with a unit test, I'm not going to test the boundaries of different classes or objects, or even go to the point of testing how my application is using the database and testing that connection and querying and manipulation. I actually just want to test how it's interacting with those, or I want to test even a smaller unit of that is how what the logic is doing within the context of that one object. So we are trying not to test across those boundaries of external APIs, and that can be whether that's a REST API or a database. We are keeping that very isolated. And that's going to let us reduce the scope of what can go wrong and the number of variables that impact what can go wrong in our test. And then finally, I just want to mention, like, if you've ever provisioned an RDS database, which I have done multiple times recently, it takes several minutes to do. And if you do it wrong the first time, whether you're doing it manually or even in your infrastructure code, you have to wait. You write the code, you apply it or spin it up, and then you have to sit there and wait for it to actually provision it. And if there's something wrong the first time or multiple times that you're going through this, you have to go through that process multiple times, the waiting process. And so that can be really time consuming. And that's where these unit tests can come in handy, is we can write a unit test to verify that we are setting up this database according to what our requirements are actually looking for. So we can actually do the same thing for our infrastructure code. We can apply the same process, unit testing, test-driven development. We can apply that to our infrastructure code. And with unit testing, we can do that because it's code. It's not actually in infrastructure at this point. We don't need to provision all of the resources in order to test to test what we are trying to build. Just like with our application code, we don't need to have that database sitting there in order to write tests against maybe a CRUD API. So yeah. Now a unit test, we've talked a little bit about this, but a unit test is going to test if a resource is created with the correct configuration. So in the case of infrastructure unit tests, we're talking about the configuration of a specific resource. With application code, it might be the logic, or it might be how you configure inputs into a function call. But with resources, it's oftentimes it's going to be the configuration. It can also be the correct whether or not the correct number of resources have been created. So in my examples that I'm going to show you in just a minute, I'm essentially creating one of everything just for the purposes of time. But our infrastructure code allows us to create multiples in order to scale. So for instance, I might need to create 5 different EC2 instances or 5 of the same EC2 instances. I can make sure using my unit tests that I'm doing just that there 5 have been created and that they are configured correctly. We can also test that dependencies between resources are created correctly, and then also interpolated values as well. So in this first demo, I want to show that it is possible to test drive your infrastructure code. So for context, this is a Cloud Development Kit app or a CDK app. We want to create a private S3 bucket with encryption enabled by default. So it's a very simple, small use case. And we are going to write the infrastructure code with we're going to write the infrastructure code with the CDK code, and then we're going to make sure that our test passes. So we're going to use the Jest framework for the unit testing. And while this demo is written with the CDK, you can also do this with other frameworks. So you can write unit tests with other testing frameworks against other infrastructure as code frameworks. So that could be against a Terraform plan representation, or it could be against a CloudFormation template. So this is just an example of what you can do here. So this is a pre-recorded video. It has been sped up a little bit because some of this stuff takes a little bit of time. We are writing the Jest unit test. We're going to create the S3 bucket stack or set of resources for this particular application. And then we're going to add some expectations to this on this stack. We want to make sure that it has an S3 bucket resource. And we're going to make sure that some of the configuration for that S3 bucket is correct. So I mentioned earlier that we want to create a bucket that has encryption enabled by default. And so I've added in some of the properties to make sure that enable this encryption, and then we're expecting certain values for that. So heading over to the terminal, we build and run these tests. at the command line, I can see very quickly that there is a compilation error, and that's because we haven't actually written the production code yet. We've only written the test. So here we are creating the bucket, the S3 bucket stack itself. So this is the production code. We're creating the class. We're setting up the constructor. And then this is where we are going to add, we're going to add the S3 bucket resource. We're going to give it an ID and some of that configuration. So we're so the ID is the ID of the resource within this code. The name, the bucket name is the actual bucket name in the AWS console. We are blocking all public access, and then we'll run and build and test this again. So now we can see we still have a failure, and that's because I missed a piece of the configuration, the server-side encryption configuration in my production code. So it's just telling me that it's failed. It's showing me the comparison of the configuration for what was expected versus what was actually generated. So I'm going to go into my production code. I'm going to add the encryption configuration, setting it to enabled, and then we'll rerun our tests here. And we have a passing unit test. So that is how we get, we can do that test-driven development flow that I mentioned earlier with our unit tests. Now, we have our infrastructure code. It's been tested. We can apply it to create resources in the cloud. We could go into the AWS console and poke around and check the state of those resources. But if I had 30 S3 buckets, that's going to be a lot of work. I don't want to do that. And that could be, you know, across accounts, across regions. It could be more than just one S3 bucket. It could be an entire stack of different resources. And so manually testing that and manually making sure that everything was set up correctly it's really just not feasible for larger situations beyond like one S3 bucket or one EC2 instance. So what we can do is we can actually write integration tests. And this is a form of testing where we are testing interactions across the different units or modules, or in the case of infrastructure testing, we're testing across different cloud resources. So it's going to allow us to verify that we've provisioned these resources correctly. They've been created correctly. They're configured correctly as we expect them to be. So as I mentioned a lot earlier, the cloud is making it easier for us to scale. But with this complexity, we have to figure out how we can manage that. And integration tests are another way to give you confidence in the actual provisioned resources. It lets you do that at scale, and it lets you do that at velocity. So in just a minute, I'm going to show you another example of integration testing. And this is going to use an open source framework called Chef and Spec for testing, and it's used for testing and auditing your infrastructure. You're able to write tests with a DSL, so a domain-specific language. So we can do this on remote systems like servers. We can do it on containers, and then we can also do it on cloud resources, which is what we're talking about today. It can be used, one of the benefits of this is it can be used on any machine or resource, regardless of how it's managed, or even if it's not managed at all. So it could be managed by CloudFormation, it could be managed by the CDK, which is what we've been using today, or it could be managed by Terraform, or even manually by a human. So it doesn't even have to be managed with infrastructure code. It's easy to read and learn, and it can be used across teams. So for instance, your security team might want to have some a set of rules and impact levels that they have set up specifically for how you provision infrastructure in your company or your team's environment or for certain situations. So these inspect tests, when they're set up that way, we give them an impact level from 0 to 1, and based on that impact level, that can either fail your test or just provide a warning based on that impact. And then again, this is just it adds to how you're able to make sure that your requirements are being met. And it helps you do this at another stage of the software development lifecycle. So in this demo, I want to show you it's possible to test your infrastructure directly, and you can even test drive those tests right alongside your unit tests. So for context, this is another CDK app. There's an EC2 instance and some related resources already tested and provisioned. And now we're going to add a database to this app. We're going to write a failing integration test. We already have a failing unit test, but we're going to write a failing integration test with the inspect framework that I just mentioned. We'll update the infrastructure code and then make sure both our unit tests and infrastructure tests pass. So if you're familiar with RSpec, unit test in Ruby, these are going to look familiar because it's built on the same, on top of these inspect tests are built on top of RSpec. So for this one, we're going to go into the unit test, and we already have, like I said, we already have our EC2 instance tested. We have a couple of other related resources tested. We've added a unit test for the database that we're adding, making sure that it's set up correctly and that we have an output of our from our infrastructure code that we can use in future tests. So we build and run this test, and we have a failure, and that's because we haven't updated our production code to include the database yet. So if we go into the production code, we can see here we have all the related resources to create our EC2 instance. We've set up our security group. Elastic IP, and I've while I was only testing one of those outputs, here we have both outputs that we use in our inspect test later. So then now we want to go into the inspect test, and this is going to look, if you've used RSpec, it looks a little bit familiar. We have that impact level and title at the top. A control on line 3 there is really just grouping. It's another way to group tests or related tests. Lines 10 and 11 are output parameters that we are going to use in this test. So when we create our stack, we want to output certain resource IDs so that we can use them in these tests. We are making sure we have an EC2 instance and the security group and making sure they're set up correctly. Here, we're going to add database outputs. We want to make sure we have that instance identifier and security group ID so that we can, this is so that we can actually find that resource in our account during this test and test against that specific one, that specific resource. We could go through all resources, so all databases that are created, we want to make sure they're set up in this specific way. So there's a different way to get at all resources versus just one specific one. Here we are adding the RDS instance test. We want to make sure that the engine is Postgres, the version is 12.7. We're making sure that the instance class is a T2 small. And then now we can go and run our test at the command line using the inspect command line tool. We can see here we do have a failure. And that is because we haven't actually created that RDS database in our production code yet. So that will be what we do here. We're importing the resource class. And then after our EC2 code, we're going to add that RDS database instance and set that up how we need to. So we're gonna give it an instance identifier. We're giving it the engine, the version that we are expecting, a few other bits of information. We're gonna tag it, and then we're gonna set up the connection so that our EC2 instance can actually talk to our database. And the video is paused. I'm going to just talk through the rest of this. Oh, here we go. Okay. And then we're adding those outputs. The outputs are used for the, again, they're used for that inspect test so that we can assert against specific resources. And then, so this is where those outputs actually are when we've run our CDK code. The actual values get put into this file. And then we are importing those in our inspect test. So now we run our unit test again. We make sure that passes. That's passing because we've added our database. And now we are able to, we're going to actually deploy our application and just passing in some parameters here, telling it where to put those outputs. And this takes a little bit of time, obviously. So this has been sped up so that we don't have to sit here and wait. And then once we have our stat created successfully, we can run our inspect test. And we have a successful inspect test. So we can see that the database has been added. The test is asserting the configuration is correct. We've used both our unit test to make sure our code is written correctly, and then we've used the inspect test to make sure that it's been provisioned correctly in the cloud. So I've got a couple more slides left here. I'm going to go through this one really quick. Drift is what happens when your resources are actually, they get out of sync from what your code says. So we want to make sure that we have ways to detect drift. And many of these infrastructure as code tools do not let you, they do not let you manage drift or detect drift of resources that they don't manage. So in the case of this example that I just showed you, I had an EC2 instance and an RDS database with related resources. But if I had any other resources in that account that are not managed under that code, I would not have any way to actually determine that my resources have drifted or are out of sync or out of compliance even. And so we can actually use inspect to detect that and to help us manage that. So again, like I mentioned earlier, like the security team can make sure that certain resources are configured in a way that is compliant. And we can do the same thing with how we expect our configurations to work as well. Now we've talked about all this testing, automated testing. You might be wondering, we have all these tests, what do we do with them? Today, your process might look like this if you don't have automated testing or if you're only finding your issues in production. You are waiting until it's actually in production before you are figuring out if it's working or not. And sometimes it might be that you haven't found that a resource isn't working or it's not configured correctly, but your customers have found it. And we don't want our customers finding our issues. We want to find them for them before they find them. So infrastructure as code, it plays a key role in our CI/CD. It relies on infrastructure automation to create consistent environments, and it lets us be confident that what we built works through each environment, each stage, and it's also going to work in production. So what we can do is we can actually add our automated infrastructure test to our CI/CD pipeline. We can iteratively develop, run our automated unit tests, run our integration tests, and then deploy our infrastructure itself, not just our application code, but our infrastructure through each environment, just like we would our application code. So by moving our infrastructure tests earlier in the pipeline, shifting it left, and doing it at every stage, we're going to find bugs earlier in the process. They're going to be cheaper and easier to fix. One last thing I want to leave you with is that we have our infrastructure code is actually code, so we should be treating it that way. We can code review it, version control it, test it, whether it's integration tests or unit tests. We can push it through our CI/CD pipeline as well. Testing is not ever done. We should be testing it at each stage of our stage of our development lifecycle. But if you're not testing in production, your customers certainly are. So that's one reason why we really want to have these tests earlier in the process, is we can catch them earlier, and it's going to be cheaper to fix. And that is all that I have today. Thank you for joining me. I appreciate you all being here early in the morning. Please give me a follow or shout out on social media. The link to the code is here at the bottom for the demo if you're interested in that. And if you have questions, please let me know. Thank you.
Thank you, Jenna. That was a great talk and something near and dear to my heart. We are a bit up on time, so for Q&A, if people wanted to take that to the chat, that would be great. Thank you again, Jenna. That was a great
absolutely. Thank you.
Yeah, thank you so much for coming on today. And with that, we have Andrew Kirkpatrick coming on next, and he is going to be teaching us about self-service PR-based automation with Terraform. Hello, nice to see you. It's like DevOps Days Toronto all over again.
Yeah, such a flashback.
Right? All right, I'll hand it over to you so you can get started. And yeah.
All right, fantastic. All right, well, welcome everybody. Hope that you're all having a good day. My name's Andrew Kirkpatrick, and I'm here to talk to you today about self-service PR-based automated Terraform. So maintaining your whole infrastructure using Terraform and reusable modules makes most of our lives just that little bit easier. But when those less familiar with DevOps want to create or update resources, you usually either have to train and enable them to use Terraform or handle the request yourself. However, what if you could offload the execution of those changes to a centralized tool and just review both the code and output being submitted for review? So Atlantis, Terraform Cloud, or M0 can act as a PR-based feedback loop for a hosted Terraform executor to make self-service just that little bit easier. So infrastructure as code solves some problems, but not all problems. So any of us that have to respond to kind of access requests, change requests, any kind of sort of general service stuff, you get the feeling of like being constantly bugged, emails, tickets, Slack messages, what have you. And that's great and all, but is it actually important that someone with infrastructure expertise carry out a lot of these day-to-day toil type regular changes? And if it's not, what actually is important then? In that case, primarily, that those changes are performed safely and securely above all else. And then secondarily to that, make sure that they're tracked against, say, either what an individual wants, a team wants, or what can be attributed back to, say, a specific project that people are working on. Since it's infrastructure as code, making sure it's codified in a reproducible way, so meaning that you can tell what was changed by who and when and where. And then just like any other PR-based process, making sure that that's peer-reviewed and then approved by an appropriate chain of command, whether that be other team members, whether that be management, security professionals, or those with budgetary control. And why automate Terraform? So a lot of people that will be watching this are quite familiar with Terraform as something that we run day-to-day from our workstations, but why would we want to automate that somewhere else? So a lot of us, whether you use Terraform registry modules or you write modules in-house, a lot of that abstracts specific logic away from people and hides complexity. But kind of one of the differentiating factors, say, using internal modules is you can start abstracting domain-specific or business-specific logic into those modules to kind of conceal some of that complexity from some of your, say, internal teams. And then if you created these kind of pre-built internal building blocks, how easy would it be and how comfortable would you be letting other people kind of build their own infrastructure out of these Lego pieces, as it were, that you've kind of given to people? And if you did, how would you validate and approve that the things that they're trying to do are valid or correct? So a possible validation step is kind of akin to a Terraform plan. So I want to see what you're trying to do, and I want you to also be able to validate for your own purposes that what you're trying to do is actually what you think you're trying to do. Also importantly, make sure that those changes are revalidated. So if you've made, like, put up a PR, this is what I plan to do, it's not quite correct, need some kind of mechanism that's built in to revalidate. If you say, in a PR context, push more commits up. So say, this isn't quite correct, keep revalidating what I'm trying to do until I'm ready to do it. In terms of approval, essentially you can just piggyback on whatever kind of peer review process you use with version control. So if you have specific requirements or checks in place to make sure that people are reviewing certain things correctly, you can essentially just follow that exact same workflow. So if you want to have code owners for specific parts of your infrastructure, if you need to mandate, X, Y, and Z, all of that can work pretty much the same as any other process you've got on GitHub, GitLab, or Bitbucket. So what are we talking about today?
Sorry to interrupt you, Andrew. It looks like the slides, it looks like there's a little bit of like ghosting that's happening with them, and just want to give you a heads up.
Very strange. How's that looking?
Oh, perfect. Much better. Thank you so much. Sorry about that.
Cool. So yeah, kind of whistle-stop tour of the things that we're going to talk about. So dive in very briefly into how kind of you could rework Terraform a little bit, maybe for self-service purposes, how Atlantis, which we use at Partner Stack, compares to, say, Terraform Cloud or M0, how kind of a pull request workflow fits in to a Terraform, and then how that also works in kind of a centralized execution context. Some examples of how some of these things works, and then advantages and drawbacks of adopting a workflow like this. Kind of looks like it's still happening. So keep going. So who typically develops with Terraform? So infrastructure engineers usually write infrastructure code, and application engineers normally work away on their applications. And that kind of typically results in an over-the-wall anti-pattern where, like, developers will, like, write applications, try and ship them over, and then do I need to quit and reshare? Yeah, can someone just double check that the slides are sharing correctly? Really can't tell.
Yeah, it seems like it's just having problems with repainting around the GIFs and the images, like when the slides change for some reason.
Give me one moment then, in that case.
No worries.
Oh dear. Alrighty. I think we're back. I think we're good.
Yeah, all looks good now. Thank you so much. Sorry about that, Andrew.
All right. Yeah, sorry about that, everyone. Firefox compatibilities. I blame that on. Back to Chrome. Alrighty. So who typically develops with Terraform? So kind of as I touched on, a lot of the times that results in a thrown over the wall anti-pattern in terms of like, I've developed this, I want you to make changes to this service, or like, I want these additional servers, I want to tweak to the database configuration, stuff like that. And there's kind of good reason for that, right? Writing Terraform from scratch is pretty daunting for people who've never done it before. Like a lot of us take for granted how HCL looks, but in a lot of cases, people find kind of the plethora of options and just the sheer amount of stuff available in documentation and in the public registry, kind of daunting. So could you kind of think, kind of counter to how some of the public modules that are out there, which are trying to simplify how you can roll out multiple resources, but how could you kind of conceal a lot of complexity away from some of the things that you roll out quite commonly within your infrastructure? So I kind of think of it in terms of how can you apply guardrails to make sure that people don't do things that you don't want within the context of what they're trying to do or within your organization. So I break out configuration for modules in that case for in-house modules to be individually configurable. So just standard variable, this is what I want, dynamically configured. So kind of based on either say string interpolation, ternary statements, map lookups, like things that you can infer from other configurations that are specified. And then things that are globally configured, say, this is what I want throughout my organization. They cannot change it. So it's always going to be this way. In terms of kind of how that actually looks, so let's say this is a reduction of a DigitalOcean droplet into, say, a module invocation. So I've kind of taken away a lot of the options that I want to be either consistent or things that I can calculate. And then how that translates back into the module. An example would be, I'm going to pick out the instance type based on kind of more simplified values for CPU and memory. I'm going to infer certain configuration options, such as like whether I want monitoring or backups enabled based on ternaries. And then say if I had complicated values, such as like VPC IDs or some kind of hash value that I don't want them to remember, I would say use a map lookup for that. And then just say whether it's in development or staging, we'll figure out the rest for you, just to kind of simplify it for them. So what options are there? Atlantis is the one that we use at my current job. I've used it for about 2 or 3 years now. But Terraform Cloud is like a very fully featured option, and M0 is a slightly different take on like kind of the Atlantis formula. So how do these compare? So Atlantis is, to my knowledge, one of the first applications to kind of do this. One of the main things that you have to bear in mind is that this is something you've got to host yourself. So it's a Go application, runs containerized. It responds to webhooks that are sent back from GitHub, GitLab, and Bitbucket. So that's kind of the only thing that comes into your infrastructure. And configuration is can be pretty complex. So you can configure it for multiple repositories, different projects within that repository to execute. And you can be pretty flexible with the workflows that you apply to that. Terraform Cloud, on the other hand, runs either entirely in the cloud, entirely on-premise, or a hybrid with agent pools. You also get your own private Terraform module registry in there. So you can start splitting stuff out a little more kind of distributed that way. The enhanced backend for remote state allows you to do some pretty cool things, including remote operations. So I run locally execute remotely. So that kind of works nicely with people being able to develop some stuff and then handing that off to then execute in Terraform Cloud later without ever actually running things on their workstations. And the concept of workspaces works slightly differently to traditional Terraform. So one of the benefits of using Terraform Cloud is there's a whole lot of other stuff that you can do in there, and there's a whole load of different workflows that are supported. So as well as PR based, you can power this from an API command line interface. The confirmation step actually also happens outside of, say, a version control system, even in a PR based workflow. So there's a very nice interface to kind of show you who's applying what, who needs to confirm, who's applied. So the auditability of this is slightly better than the other two options. There are a lot of neat features that it supports. So preventing destroys might be something that's quite desirable, and hooks into other systems such as Slack. Like there's a lot more integrations that are available out of the box with relatively little effort. I haven't dipped into these options in particular, because originally I looked into this a few months ago. But there are lots of kind of different things that Terraform Cloud is coming up with to keep in line with Terraform development, which are pretty cool. In terms of some of the gotchas, one of the things I came across is that symlinks aren't necessarily supported. I think it's potentially how like your code is cloaked down. And one of the other gotchas related to that is it only supports, or last time I checked, it'll only support an enhanced backend. So if you're trying to use something in an S3 bucket or a GCS bucket, it won't work straight off the bat and treats it as net new. But the process to actually migrate state in there is actually pretty simple. It's just a gotcha to be aware of. M0, on the other hand, it's kind of, I would liken it to more on-demand type infrastructure. Well, that's kind of the way that it seems to be built and seems to be sold. So you create organization templates from version control from a repository. So like this is a master copy of a set of stuff that I want people to be able to deploy. And then you can deploy that out to kind of like 1 to n workspaces. So you then kind of create project environments based off a project template, and you kind of like just clone and clone and clone and clone. So a good example of this would be, say, if you want people to be able to have ad hoc developer environments. I think it's probably like a really good use case for this. It has native Terra support for people who prefer that kind of workflow, and how custom you can get the workflow is pretty similar to Atlantis. You can do a lot of different stuff, and they have different language support if you want to get really funky with how that executes. In terms of the project templates, so you can kind of specify what branch you have in BCS to be monitored for pull requests against when you create an environment. You can also set specific destroy times, which is kind of handy. The environments themselves, you get kind of a nice interface that shows you like what has happened when deploys and redeploys have happened based on different triggering events, such as PR plans, stuff like that. As I mentioned, you can set time-limited environments to say, like, I want my development environment up for a day so I can quickly test this feature. So you can literally spin it up. It'll auto-destroy, which is quite nice. And then it has cost settings that are also built into that. So you can see like how much certain people are spending on certain things. And you can also limit how many environments they can spin up at any given time. In terms of the gotchas, state itself is managed entirely within M0, or it was the last time I tested it. So you can't kind of have a hybrid workflow between you developing locally and doing some of the stuff in M0. It kind of likes to manage that whole workflow end to end, which is fine. It's just you kind of have to be aware of that. And the whole thing kind of works off the concept of workspaces. So like it's very much like a 1 to n type system rather than specifically project and directory layout. In terms of configuration, there's pretty good support for all the kind of usual stuff that you'll have. The only additional thing that Atlantis can support, because it's self-hosted, is you can inject files and reference like any kind of file-based configuration you need to locally within an image. So if you need to build a custom image, mount config maps or secrets onto the container, stuff like that. In terms of an actual pull request workflow itself, so one common question is, why don't we use continuous integration for this? And that kind of breaks down for me into 3 kind of problem areas. Some of this is covered in Terraform documentation as a kind of like age-old problems of how do you synchronize plans and applies based on like commits, future commits? Do you discard, do you keep going? How do you approve what someone has done, and how does that fit, say, into a deployment pipeline? And based on file changes, what are you actually going to like try and change? How do you figure that out? So it's kind of difficult to explain the plan and synchronization problem. So I kind of decided to draw a diagram for this presentation. So like if you were to put, say, something into a branch, whether it be main or a feature branch, if you did a Terraform plan off of that and then subsequent commits came in, do you then discard the older plan because you consider it to be out of date? And if you don't discard it and you then applied it, what if future commits came in? Do you then abort that apply because that's now based on out-of-date code in that branch? Or do you keep track of the plans? And if you had, say, multiple machines in a CI environment, do you copy these plans between things so they can be executed correctly? It's not a major problem. It's just something to be aware of. How this kind of happens with this, with these tools, is execution locking. So making sure that for a given project or workspace, depending on terminology, you can only do one set of things at each time, so everyone queues up to do their thing. So just to try and make sure that you kind of keep things consistent. In terms of how that looks in Atlantis itself, it actually locks the pull requests and then locks any kind of activity on it and will reference you to other pull requests that are stacked up in the queue and keep separate Atlantis locks in addition to Terraform state locks. In terms of actual approval, there are some CI tools that have manual approval steps, but do you want to essentially like hold on to a pipeline if you're waiting for approval? Like as in the context of, say, a deployment, you'd probably be waiting minutes, maybe hours, but in terms of, say, an infrastructure change, you could be waiting hours or days. So it depends whether that really makes sense for something that's supposed to be short-lived. in say like CI runners. That's kind of a tricky thing. Like you could probably work something into Jenkins, but these tools, I would argue, have kind of a simpler way to do it in the context of PR. In terms of how that looks, say, in feedback, you essentially get the outputs of Terraform plans and Terraform applies with Atlantis and N0 posted back to the PR, so you can see it as just as if it was a terminal. And then Terraform Cloud and Atlantis both respond back to say, like, as a VCS status check to go, like, this is what I'm doing right now. You're either allowed or not allowed to proceed based on like what I've done in the background. In terms of reply requirements, like if you have specific requirements that you want to be in place for like pushing through PRs, then that's kind of like the workflow that's, like, say, we enforce in Atlantis. So if I want to make sure that this is approved by everyone I've said in GitHub can approve it, Atlantis will respect that and prevent you from applying things based on those requirements. In terms of centralized execution, where does the actual execution happen? So in a lot of cases, this either happens in the cloud or in your infrastructure, but in a central place. And that's kind of important to bear in mind because that determines how you issue credentials. So instead of different credentials for different providers being issued to individuals, say on platform team, infrastructure team, SREs, you're now issuing it to service accounts that are being dished out to a central place. And there are pros and cons to that. Of course, that can be desirable or not desirable, depending on how granular you want to be. But you then also have to think, I've got multiple providers now. Like, what permissions do I need to give specifically? You know, would I grant more or less permissions to a central executor that works on a PR basis that multiple people can access versus what I would give out to site reliability engineers? For example, you might not want that to be one-to-one. You might want to have that be a subset. That's just something to consider. In terms of how you map this is kind of like a simplistic example of, say, how I mount Atlantis configuration into Atlantis on the right, and then how I pass specific credentials on the left. Like, obviously, it's not how I would actually recommend you necessarily do it, but like there are good options for this, like Kubernetes external secrets, HashiCorp vaults. But there are various ways to get credentials into like a central executor, depending on which option you choose. In terms of execution, one thing that some people have is, say, like, my workflow is not strictly just a planner apply. I do other things in between this step and that step. Like, I get custom tokens for this, or my token will expire in between the planner apply. How can I support that? Atlantis and M0 are slightly more customizable in that regard. Terraform Cloud, less so. That's kind of more of a stock standard Terraform experience, which is not necessarily a bad thing. It's just something to consider. So one of the weird workflows that I did for a job a little while back was we had a multi-factor authentication requirement to one of the roles that was actually tied to the server's account. We didn't have time to refactor it out. So I essentially like used a Python script to generate a multi-factor key, pipe that back into a Terraform command, and then overrode AWS credentials to get that to happen. So I basically got it to pretend that it had a 2FA device. But you can do those kind of things if you want. Not that you should, but you can. So how does this actually look? I've talked an awful lot about stuff, but how does this kind of look in practicality? So say if I wanted to delete a DNS record, I would add that standard kind of get stuff, and I'm going to push that up and then create a pull request for it. So you can see the Atlantis UI on the left. I'm going to jump into GitHub here, create a pull request for it. And then the first thing that's going to happen is one of the checks will execute. Atlantis will try and plan it. It will comment back saying what it's going to do. So that's going to look like standard Terraform output. Yeah, okay, I want this record created. Great. Apply it for me. First thing it's going to do is reject it based on the apply requirements that we talked about. So it says, like, you can't do this. You need to go and get someone to approve it based on like your repository specific settings. Someone approves it. I comment back Atlantis apply. It applies for it. And then based on the repository configuration, I said, like, once all that's gone ahead, like, I've got Atlantis to merge it in, and then that will automatically that branch will get deleted. In terms of how the locking looks, so say we've got one PR on the left where someone's removed the record. In a subsequent branch that I'm going to push up on the right, I'm going to try and add it back. So we've now got two concurrent PRs trying to access the same project. So Atlantis has locked that for us. You can see we'll get back a comment, and that's reflected in the UI where it says, this is locked. This PR is ahead of yours, so they're either going to have to go first and apply their changes and close their PR, or they're going to have to discard, which is essentially like giving up their place in the queue to let you go first. They can then subsequently like replan and apply later. In terms of how this looks in M0, as I said, this is kind of me creating an environment based off a project template. So I've gone with an ad hoc workspace name. So this is just kind of creating another workspace kind of layered on top of this directory. But as mentioned, this is all kind of contained within M0. So like this kind of doesn't exist outside the context of M0. But my project template specifies that I want to create 2 buckets. It's just going to go through that and go, all right, I'm going to make 2 buckets for you. Good to go. In terms of how that works, come on. It's always one video, it doesn't load. There we go. So let's kind of modify this in a feature branch. I decided my project environment would have like the target branch for this PR set as the watchable branch. So I'm going to set that as the base. I'm going to remove one of the things in there, put that up for PR. You'll see that M0 then comments back. And we'll say like there's a PR plan in process. So you kind of flow through that. Similar kind of output. It'll comment back. Similar to Atlantis, this is what I plan to destroy based on the changes that you made. The main difference between Atlantis and M0 or Terraform Cloud is whether you do things pre or post merge, which is a preference thing. So this has said, all right, plan looks good. Your PR has been approved. Now that it's been merged, now I'm going to do stuff. Like this has an approval step within the UI, so similar to Terraform Cloud. So I'm going to go and approve that. And then everything runs through. So those changes are in the branch that I had set to watch. That's all rolled out. In terms of how that looks in Terraform Cloud, relatively similar to M0, but more similar conceptually to how Atlantis works. So this operates on your repositories and state as it would normally. I'm just going to create these couple buckets. Confirmation step exists in the UI, similar to M0, like you get linked out to their respective UIs from the PR by the feedback that you get on there. In terms of how it works with Terraform Cloud in the context of a PR, kind of similar. So we're going to commit changes back, delete this record, push that up. So like very rinse and repeat at this point, everything should look relatively familiar. The only difference is there's less information that Terraform Cloud pumps back into the GitHub UI itself. Only the status check will respond, but you then get kind of pushed back to here. This is what I'm going to do. Like need to make sure that this gets approved. All right, approved, good to go. Let's squash and merge that. That then gets detected in Terraform Cloud. You can go back to the runs and you'll see that it's like now planning, now that it's been merged into the branch that it's been told to watch. Confirmation step as well, make sure that we're good to go. And then that gets rolled out. All right, so what are some of the advantages and drawbacks of using a system like this? So some of the advantages of if you've got people that need to do little pieces of infrastructure work from time to time, it means they don't have to get everything set up. They don't have to be issued credentials for each of these things. They can just clone the repository down, follow some basic instructions, put up a quick PR and get what they need to do occasionally done from time to time. It also means you get peer review before execution, which is kind of handy depending on your workflow. Because it's kind of VCS integrated, that potentially ties into other automation. So if you've got things that are tying into GitHub, GitLab, like plays quite nicely with that. It potentially simplifies what you're doing with credentials because you don't have to issue as many. Well, there's obviously a flip side to that. And depending on how well developed your peer review process is, it can potentially kind of alleviate a lot of the bottlenecks of, I need this stuff to be done. Let's just like keep throwing that over to, or keep getting this team to do it. So you can automate some of the toil away. But then subsequently, some of the disadvantages are you kind of saw the feedback cycle that you get versus developing locally is quite slow. So that means it's less ideal for developing modules or prototyping out some functionality. You might still want to do that locally, say like a platform or infrastructure engineer. Because you're moving the security controls from, say, your respective providers to your version control system, that's potentially an issue depending on how well developed that is or how complex you need that to be. And that then also means there's something somewhere, whether that be in your infrastructure or in the cloud, that has a bunch of credentials that allow you to access everything, which is more or less of a concern depending on how that plays out. If you're self-hosting it, it's something else you've got to maintain. And it can potentially be problematic if you're running on the same infrastructure as it controls. Like you destroy the thing that Atlantis is running on, for example, which I did once. So in summary, just to quickly wrap up, sorry for technical difficulties earlier. So Atlantis is open source and free to use. So that's one of the big benefits to it. And you can self-host it, very customizable. And that's a pro and a con to different people, right? So you can do a lot with it, but it's still something you're going to have to look after and babysit to make sure that it keeps working. One of the biggest benefits for me is that it does applies pre-merge. So that's one kind of mechanism that's nice to prevent potentially broken codes making its way into master. But I've spoken to other people don't like it that way around. So that's very much a preference thing. M0, I think, is a really good solution for ad hoc infrastructure. Has a well-supported UI and workflow for that, and it's very customizable in terms of how that works and executes. Terraform Cloud, on the other hand, is, I think, the big bad enterprise solution. So there's so much more than what we talked about here that you can do with that solution. And even in the context of PR-based workflows, provided you're doing something more in line with standard, I think it's a very, very good solution for that. It's very clear what's going on. The auditability and practicality of a platform like that with all the integrations it's got is far outclasses the other two, but for a lot of people, it's potentially far more than they'll ever need and far more complicated than they'll ever need. So I think each one of them has their pros and cons and suits a potentially different use case. Thank you very much for listening. I'm Andrew Kirkpatrick. I work at PartnerStack. We're almost always hiring, as a shameless plug. But yeah, hopefully there's any questions I can respond to in comments. I went slightly over time due to my Firefox problems, so I apologize for that. But thank you.
Hey, Andrew, thank you so much for joining us today. It's great to see you. And I mean, is it really a live session if something doesn't go wrong during the stream? Unclear.
Right.
But yeah, I think we are out of time to do Q&A right now, but there is a couple questions, it looks like, in the YouTube chat. So if you're open to answering them there, we'd really appreciate that, and that'd be great. And yeah, thank you so much for joining us today.
And yeah, up next, we have Amar Malik, and he is going to be talking to us about using HashiCorp Vault to manage secrets for a retail client. Thanks for joining us this morning.
Hey, thanks, Jason. Thanks, Jackie. Can you hear me fine?
We hear you good. We'll turn the floor over to you.
Sounds good. Thank you. Yeah, so I'll try to bring us back on schedule because my talk is a bit shorter. I'm here today, very excited to talk to you about how we're helping one of our wonderful clients, retail client, truly unlock the power of Vault Enterprise. So, I'm Amar Malik. I'm from Accenture, and we've been helping our client for a couple of months now. And just a bit of a profile on this particular customer. They're a retail client. They're well underway on their cloud transformation journey. And they're using the HashiCorp stack quite a bit. So not only Vault, but they're also using Terraform, Consul, Nomad, and they're experimenting with some of the other open source tool sets. In terms of their workloads, it's their applications are very resource intensive. A lot of consumers are actually leveraging their applications from a client facing perspective. But in the back end, those applications are using open source Vault to consume the secrets. And so about earlier this year in the summer, the client had a business requirement to move from the open source Vault to the enterprise Vault. And that was for two primary reasons. One was they were looking for more high availability, as well as disaster recovery in their service. So they were using open source for a number of months and even a couple of years, I would say. They saw that more and more of their applications were starting to consume and leverage this central platform, which is Vault. And they realized that this is becoming a critical service, and so it's better to have high availability and disaster recovery in place. So that was one of the business drivers to move towards Enterprise Vault, and the other one was the concept and ability to use namespaces, right? So again, one of the key tenets of this particular client's cloud transformation journey was self-service and autonomy. And so, they wanted to really unlock these two main features of Enterprise Vault, and they engaged Accenture to help with this journey. So I'll go into a bit about those business drivers, again, DR, high availability, and the namespace. And then I'll talk about how we help them do this implementation and migration off of open source to enterprise fairly quick in a short time frame. So from an HA perspective, we followed the recommendation from HashiCorp in terms of their multi-cluster architecture, and so we had 5 Vault nodes distributed across 3 availability zones, right? And with this architecture, the client would be able to sustain a failure in a loss of 2 nodes within the cluster or a loss of an entire availability zone. And the way we designed and implemented it was using auto scaling groups, and we had designed it in a way that if a node were to go down for whatever reason, the auto scaling event would kick off and the node would rejoin the cluster automatically, right? At the back, in terms of the backend storage, the storage was using integrated storage, whereas their current open source was using console. However, in the enterprise version that we were implementing, we decided to go with integrated storage. Right, and that again for a number of reasons. One being that it's less administration and overhead in terms of managing the overall solution, and it supports some of that failover and multi-cluster replication a bit easier than what console offers. And of course, we had backups there. We had backups of the wrap storage. Not only we had it on a daily as well as a weekly basis. And so, having that HA kind of set up with the integrated storage, that did allow us to cast a safety net in case that, this critical platform were to go down. We have a recovery mechanism. And from the DR perspective, that's a big reason why enterprise customers even go down this path is so they have disaster recovery replication. And so the way we designed it was, again, this is all running on AWS. Sorry if I didn't mention that earlier, but this is all cloud ready. They're heavy users of AWS. And so from a DR perspective, we mirrored the 5-node cluster architecture from the primary region to the secondary region. And we did our testing to ensure that that data is synchronized, and auth methods, policies, and some of the basic stuff, those were being replicated as well. From a namespaces perspective, again, trying to achieve and really unlock that self-service and autonomy, there was a business decision made by the client to kind of start opening this up, right? Again, from where we're starting, which is open source, it was centrally managed by one team. There was a bit of a bottleneck, I would say, as well. And with the namespaces, we wanted to really open it up, right? And give the opportunity to the application teams to manage their tenant of the vault, right? So with that, I would say, it did work out well, but there's definitely some lessons learned that I want to share with you as well. One of the lessons learned is that we can't open the floodgates necessarily for everyone to start using their namespaces, right? So we had a pretty rigid onboarding process so that the app teams actually had to prove that they had the experience within their teams to manage namespaces, right? But I would say it's a very great feature of the Enterprise Vault because it does reduce some of that bottleneck and that single point of failure from the teams. In terms of how we implemented it, again, I think the point to be made here is that it was automation was a key component to the implementation. We were able to deploy the entire solution plus the testing plus the onboarding in a fairly short amount of time. And I would probably attribute that to one is the codification and deployment through Terraform and the integration with AWS. So we were able to spin up our entire Enterprise Vault environment in multiple kind of iterations, and we were able to test it. And if there were any issues, if there were any changes in the requirements, we were able to demonstrate to the client fairly quickly through this pipeline that we had built. The other thing to call out in terms of the actual implementation journey was the bootstrapping of the EC2 instances. And so we had configured it in a way that if a node were to die in the autoscale group, that a new node would spin up with the right configurations, with the right certificates installed already, and with the ability to join the existing cluster. right? So there was some automation already built into that, and that proved to be very effective when we were doing our testing and our demonstrations to the client. And then the other thing from the implementation perspective, which we didn't have in the open source, and we tried to do in the enterprise, was the monitoring and alerting, right? So again, we use the cloud native capabilities in AWS, like CloudWatch, to have pretty much interactive dashboards and have a health check over the status of Vault, right? And so this was something that the client wanted, and we delivered that pretty effectively. And that was really the base implementation. So again, it was very quick. The next piece, probably the more difficult piece, was to get the end users to start using the enterprise vault, right? And from there, it was the onboarding procedure. There was a lot of, I would say, curveballs in our journey, to put it lightly. But we had to onboard them fairly quickly. But it was a bit of an emergency onboard. I'll be quite honest there. But in terms of the migration, we were able to copy across, with the root token of the open source vault, we were able to copy across policies and key value engines. And then, the thing that was outstanding, or where we had to interact and talk to the app teams quite a bit, was for the auth methods, right? So that's a bit about the migration journey. I want to leave you with a couple of lessons learned here in our engagement that we had with this particular client. The first one is the key management, right? So again, in the open source version of the Vault, the client was using Shamir secret keys, and there was multiple key shards. I think even in open source, you have the ability to integrate with the cloud key management system. So I think the process for Shamir is good. It's a manual, but it can become painful, right? If you have many vault clusters and you have many holders of the keys, and so if there's no real reason that's holding you back from using auto unseal, I would definitely recommend it, because it just makes it so much easier, right? When you want to upgrade, or when you want to do a migration like the one I just spoke about. So that's one thing I would highly encourage and recommend, to use that auto unseal capability. The other one is backups, right? Like, again, this is something that we often forget about, or we don't really pay too much attention to, but make sure to validate those backups. Because we sometimes think that we have the backups, but they might not necessarily be in working condition. So review the backup schedule, make sure that your backups are there and they're working. And then is to have a onboarding layer, right? So wrap some governance and onboarding processes around the Vault environment, right? So people should not be getting access to things that they don't need to. Even if that access is being provisioned, we should have some sort of mechanism to review that access and deprovision it in an automatic manner. And then lastly, I would say, avoid some of the anti-patterns for Vault usage, because we've seen time and time again, people are using, from an app role perspective, using role ID and secret ID, and they're hard coding it into the application itself, right? So we want to move away from that. We want to use ephemeral secrets as much as possible. And so that's something I would say, it's definitely worth doubling down on and focusing on that with the client. So that's that. That's all that I want to discuss about. And we did have a lot of lessons learned out of this engagement and this opportunity that we had with the client. Great being here today and speaking with you. I will, if there's any questions that anyone has, feel free to reach out to me on LinkedIn. That's probably the best way you can get a hold of me.
Great. Thank you so much. Thank you so much. I love a good story from the road. Yeah, and again, questions in the YouTube chat would be the best part, or via LinkedIn, as Amar said. So thanks again for joining us. Over to you, Jackie.
Yeah, thank you so much for joining us today. And I'm excited to welcome up our next speaker, Shai, who will be talking about debugging production applications in Nomad using Lightrun. Hello, welcome.
Hi, how are you doing? I love
We're
the
doing
shirt, Jason.
Thank you very much.
So I'll rush it a bit because we're obviously in a hurry. I'll try to talk faster than my normal pace. So, hi everyone. today I'm going to talk about debugging Nomad applications in production and about APMs. So, but first, a few things about me. I was a consultant for over a decade, worked at Sun, founded a couple of companies, wrote a couple of books, wrote a lot of open source code, and currently work as a developer advocate for Lightrun. My email and Twitter accounts are listed here, so feel free to write to me if you have a question, you don't get a chance to chat to me about it. And also follow my blog, talktotheduck.dev, which isn't about ducks, but mostly about debugging and stuff. So I want to start talking about APMs. I love APMs. They're wonderful. I'm old enough to remember the time when they weren't around, and I'm so happy that we moved past that. These dashboards are absolutely amazing. You get this great dashboard with everything you need, and we're truly in a golden age of monitoring. When I started programming, monitoring was just walking up to a server and kicking it to listen to see if you can hear the hard drive making a noise. And this is such a huge improvement. So today with Nomad, deployments are scaled to a level where tools like this are essential. You literally can't deploy without some sort of monitoring in place when you're doing stuff at that scale. Without an APM, well, I'd like to say we're blind as a bat, which, well, obviously bats aren't really blind. That's a myth, but it's a sort of point time recurring through this presentation. So a lot of the issues we run into are as a result of anomalies we see inside the dashboard. We see spikes or failures or something that performs a bit too slow, and the APM is really, really amazing in showing those sort of hiccups. But this is sort of where it stops. It can tell us that a web service performed badly or failed. It can't tell us why. It can't point at a line of code. So let's stop for a second and talk about a different line, this one. On the one side, we have developers, and on the other side, we have the ops or DevOps. This is the line that we've had for a long time. It's something we drew out of necessity because when developers were given access to production, well, I don't want to be too dramatic, but when developers got access to production, it didn't end well. This was literally the situation not too long ago. We had sysadmins, but the whole process used to be a mess. That was no good. We need a better solution than this hard separation because the ops guys don't necessarily know how to solve the problem made by the developers. They know how to solve ops problems. So when a no-band agent has a problem and the DevOps don't know how to fix it, well, it starts a problematic feedback loop of test, redeploy, rinse, repeat. That isn't ideal. So monitoring tools are kind of like the bat signal. Remember, I said I'll get back to this. They come up and we, the developers, we're Batman or Batwoman or Batperson. Everyone's welcome. Damn heroes, that's what's important. And we step up to deal with the bugs and last line against their villainy, so to speak. Well, coder bat people, really. Kind of the same thing, just without the six-pack abs, you know, the kitchen here, all the sweets. You get my drift. So coder Batman needs to know where the crime or bugs are actually happening in the code. So these dashboards, they point us towards the crime existing in the general direction, but it doesn't really tell us where the problem is. And this is where things get hard. We start digging into the logs and trying to find the problem. The dashboard sent us in a general vague direction, like a performance problem or high error rates and stuff like that. But we need to jump into the logs and hope that maybe we can find something there that will somehow explain the problem that we're seeing. That's like going from a jet engine back to Stone Age tools. There are many log processing platforms that do an amazing job at processing these logs and finding the gold within them. But even then, it's a needle in a haystack. That's the good outcome. where a log is already there waiting for us with an answer. But obviously, we can't have logging all over the place. Our billing will go through the roof and our performance will, well, it will suffer, putting it mildly. We're stuck in this loop of add a new log, go through CI/CD, which includes the QA cycle and everything. This can take hours. Then reproduce the issue in the production servers with your fingers crossed and try to analyze what went wrong. Hopefully you found the issue, because if not, it's effectively rinse, repeat for the whole process. In the meantime, you still have a bug in production and developers are wasting their time. There has to be a better way. It's 2021 and logs are the way we solve bugs in this day and age. Don't get me wrong, I love logs. Today's logs are totally different from what we had even 10 years ago. But you need to know about your problem in advance for a log to work. And I'm not clairvoyant. When I write code, I can't tell what bugs or problems the code will have before the code is written. I'm in the same boat as you. The bug doesn't exist yet. So I'm faced with the dilemma of whether to log something. And this is a bit like the dilemma of writing comments. Does it make sense, look noisy or stupid, or will I find this useful at 2 a.m. when everything isn't working and I want to rip out the few strands of hair I still have here? So it's a production problem. So debuggers, they're wonderful. I love debuggers. They let us set breakpoints, see call stacks, inspect variables, and so much more. If only we could do the same for production systems. But debuggers weren't designed for this. They're very insecure when debugging remotely. They can block your server while sending debug commands remotely. A small mistake, such as an expensive condition, can literally destroy a Nomad agent in an instant. I might be repeating an urban legend here, but 20 years or so ago, I heard a story about a guy who was debugging a railed system located on a cliff. He stopped at a breakpoint during debugging, and the multi-million-dollar hardware fell into the sea because it didn't receive the stop command. Again, I don't know if it's a true story, but it's plausible. And that's really, we believe it can happen, and stuff like that does happen if you try to debug things that matter. Debuggers weren't really designed for situations like production debugging. And worse, debuggers are limited to one server. If you have essentially a Nomad cluster, many agents with multiple machines and a complex deployment, a problem can manifest on one agent. It might manifest on all of them. It can be anywhere. And you're really relying on luck of the draw when you're looking at the deployment. So if we have multiple servers, multiple agents with multiple languages, platforms crossing from one to another with a debugger, well, it's possible in theory, but I can't even imagine it in reality. Definitely not in the scales that we see our deployments. So let's take the Batman metaphor all the way. We need a sort of team up. We need some help on the servers, especially in a clustered polyglot environment where the issue can appear on one Nomad agent, move on to the next, etc. So you remember this slide. We need some way to get through that line, not to remove it. We like that line. It's a good line. We need a way to connect with the Nomad agent and debug it. Now, I'm a developer, so I try to stay away from management buzzwords and that stuff, but the word for this is shift left. It essentially means we're letting developers and QA get back some of the access we used to have into the ops without demolishing the gains we had in security and stability. We love the ops people and we need them. So this is about helping them keep everything running smoothly in Nomad without stepping on their toes or blowing up their deployment and, getting everything to work nicely. So this leads us here. What if you could connect your server to a debugger agent that would make sure you don't overload the server and don't make a mistake like setting a breakpoint or something like that? That's literally what Lightrun does. Now, I'd like to take a short moment to mention the term agent. A Nomad agent is used to describe the process running. It's the same for Lightrun. So when I say agent, I will qualify it with Lightrun or Nomad for clarity, because it might be slightly confusing. So how does this thing work? Well, we install the Lightrun plugin in our IDE and let it interact with the Lightrun server. We can insert an action, which can be a log or a snapshot or a measurement metric. I'll show all of these soon enough. This talk will go into the code portion soon. Notice that the Lightrun server can be installed in the cloud or as a SaaS or on-premise and managed by ops. The management server sends everything to the Lightrun agent, which is installed on a Nomad agent. That means there is a clear separation between the developer and the production. The DevOps still has that guarding line we're talking about, and we don't have direct access to production. That means no danger to the running production servers from a careless developer, well, kind of like myself, sorry. The Lightrun agent is just a small runtime you add to your Nomad agent. It's very low overhead, and it implements the debugging logic. Finally, everything is piped through the server back to your IDE, to the developer IDE directly. So as a developer, you can keep working in the IDE without leaving your comfort zone. So I'll demonstrate a to-do app. I want a better demo, but trying to run and explain a true polyglot microservice environment in a conference session will probably confuse all of us more than it will teach. And frankly, with the amount of time I'm happy I picked a simple demo. Myself included, I'd also be confused. So this is all good. The front-end code connects to a Node.js server. This is actually a pretty sensible architecture. It lets the front-end guys handle all their stuff, including the start of the back-end area. And Node.js scales reasonably well and can handle stuff it's good at, communicating with the UI front-end, etc. Storage, transactions, and reliability are decades ahead in the world of Java. So using Spring Boot for the back-end heavy lifting also makes sense. A merge of the best each world has to offer. It also lets us hire the right people for the right job. So we start by signing up on Lightrun.com. Then we can set up the Agent ID plugin, which lets us debug this application. Next, we need to connect the Lightrun agent into individual Nomad agents. Now, this is where it gets interesting. For the Java code, we can use the Lightrun driver for Nomad. This is explained in the docs, so I'll just touch it briefly in general. The Lightrun Java driver accepts all configuration options of the Nomad Java driver. So to get the driver working, we need to download the Lightrun driver repository, find the Lightrun Java driver in the repository root folder, copy the driver to your Nomad plugins directory. Then, when running the Nomad agent, we need to specify the path to the plugin directory. The Lightrun Java driver accepts all configuration options of the Nomad Java driver. We just need to add Lightrun Java as a driver to our job file. Then we need to set the secret that we got from the Lightrun administration server. That does it for the Java driver. We don't yet have integration for Node and Python, but the integrations there are simpler since they can be done in the code level. And you don't need a driver like you do in the Java portion. So you can just follow the instructions on the Lightrun website and will work with Nomad pretty seamlessly. So it's really easier in some regards. So now that this is working, let's go to the simple to-do app used by so many demos in the past. Now, the funny thing is that I was going to demonstrate something completely different and ran into this bug accidentally as I was working on the code. Well, opportunity knocks. I can't clear completed to-do items in the app. Well, it's time to pull out the debuggers and figure out what's going on. The only problem is that these are two servers running on remote containers in production. I can't just debug them. So let's look at the code and see if I can spot some problem. Now, this is the method that implements the clear completed in the Node server. I assume we all know how to debug the client, so I didn't really show that part. But even if we don't, the technique would instantly show if the problem is in the client. You'll notice that we don't have any logging here. That would have been really nice, but obviously we can't put logs everywhere. Besides the huge cost of logs at scale, this also costs in performance on the individual machine, so I'm not a huge fan of overlogging. So I already installed Lightrun on both servers here. I won't go into the install process since it's trivial and we don't have much time. I also have Lightrun installed in my IDE, so I can just add a snapshot to the method to see if it's even reached. A snapshot is like a breakpoint. It gives us the stack trace and the variable values, but it doesn't stop the debugger in place. So a production server won't block on a snapshot. The camera icon we see on the left is the line on which we set up the snapshot. But we also want to see the end of the method was reached. Did we return from the method? If only there was a log. Well, we can inject new logs in runtime. We can just add a new log and type in the details we want in that log. And bam, we can see the log right here. The cool thing is that if you have built-in logs, the log will be integrated with the rest of the logs, so you can see it in context. In this case, I selected that the log will pipe into the IDE console, which is more convenient for demos and quick tests. But when you do this in real life, viewing the log as if it was written in the code is a game changer that can literally save you millions. And in my opinion, logging is debugging. So the ability to inject logs is literally debugging enhanced. Now, let's go back into the browser and press that dysfunctional button. Then go back into the IDE and wait a couple of seconds for the whole loopback of events to reach us. Now we can see the snapshot was hit. That means the calls reached that method, which already eliminates a lot of potential problems. Now we can look in the stack trace on the left to see who invoked that method, or look within the variables on the right to see if there is an interesting variable we missed. We should also check out the log console where we can see that the method reached the log line. So we didn't get an exception or some other problem. This is odd. Let's check the Spring Boot server. So this is the Spring Boot server code. Notice this is Java code representing a REST request for the clear completed API. It deletes all the elements that are marked completed, then returns the to-do items that remain. So I want to add a log here, just like I did in the Node.js code. But in this case, I'm going to do something a bit different. I'm going to add an expression to the log. I'm going to print out the number of items in the response variable, which is a type of the list. That means I'll literally invoke the size method on that object within the curly braces here. Now, you might be thinking, why not print the whole thing? Why not print the response object? Well, it won't work well. There are two reasons. First, it might output too much text and get cropped. But the more important aspect is evaluation speed. When we're running in a production environment, changes can be very dangerous. If we evaluate these expressions dynamically, it might take too much CPU and crash our server. So Lightrun limits the amount of operations you can do in an expression. If I'll print that list, Lightrun might just eliminate my log because of CPU usage. So the code here needs to be very efficient. So let's press OK and go to the browser to trigger the event. I'll press clear completed again, and then we'll go back to the server. So back in the server, we can see the log showing, and that's weird. The API is showing that we're returning 2 elements. That doesn't make sense. But this is the core idea of debugging. Validate your assumptions. I don't get that. I want to check the values. So for that, I'll need to edit the log entry, and instead of listing the size of the list, I want to print out the content of the first element in the list using the getZero method call. Pressing OK deletes the current log and creates a new log object in its place. We now need to go back to the web and clear the completed elements again. And after a short wait, the log prints out the result. It seems that this is the bug. Looking at the values for the object, it's obvious that the completed field is false on the server. That's why it wasn't cleared. With that in hand, I looked at the code that toggles the completed field on the Node.js server, and oops, it seems that code was never written. The completed field was only set on initialization, so that's the bug. That's very cool, but that's just one type of production problem. For a different production problem, let's go back to the slides and look at one of my first slides. So this is a dashboard I found off Google. It isn't mine, but you probably see a couple of interesting things here. I mean, what's this? What the hell happened here? If you use a dashboard, you probably see stuff like that all the time. And ask yourself the exact same question. Now, APMs are pretty sweet. They will usually tell you which entry point caused a performance issue, which CPU worked too hard, where memory was used up, and all that, those sort of things. But what they don't tell you is which block of code took too long. Let's say we have an entry point that takes too long to perform. Now what? We need to review deep calls all over the place to try and pinpoint a specific operation. This might be something we can't reproduce locally. Let's go back to the IDE briefly and go over the options here. In the metrics menu, we can add measurements that give us fine-grained benchmarks on the code level. We can count the number of times a line of code was hit. We can measure the duration of a block of code or a method. We can even add more complex metrics based on custom evaluation. The result of the metric can be periodically logged or piped into Prometheus, StatsD, etc. This provides that missing piece that we need to see beyond what the APM provides us. That way, we won't spend ages optimizing the wrong area because the production information didn't include all of the lower level information. Please notice that at this moment, measurements are only available for JVM languages, but they will be coming to Node.js and Python in an update that's coming really, really soon. So in closing, I'd like to go over what we discussed here and a few things we didn't have time for. Lightrun supports JVM languages like Java, Kotlin, Scala, etc. It supports Node for both JavaScript and TypeScript code, and Python, even complex stuff like Airflow, which is really, really cool if you need those sort of things like Kafka and stuff like that. Really cool. When we add actions, conditions run within Sandbox so they don't take up CPU or crash the system. This all happens without networking, so something like a networking hiccup won't crash the server. Security is especially crucial with solutions like this. One of the core concepts is that the server queries information, not the other way around, as you would see with solutions such as JDWP, etc. This means operations are atomic, and the server can be hidden behind firewalls even from the rest of the organization. PII reduction lets us define conditions that would obscure patterns in the logs. So if a user could print out a credit card number by mistake, you can define a rule that would block that. This way, the bad data won't make it into your logs and won't expose you to liability. Blacklisting lets us block specific classes, methods, or files. This means you can block developers in your organization from debugging specific files. This means a developer won't be able to put a snapshot or a log in a place where a password might be available to steal user credentials or stuff like that. This is hugely important in large organizations. Besides the sandbox, I'd like to also mention that Lightrun is very efficient, and our benchmarks has almost no runtime impact. When it isn't used, it has a very small impact, even with multiple actions in place. And finally, Lightrun can be used from the cloud or using an on-premise install. It works with any deployment you might have, whether cloud-based, container-based, on-premise, microservices, serverless, etc. So thanks for bearing with me. I hope you enjoyed the presentation. Please feel free to ask questions in the YouTube chat, and check me out at talktoduck.dev and lightron.com and everything. And thank you so much.
Awesome. Thank you so much. And you did get us closer to time, so we really appreciate that. Thank you for joining us today.
I talked very fast.
It's
Thank
much
you.
appreciated. Thank you.
Thanks, Jack.
Have a great day. And yeah, I'm going to kick it over to Jason to introduce our next speaker.
Great. Next up, we have Gilberto Castillo, and he is joining us from the Solutions Engineering team at HashiCorp. Good. It's still morning. I had to check the clock. Good morning.
Thanks, Jason. Appreciate it.
Yeah. Well, so you're talking to us today about working with Azure DevOps pipelines, Terraform Cloud, and Enterprise.
That's correct. So we're going to talk about the general things that we see in the community today, and some of the things that we don't see in the community as often, but essentially demystifies how we take advantage of pipelines through Terraform and Vault.
Awesome. Well, we'll turn the floor over to you.
Thank you very much. So I'm trusting that you can see my screen. If not, please. Okay, can I get a thumbs up on your end just to make sure that you can see my screen? Yes, no? All right, I'm going to start talking, and if nobody corrects me, then I'm just going to talk. So thanks, everyone. My name is Gilberto. I do work for HashiCorp, so disclaimer. I'm a bit biased on my conversation today, but it is a good conversation. So I want to make sure that you know that we take our partners very seriously. Microsoft being a strong partner for us, and so we tend to have very strong conversations about what makes sense for customers, what makes sense for the community. So today, the conversation is about the community.
Oh, and really quick, sorry, Gilberto.
Yes.
We can see your browser, but I'm not sure if you're meant to share slides.
No, I'm not sharing slides. I'm sharing my browser only.
Oh, perfect, perfect.
Are you seeing my picture right now?
Yes, yeah. HashiCorp logo on the left, picture on the right.
That's right, perfect. So we're going to move from there.
Fantastic.
All right, so what happens next is, so what we see in the community today, whenever you do a search for Terraform pipelines in Azure DevOps, Terraform pipelines with Azure DevOps, anything that has to do with a tutorial, whether you do it formally online or you do it on YouTube or you do it in any type of scenario, you see the same message. And it's a good message. It essentially reflects something like this. The idea is you write your code, you purposely build something with the intent to create infrastructure inside of your organization, whether it's cloud, on premises, many clouds, it doesn't matter. The idea is you're going to build something. That something is going to produce some assets, and those assets are called state files, security context, all of those things. And then the idea is that you take that, you create an Azure blob or a blob for your preferred cloud, and you store your asset inside of that cloud, whether that's a state file, your properties, your files, anything that has to do with the deployment that you've had. So that's a good practice, and it works really well for the open source community. And basically, you deliver something into the infrastructure that you're going to see. This is what we see normally in terms of learning the overall structure of the things that we do with pipelines. A couple of things about this. This is not the only way. And the reason I bring that up is because there is a bit of a disconnect in understanding that having the ability to do this doesn't necessarily make it easier in terms of the overhead of management. Because now you have a large collection of Azure blobs or containers, if you will, where your pipeline content starts to reside. And you have to manage that, and you have to keep it secure. And there are a couple of things that you have to keep in mind. The first thing that I mentioned is security. That your security posture is utmost, the most important thing in your organization. The last thing that you want is for somebody to know that your assets are being deprecated into the cloud, and that you're going to lose business because you expose something that you shouldn't. The examples today focus on this. So we have a small repo here that does some work. The repo essentially has a couple of examples, and the examples kind of talk about what we just discussed, but it kind of just simplify the overall adoption process. So we're just going to show you. That's all we're going to do today. Then we also have slides that we can share with you as a follow-up, and of course, this repo. You can use whatever is here to basically instrument whatever you need. There are 5 pipelines being deployed here. Don't think we have time to deploy them all today, so we're just going to focus on the ones that make sense for this scenario, this conversation. And as we do this, you're going to have questions. So I'm going to try to answer those questions, basically. So let's get started. So I deployed the code to basically instrument the pipelines. By the way, if you're curious about it, this is real code. So the way we do that is we have a large collection of components that essentially deploy. First, we create a project, which is what you saw on the screen just now. Then we deploy and instrument each pipeline individually. And each pipeline is going to have different properties, different purposes, different assets related to it. This here is basically the last thing that I did just a few minutes ago when I was trying to deploy the pipelines and just making sure that everything worked for the demo. If you have the ability to run Terraform code, you can run this pipeline. Essentially, the instructions are here. How you go about doing the work is pretty much just giving permissions for your code to interact with the platform of Azure. That's all it is. And once you do that, you'll end up with a shiny new project, which is this guy right here, which should look familiar to you, which is this thing right here. Okay, so we have a repo, and that repo has content. Oh, we cloned it. Surprise, surprise. And the content here has an extra one, which is the bonus one for this scenario. This is the first scenario. So what we're doing right now is we're basically saying, we're landing in your new environment. We're going to push content to the cloud. And by the way, we're going to create that storage asset inside of cloud so that we can keep our state file. It's a pretty simple scenario that pretty much brings us up to par with that content. So let's go run the pipeline. And while it runs, we'll talk about a couple of things that are happening inside of this deployment. The first thing we're going to do, focus on that, we're going to do a linter test. So if your deployment contains YAMLs, whether it contains JSON, or anything that essentially needs to be tested for context and simplicity and making sure that it aligns with the language requirements, Terraform itself, you should do it here. And this is a good practice. Why do we emphasize this? It's because you can. In Azure DevOps, you have the ability to run tests. In fact, there's a whole factory of tests that you can do against code, against logic. And so you want to make sure that you take advantage of that feature so that you can support it once you run the system. In this scenario, the linter test for us is really just checking to make sure that the Terraform code is valid. And then once we know that the code is valid, then we run a plan. Why do we separate the two? Just practice, making sure that if you run a plan against your code, that it matches the desired effect that you're going to have in your environment. Am I going to have collisions? Is this going to work? Does the resource make sense? Is this logically aligned in a way that makes sense for me? A speculative planning makes sense. Now, once you have that, then what is going to happen is we're going to create a backend. This is that piece that matches this process right here. We're going to create an Azure blob, and essentially that's going to give us access to the system. So what I'll do right now is I'll just hit refresh here until a fresh animal comes into view. You'll see that here. And that's really the code generating some content in the back end. I'll show you as it builds. It's actually doing it right now. You can actually introspect that directly into the code. And once it does it, I think it's just about to finish that. Then we'll have a fresh new animal that is going to give us access to the storage. I think it's called helping shad. So let's go take a look, make sure the helping shad is available. So we do that. It's going to come in a second. Oh, perfect. So it's right here. There's our helping shad. So Azure DevOps helping shad. Inside of that resource, you'll notice here right now that we're going to create a storage backend. And that's what we're doing in the backend right now. Basically, the pipeline is building all of these resources so that we can build the resources that we need. And so this storage piece is essentially looking to support the ongoing storage for your state file for the Terraform deployment. Typical, and basically it matches the purpose for that particular scenario that we showed you today. So that's the common typical scenario that we see in environments. Inside of this environment, we support, we actually stated things like let's make sure that we have variables set up properly, make sure that we have versioning enabled, make sure that we have the proper alignment with the account that you want to allow access to. There's a couple of things that you manually have to do to be able to support this. But in the end, you have a proper state. And if I show you that thing, we just call the state. Basically, the deployment that we just did has a Terraform state. And if we download that, it'll just show you that it exists as an object. So I'll download it and see if I can download it quickly. There you go. And if I bring the state, you'll notice that essentially it's a recent deployment for the system. So there it is. So that's my state file. We just downloaded it. It's a brand new one for the deployment that we had. And that's that. So that basically, this pipeline that you see here is now matching the entire sequence that you normally see in the general community examples that you get to examine. Now, why are we showing you this? It's just so that you have a basis for comparison. If you don't have a basis for comparison, then you don't know what to compare to. Now, here's where we go into the improvement part. And we're going to do that in two parts. One, first, we're going to show you how that aligns with Terraform Cloud. And the second one is, well, inside of this pipeline, in fact, when you look into it, pipeline 03, we edit it, and we look at the content that gets included, we had to pass a couple of variables. We had to put in some containers to be able to support this. This is not necessarily a best practice because you don't want to propagate things that could be discovered or could be exposed. And then once you have this, how long do you have, in terms of retention? How do you manage the overall association of those critical elements inside of your environment? These are dangerous things to leave around. Even if you put them into a key vault, then you're going to have key vault proliferation. So we'll talk about how we avoid that in the short term. Okay. So let's go back to that pipeline. Let's complete it. Because this is a demo, we have to basically allow it to expire. So we're going to say, let's go ahead and delete these items that we've created, and let's move on to the next example. All right. We're making sure that we understand there's a balance between what we did here and what we're going to do next. What comes next is rather symbolic. The second thing that we're going to show you is on pipeline, say 5. And on pipeline 5, what we're doing is we're taking this context. We're going to talk to Terraform Cloud, which is where my mouse is hiding right now. And then Terraform Cloud is going to talk to your target environment. In this case, Azure Cloud. It could be anything, of course, but at the same time, we're going to use an element of release to basically take this and release an application based on the proper Azure deployment standards. Why do we separate the two? To ensure that you know that there is build and release context built into the logic for this particular scenario. We don't believe that Terraform is the only tool to do the work. In fact, Terraform can, in fact, deploy applications. The question that you have to ask yourself is this the best tool to deploy that application? And you will have multiple versions of the truth based on your own conditions. But the thought process here is build to the left, release to the right. Build to the left, release to the right. That's it. That's the only context that we want to give you. So let's go ahead and build that. So we're going to go to pipeline 05. And pipeline 05 is going to be very, very beautiful. There it is. And we're going to run that pipeline. You're going to see something parallel in the same sense that we run pipeline 03. We're going to do the QA test. You probably shouldn't see that again, but I think you're seeing it here for consistency. You know that we believe in this when we put it as part of the process. All of you do this in different ways. If you had a test plan from Azure, then you want to tie that directly into your QA process. What you're going to see here, though, is different. You are going to see resources land inside of the Terraform or the Azure environment. Absolutely, you are going to see that. What you're going to see differently is that once we have those resources deployed, we are also going to use Terraform Cloud to host the resources and to dive into the environment. So we're going to show you that next. So let's watch the little lines run. Basically, we just have to wait. This is the part of the program where I do a little dance and essentially just kind of look into your eyes and have an introspective conversation about technology. All of that in a measure of buying time. All right, looks like it's running. I'm wondering if anybody here has any questions while I look at the chat. All right, looks like no questions. I am absolutely clear on what I'm doing today. So that's great, guys. Thank you. Notice how here, instead of saying create a backend inside of Azure, we're actually looking at creating a TFC workspace. And that has a significance because that's going to show up right over here once it gets done. So we'll come back to that in a minute. And then we look at what introspection we did to get to that stage. All right. And as it runs, then now we're going to see. So this is Terraform Cloud. Terraform Cloud comes to you in multiple flavors. You have the ability to run Terraform Cloud in what do you call it, in free mode. Basically what it means is you can run it with a free account. You have some limits in terms of what you can run, but you can run it on your own. So basically it's the same as open source, except that it's in the cloud. That's the main difference. It also comes with a couple of measures of protection. So in this case, I'm using dual factor authentication to log in. Here we go. Please close your eyes. Don't remember this number. And basically, once we're able to log in, let me try that again. Terraform Cloud. There we go. 094096. Hopefully that works. Let me try that again. Okay. 431 782. There you go. Now we're able to log in. Sorry, just a little lag in my phone. And as we log in, there it is. So we just created this. It's called the Azure DevOps Proud Mammoth. This basically, these names come from our random generator. And essentially, one of the things that I want to show you first is we populated the appropriate variables that support this deployment inside of Terraform Cloud. Now, this is sort of contradictory. I just said you shouldn't keep your variables deployed inside of Azure pipelines because you don't want to propagate them, and yet I'm propagating those to Terraform Cloud. So am I a hypocrite? A bit, somewhat. We need those to be able to deploy and talk to your environment. So you don't have to keep them here forever, but you need them to get started. Once you're done with them, you can discard them if you wanted to. It's up to you. These here are being generated dynamically. You don't know that yet because that's part of the next demo. But essentially, that's the meaning behind this particular scenario. Now, we also added some specifics about the environment. Unlike this, you can populate anything from your environment as well. We also automated the run. So right now, this is running and it's trying to build something in the back end. It looks like it's building my Azure resources. So I'm going to go look for Proud Mammoth inside of the ASDO. So let's see. There is Proud Mammoth. Inside of this Proud Mammoth, now we have a service app service plan. And next, we should have the next resource should be an app service container. And through that, we're going to see an application being deployed. So let's give it a moment while it builds. It does take a little while. But basically, this is the overall introspection that I want to show you. All right, so it looks like it's done. So there's a couple of things that we need to do still, and this happens automatically. So here's our app service. Inside of the app service, one of the things we have is we have a deployment center, and this is waiting for an application. Basically, there's nothing there right now. Wait, go back to the example. Oh yeah, it's waiting for the deployment of the application. The separation here is build and then release. Build pipeline, release pipeline, all containing within one particular pipeline. Why do we have this and why is it waiting for? It's waiting for us to approve it. Really, what it needs to happen is we need to have permissions to actually access the Azure environment and deploy directly from this pipeline. The very first time that you need to do this, you need to approve it. So this is at this stage, at this very moment, you should be generating a service ticket. And that service ticket should be driving a conversation about, yes, I approve the deployment of that application, or you don't. It's completely up to you. And I just did that approval from this perspective, clicking a button inside of Azure DevOps. The truth is, though, that should be automated from a different click. And that click shouldn't be a technical click. As a technical person, I have the authority to do that inside of an example in real life. The authority should fall under somebody who has the ability to basically manage your budget, manage your projects, maybe a project manager, maybe a manager, maybe a team leader that has the knowledge and understanding of what the implications of that application deployment are going to be. That's it. That's the bottom line. As we see this, at this point, when we go back to our Node.js app, we do a little refresh. I jump around so that we can see refreshes happening. You see now that there is more context and more happening inside of that container that we just created. And we start to see the deployment center take action. So right now it's basically saying, yes, I see a new application being deployed. I have to copy the assets from the source repository all over here and then instantiate the deployment. And this is what is happening right now. So we just have to wait for that to happen. Where is that deployment? Well, that deployment happens to be in our repos. Our repos basically have a breakdown for this. We have the templates, which are basically the templates that we use to illustrate the deployment. The staging components that essentially build the repository. So these build this particular item right here inside of our platform. And they also create the assets we need inside of the Azure platform. And the production app essentially defines how to deploy the resources in terms of infrastructure that you need to support the app. Finally, here's your app, just a zip file. But because of the context of how Azure DevOps does it, it has to go through proper authorization. It has to package all of this and then deliver it to the component. Is this a complex scenario? Not really, not by much. But what we're trying to prove here, and this is the importance of this conversation, is that you can do all of this with a prescriptive method. And that aligns with not just technology alignment, but security. And that really is what makes the change here. So we're going to let this cook. I think it's going to take a little while. But while it cooks, we can jump into the next scenario. So let me see. I click on different things so we can update the screen. We'll see that happening in a few seconds. So as soon as the screen shows me the app, click on the app and you'll see the app say hello world. We know that it's running. Okay, so there it is. It is being uploaded. It's still not ready. We'll wait a little bit, but essentially that's what's happening right now. Okay, so as it starts to build its settings, we're going to jump into the next example and we'll come back and look at this because this really changes everything. I'm going to point out a couple of things. One, inside of this environment, in Terraform Cloud, we have the context of these variables that are dynamically generated based on the context and the metadata that is derived from the deployment. Hence, we do this with dynamic names. We also have this, your state file. And now that you have your state file, then you start to realize, wait, I don't have to maintain any of that. I don't have to control it. I don't have to worry about having to have the overhead. It just happens here. Whenever you do collaboration, meaning somebody else contributes to your code base, we queue up a new deployment. You decide whether you want to do a full end-to-end deployment, which includes infrastructure plus application, or just the release or what have you. And then you decide how to approve those deployments. And based on a proper CI method, now we can have a second lineage for that state file being delivered here. And that starts to change the overall structure of how you do things. State file is over here. Now we have a clear definition of what we need, outputs, content, all of this is here. This is the bottom line here. This piece right here, this is the end result, if you will, of the thing that we want to see. The app is not ready, so I'm just going to stop that. I'll copy it, load it over here. Once the process in Azure completes, we'll see the app load here, and then we'll just come back and see it. But what I wanted to emphasize is that all of the effort, all of the work that goes into trying to save assets, trying to save variables, trying to locate and secure deployment details in the state file, all of those things, you wipe them off the table. Okay. So let's go back to the last example. We have about 8 minutes before we end this conversation. I want to point out this. This happens to be my deployment of Vault in something we call the HashiCorp Cloud Platform, or HCP. Happens to be part of what I do today. So when I needed an interrupt or a Vault deployment, I just came in and I deployed one based on the things that I needed. I don't have a large deployment. I have a very small deployment done, but I do have a private instance for this that faces my backend cloud environment. And then I have a public instance, which is where I'm showing you right now. Inside of this Vault deployment, I have dynamic Terraform tokens being generated for each deployment that you have, so that each deployment is unique. We also have secrets for the conversation that we're having right now, so that every time we deploy an application, the secret gets generated. And there's different ways to approach this. For this demo, I just mounted the secrets inside of an environment variable. So these are the things that I'm deploying. If I wanted to be more introspective, I could generate them dynamically, basically do everything that I need to do, sort of like what I do with the certificate generation, and then basically do that dynamically so that every single thing that we do is unique. And this backs up the idea we eat our own dog food in terms of saying that you should authenticate everything, trust nothing, because that really defies the idea that you have to keep static secrets laying around anywhere. And so the proof is in the pudding. So let's go back ahead and do that. So we have one last pipeline. This is the last pipeline that I'm going to show you. There's a significant difference in this pipeline and the way this pipeline runs and the other pipelines, and hence it's not part of my example set. The reason is because this is all built on pure API calls. Pure API calls. There is nothing being used here this is required directly within the Azure DevOps environment. So as I run this is going to do a bunch of work. Each one of those things is going to run in sequence, and as they run, one of the things that you're going to notice is that everything that it gets done is basically a curl call using basic API instrumentation, both against Terraform and against Vault. Okay, and while we do that, I'm just going to show you the code. Let me go back. I'll show you the code. This is the most exciting part for everybody here, because code really means that you can do stuff. So let's see, pipeline. I'm looking for a pipeline. I'll do it from this area here. Pipeline 6, pipeline. Okay. On this scenario, what you see here is pipeline 6. So a couple of things. So we're grabbing artifacts, we're grabbing the code, we're taking the code, massaging it, put it into an artifact so we can push it over to the platform. When I meant what I said, and I said what I meant. We're using pure API calls to talk to the platform. So the first thing we do, first thing we do is we have a response token that essentially talks to Vault and says, give me my secrets. That's the first thing that it's doing. So it does that by basically saying, okay, I want to get my token, my secrets, then I want to get all of the proper secrets from this particular scenario and set them up as secrets inside of this pipeline. If these are static, there's no way you can expose them. And if they're dynamic, it's even better, because even if they were exposed, you wouldn't lose anything. And basically, this would be valid for the run. Once we have that, we also do this. Right here, we said, let's go get a token for Terraform Workspace. And we get the Terraform Workspace token. We talk to Vault. Vault talks to Terraform Cloud. Terraform Cloud returns a token. I have an idea. Let me show you that visually so you can take a look at what I mean. Here's what I meant. Azure DevOps talks to Vault. Vault returns secrets. When Vault returns the secrets, the next thing that it will do is say, Vault, that's just Azure DevOps asking, go get me a Terraform token. And Terraform token goes out and gets that and says, hey, I need dynamic credentials for Azure Cloud for this thing to work. Let's get those too. and it gets them. In fact, when we look at the instrumentation, this is really what is happening. We're following a workflow. So it's a small workflow within a workflow. Each one of these sequences can be broken down into concrete steps that are going to essentially give you something that you care about. And the only thing that is being exposed to the pipeline is a role ID and an app ID, which in our nomenclature is a very super duper secure username and password that is dynamically generated with a lot of introspection on randomness, so that it's never replicated, and you can put rules around how often you use them, and that generates a token which gets us to the ability to talk to the API, and that allows us to get secrets. Each one of these things has its own set of content, so depending on what you're doing, you are going to see different sets of steps to support the operation. Okay, so that works, but what happens next? Well, we populate those secrets into a workspace. Whether those secrets stay there, that's completely up to you. We'll note that we use a lot of encryption in our backend to support your secrets. And then once you have that, then we load the artifact, which is the code, the Terraform code that you actually want to deploy. Yeah, you were there for a reason. And as it runs, basically, it's going to run that plan. So the whole thing that we talked about before, it's going to do some testing. If we are using Terraform policies, we call them really Sentinel policies, but let's pretend they're policies for Terraform code as it deploys into your environment. It's also applicable to secrets. Then you build the infrastructure, and then you go back and you acquire the secrets for the application because you want to load those things inside of the app, and you confirm the identity, and taking a deep breath, build the infrastructure. That's a long way of saying things, but that's what's happening in the back end. And each one of these steps has a different set of conditions that you're going to care about, right? So depending on what you need, that's what we worry about. With 2 minutes, less than a minute left, this is the final application that got deployed a little while ago. This application really is an example of another exercise that we ran through, and it's just a little widget, really. Inside of the Azure pipelines, you should see our pipeline, our latest pipelines being built. Yeah, it's finished right there. And it built the assets, and it did the work. Sorry, I'm jumping around too much. I should just look at this pipeline. Yeah, there it is. And it did the job, right? So it finishes doing the work, and it went through all of these steps to finally deliver the effort into your environment. And lastly, this is the last thing that I'm going to show you, is that our assets got deployed. The reason this is deleted, by the way, is because I have a timer in the pipelines. We have a timer in the pipelines, and each one of those pipelines essentially will expire on its own. So pipeline 5, it has a little thing that says, after 10 minutes, go ahead and destroy the infrastructure. It is a demo after all, so whenever we run a demo, we make sure that we clean after ourselves. And while I didn't show you the effort that was done, I show you the end result, which was that application that's deployed here. Okay, to summarize and to end this conversation, there are different ways to run a pipeline. So if you ever run into like, here's the best way to run a pipeline, yes, this is effective and it runs and it works really, really well. However, you also owe it to yourself to think about different ways to approach this with enterprise tools, which makes your lives a lot easier, not just now, but in the future. With that, I'm going to stop sharing, and I'm going to answer questions if there is time.
Thank you for that presentation. I don't think we have time for live questions, but if you have a minute and wouldn't mind, Gilberto, if you jump into the YouTube chat, people may be prompted to ask some. I don't think there was any queued up, but thank you very much. Azure DevOps is something I haven't spent a lot of time with myself, so it was neat to see it tie in all those different ways with the IAC pipeline. So,
well, thanks, Jason. Appreciate
no
it.
problem.
All right.
Yeah. Have a good rest of your day. And up next, I think we have Michael Kennedy.
Hey, how's it going?
Hey, good afternoon, Michael.
Thanks, Jason.
So you're a consultant with Arctic here in Toronto, and Jackie and I wanted to read your full bio as provided because we love it. Says Michael is a consultant with Arctic, and when he's not working with customers and their software systems, you can find him hiking in the forest with his dog Maggie. The chaos of the trees is comforting and reminiscent of the branching found in some enterprise Git repositories.
It's true. It's true. Yeah, the forest is relaxing. I enjoy that time with my dog and reflecting on the chaos that's all around us. It's always fun.
I like the balance that comes from that also. So you're here to talk to us today about transforming sensitive data at API gateways with HashiCorp Vault.
Yeah. I have a slide deck. I'm just hitting share now.
Perfect. We'll give you the floor. Looking forward to hearing the talk.
There we go. Is that showing up correctly? Yeah. Okay.
That looks good.
Yeah, great. Oh, so this is me. We've already done the intro, and the premise here is that Vault, HashiCorp Vault is a great tool set, but all the other secret engines get the attention. I think Transform needs some love too. There's often a lot of capabilities that are left unexplored. Many organizations we work with are either using the open source edition or have upgraded to a supported enterprise or HCP Vault, but they've typically only just begun to take advantage of the capabilities that the platform offers. The typical starting use case is static secrets, stowing them in the KV, using them for their CI/CD pipelines and software deployments, like the ones that Gilberto just showed. And a good healthy segment of the market are starting to explore the power of dynamic secrets and are using Vault to generate credentials for components of their ecosystem dynamically and reducing the number of credentials that are out there in configuration files in the wild. So they're reducing their risk profile and improving their operational security and providing audit trails and so forth. But I believe Vault has more to offer. I think the Transform engine needs more airtime so people can understand what this capability is, why it's useful, and that's why I prepared this short talk. While the title mentions API gateways, this talk isn't about exposing Vault services for consumption via the API gateway. We're talking about using Vault in concert with your API gateways and a bit of integration code to solve compliance problems and risk management. Using these features is not limited to API gateways. These features can be used by any developer that can consume Vault services. This Transform engine currently supports a couple of different types of transformations called FPE masking and tokenization. FPE is format preserving encryption. Masking is, as you might imagine, masking of data. And tokenization is substituting data for other data. In this talk, we're focused on the NIST standard FPE using FF31 for this example use case. And this Transform engine is included with Vault Enterprise with the Advanced Data Protection module. Unfortunately, this isn't available in an open source edition. Just to be aware that if you try this and want to try this yourself, that you'll need to get a eval key from our friends at HashiCorp and to give it a go. So format preserving encryption, for some of you, this may be new. So for some of you, it may be old hat. But essentially, you take the plain text and you encode it using Vault Transform, and the encoded value that comes out looks an awful lot like what you put in, but it's encrypted, and it's a NIST standard, and there are cryptographic features available to improve the key space used, and something called tweaks. And then, as you do this, you store that encoded value in your database, and that's lowers your risk profile because you are no longer storing the sensitive data You're only storing an encrypted version of it. And then when you want to decode the value, you take the encoded value, send it to Vault Transform, and if you're entitled to decode, then you can get that plain text back. This sequence we think is quite useful as a transformation with your API gateway. A lot of enterprises are adopting an API first approach to building. They have API management platforms and integration as a service platforms throughout their enterprise, and then each solution has an API gateway with an integration layer that's readily available or can be readily configured to place an integration in line. The purpose of this talk isn't to drill into any one specific solution. We're talking about this at a conceptual level, and then we're going to show you the feature in Vault that support this. Essentially, when you have an API consumer going through an API gateway to the API producer on the right-hand side, that typical flow, everybody sees this if you're working with API gateways. And with a lot of products, oh, by the way, super excited about the console API gateway that was announced by HashiCorp early, I think in October, and we just saw some bits hit GitHub this week for early access. So check out the console API gateway if you can. But when you transit through an API gateway, you have the opportunity to go through an integration layer that can then talk to the Vault Transform engine to encode and decode values. And then the idea here is that by doing so, you're creating a barrier between your consumer and your producer, and limiting where sensitive data goes, which is just to the API gateway and the integration layer and through to the Vault platform. And the API producer doesn't actually see the sensitive information. This obviously is more complicated than that. You'd have to analyze your particular domain and understand how this would work for your particular environment. But in this example, we'll show you how that's done. Because this is HashiTalks Canada, I picked the Canadian use case example to show, your social insurance number. This is a publicly available image from a museum, so no worries there. I'm not showing Charles Sellers' social insurance number. It's nothing to worry about. But this idea is that we have a 9-digit number that we all want to protect and don't want to leak for fear of identity theft. And so what we might do with this is use the HashiCorp Vault Transform engine in order to protect that. As someone submits it to an API, have it transformed before it goes to the API producer and is written into a database or perhaps logged. And so how we do this is configuring the Vault for Transform engine. First thing we do is activate the Transform engine. Then we can configure an alphabet, which is a set of characters used for evaluating input and creating output. Configure a template, which in our instance is a regex that describes the value capture and encryption. Configure a role, which is an access control construct provided during encode and decode operations. And then configure the transformation, which is information about the type of transformation, which template to use, and some other configurations such as a tweak source. And this is just all the steps you need in order to get started. We'll go through what each one of them looks like. The first thing you do is activate the engine. This looks a lot like any other secrets engine. And you just do a Vault Secrets enable with the transform, and it'll be enabled at the default spot. You, of course, would configure this appropriately for your environment. If you're using namespaces, etc., you would manage that the way that you would. But for the purposes of the demo, we're using a very simplistic example. You create the alphabet. Here, we're just showing you what it would be like to create a numeric alphabet. There is a built-in numeric that's equivalent and could be used for the use case, but we just wanted to show you what it might look like in case your use case needed some special attention. And then next is templating. So we know that this input value that we're thinking about looks like 3 digits, followed by 3 digits, followed by 3 digits. And so we create this template, which is a regular expression. And the brackets in the template represent the areas of the number that will be encrypted. This is pretty powerful. And if you, let's say, only wanted to encrypt a portion of the field because you needed another part of the field to be open and available for your perusal and querying, you could make part of the field outside the brackets, and which I think there are some examples out there for credit card numbers where they want to still know whether it's an Amex or a Visa or a MasterCard, and so they leave the first 6 digits unencrypted. But still have the rest of the card number encrypted in order to prevent it from being abused. So we create this template using vault-write. We name it, we tell it what it is, we tell it what the pattern looks like, and we set the alphabet that we're using. And here we create the role. This is the, we're saying, hey, we want to create a path that is going to be used for these transformations, and that's what you'll use for your access control construct. And finally, we create the transformation itself. Here we say vault-write, and we set the transformation name. We set the type of transformation. We set the template we're going to use. We set the tweak source, and we set the allowed roles. And so, and this is successfully done. And for demonstration purposes, we're using tweak source internal. This may not be the most appropriate option for your use case, so please refer to the documentation for the FF31 tweak usage. This is available on the HashiCorp site, and you can learn a little bit more about it. Once that's done, your transform's active, right? A quick vault-write to the encode, and you set the value, and it returns you the encoded value, and a quick vault-write to the decode path with the encrypted value returns the original value. And you can see very easily, like readily, how this could be very useful depending on the scenario that you're working on. In an API integration, you might access the encode on a post, and then access the decode on a get. And these are just some command line examples. In the context of an integration gateway, you're likely going to use the API endpoints. And so you would set it, your encode to the, your vault address, followed by the /v1 transform your path and encode, and then the transform role that we're doing, and then same with the decode. This is most typically what you'll be doing on the integration platform, and that looks as you would expect. You would make the request, provide the token, provide the data, and you get a response with the encoded value in your JSON response, and you marshal that and replace the values as required on the integration platform. And same with the decode, precisely the same. And so with that, you can see how an API, a consumer to API producer without the integration of Vault, the consumer will send sensitive information, and the API producer stores and retrieves that sensitive information. But if you add the Vault's transform in the middle with the integration, the API consumer will send that sensitive information, but the API producer stores and retrieves encrypted information. And what this does is creates a sort of a barrier. and so potential for reduced audit scope for sensitive information handling, because essentially the things that handle the sensitive information are your API gateway, the integration layer, and the vault that you're using, because your API producer now only sees that sensitive data in an encrypted form, and it limits opportunities for your API producers to leak sensitive data unintentionally, such as logging. We often have conversations with our customers about keeping sensitive information out of logs, and this is one way to do it. Just make sure that it's just not available. And then depending on your audit scope and who you're dealing with and what compliance controls you need to be concerned with, this is a potential reduction in audit scope for some of your compliance activities, because now anything to the right of the API gateway integration and vault transform engine does not really have access to that sensitive information. And because you've encoded it prior to sending it to your API producers. And so with that, that is the quick speed run. I have some command line stuff to run, but I think that we've covered that in the previous slides. The essence here is that with the API gateways being present in all of the environments that we see, more and more people are investing in them. You can create this reduced risk profile and lower your compliance costs by encrypting the data before it gets to the API producers, and it creates a very, I think, valuable asset in the developer's inventory. And for now, I'd be open to any questions if there are any. Oh, anything, Jason?
Hey, thank you for the talk. I really liked it. In particular, I was sitting there thinking about all the times where we had that push-pull tension between, emit traces or like emit reasonable logs and like exact scenarios like this, right? So if the service is not even getting the real value, it's sort of a game changer.
Yeah. There are some folks will take some ground that say, hey, you shouldn't have this kind of logic in the gateways, and in certain scenarios, I can see the case, but in this particular one, we're talking about a transformation and not logic, and so there's a trend now where we're seeing more and more of the integration platforms and API gateway platforms creating space for doing light integration work at the gateways. There's been some recent announcements from Google with the Apogee products, and there's Red Hat has their Fuse platform. There's ways to do this that we think remain consistent with the principles that one would want to apply.
Yeah, it's great.
Yeah.
There are a few questions in the chat, and if you don't mind sort of heading there and wrapping those up, I really appreciate you speaking with us this afternoon, and we are going to roll forward with the schedule. So,
okay, thank you very much.
Thank you. Next up, we have Yassine Snoosi. I apologize if I got your name wrong. Could you tell me how to pronounce it so I do better in the future?
No, that's right. Thank you.
Perfect. Well, thanks for joining us this afternoon. And you are going to talk to us about infrastructure as real code.
Yeah, definitely. Thank you for the opportunity, first of all. And I thank Jenna this morning and Gilberto later on set up the table for this talk. My name is Yassine. I'm an independent consultant. My area of interest are cloud native tech stacks, DevSecOps, and Dev Experience. My LinkedIn handle if you want to connect. What I will be talking about is infrastructure as code or as real code. I have a developer background and I still identify myself as a developer. And while I write application code, I feel like I'm empowered. I have cutting-edge toolings, flows, and processes that serves my need to innovate and iterate faster. This area is still in continuous improvement with smarter IDEs, CI/CD, microservices now, containers, Kubernetes, needs developer experience, and even solid test and deployment strategies. But when I started to write infrastructure as code, I had that feeling. I don't have equivalent toolings, equivalent dev experience as in the apps code. So I was wondering.
Sorry, Yassine, just jumping in here. It looks like we can see your screen, but it just looks like it's blank, but there's a cursor on the screen. Just want to give you a heads up.
Okay, that's strange because it says it's I'm sharing.
I do see the cursor moving currently too.
Do you see the slides now?
No.
Okay. I'll stop sharing and reshare again.
Absolutely. Thanks.
What about now?
There we go. I think I can see everything there. Perfect. Yeah, I can see the slides now. Thank you.
I'll go into the slideshow mode. You tell me if you see it.
Awesome. There we go. Good to go. Thanks, Yassine.
Cool. Yeah. So I was saying that when I started to write infrastructure as code, I had that feeling. So I don't have the same flows, processes, and also tools that helps me to accelerate my my coding turnaround time. And I was wondering why we have that gap between app and infra code, knowing that the value resides in application code as well as in infrastructure code. And I was even wondering if there's any way to bridge that gap. And this is definitely one way to bridge that gap. And what I suggest today is whatever we learned from our DevOps journey, from our DevOps approach, mentality, and culture could be applied to infra code. So when you write a piece of code using Terraform, for instance, this is just the beginning of your journey. And we should build an ecosystem around the said Terraform code. That ecosystem resides and relies on different pillars. The first one is CI/CD, a CI/CD flow that goes beyond the classic Terraform init, plan, and apply. A better developer experience so your developer can innovate and iterate and deploy with confidence in production. Security and governance. And this is in line with the shift left paradigm. So whatever we do in production in order to pen test the infrastructure or detect any security misconfiguration could be done when we write the Terraform code. And last but not least, the fourth pillar, operations. And by operations, I mean two things. Day two operations, but specifically provisioning. And this is what Andrew tackled in his talk, how we can write a set of Terraform code that is easier to share and easier to reuse afterward. And this leads me to talk about the collaboration model. Before even we write a single line of code, we need to know what our team size, our capabilities, the team's responsibilities. Do we have a dedicated platform teams, or we are just a bunch of individuals who knows how to write Terraform code and we do our best? The provisioning model that we want to have within our organization, is it pipeline driven, TFC driven, or we have the luxury to code a nice and fancy UI for self-serve? But there's one flow that really works. That flow, if you used any modules from the public Terraform public registry, you used it, the producer and the consumer. With Andrew, we've seen how to use that, the second flow, the consumer, basically to roll out features that deploys resources in the cloud. For the first one is the flow about the producers, the guys who writes actual modules. And then with a pipeline of some sort, the outcome is a versioned module over here. We will see in the next slide how we can implement a pipeline with the outcome, a module that is tested, secure, battle hardened, and obviously versioned, so we can share it and standardize the purpose of that module across your organization. This is one example of this flow, and by no means the example. As you can see, it's pipeline driven, PR driven even, and we can notice two flows: the developer flow from the left hand side and the module flow on the right hand side. So we see a classic approach if you worked in the software space. The developer writes some code. You will have some pre-commit hooks that does some sanity checks on all the file that it's being committed, so you don't push garbage to your VCS. Whenever you do that and you raise a merge request, there will be a pipeline associated to your merge requests to make sure that at least you have some sort of smoke tests being executed against your PR. And then you have the reviewers, review your code, push some comments, suggest some comments, and then that loop goes on and on until everybody's satisfied with your change or you get fired. So once that PR is getting approved, the code is being merged, and this is where the module pipeline on the right-hand side kicks itself with the purpose to execute some steps. We will see them in a minute. Execute some steps, and outcome will be a published module with a version attached to it. And this is what I suggest as building blocks. And I really meant to call this slide building blocks to not have the exhaustive list of tools that does different steps that you see in here. And I don't want to have a debate around which tool is better than what. So again, in the pre-commit side, the left-hand side, you will see what you can do. For example, Terraform validate, the native command, Terraform FMT in a recursive manner. You can use tflint to do some linting with some provider deprecation. It can detect that as well. There's also Terraform doc that generates your documentation automatically for you, either if you run it as a standalone command or if you make it as part of your pre-commit hooks as well. The next step, linting validation. This is more for the aesthetic part of the things. So Terraform validate, Terraform FMT. If you have any commit standard, should be part of it as well. The security scan step. This is what we talked about earlier. This is about to shift left all the security scanning that you do in a passive way. This is static security scanning. So with the tools that I list here, Checkov, TFSec, TerraScan, we have the ability to scan in a passive way all your HCL files and detect if there's any security misconfiguration. An obvious one will be if your organization doesn't allow public S3 buckets, you can have it detected and flagged by one of those tools. The tests, and this is one of my favorite topics, and I guess Jenna talked about it at length. Here, this step will tell you how serious are you about infrastructure as code. So either you have some smoke test, integration tests, unit tests, or end-to-end test with respect to the pyramid of testing, obviously. What I suggest here, two known tools, TerraTest and Kitchen Terraform. And hopefully at some point we will have a native Terraform testing framework at some point. And the last step, this is the CD part of CI/CD. Say that we passed all those steps. The idea here is to tag that code with a semantic versioning schema, major, minor, patch release. And you can do it either manually if you want, or you can automate that process. Semantic release appears to be one of the tools, at least my favorite, put it this way, that takes as an input the commit message and decide if it's a major, minor, or patch release. And of course, you need to follow a commit message standard. The one that semantic release depends on is the Angular one. And then as a bonus, if you are a TFC user, you can configure your VCS to push a new version into your private module registry in TFC automatically. So whenever there's a new get tag, TFC with the integration in place will detect a new get tag and push or pull that version into PMR in order to have a new version. And this is what we will see in this demo. I will try to skim through. I'm running out of time. So in here, the purpose is to have a module for S3 in AWS. We will see the pre-commit hooks that I have in place in my laptop, the execution of them, the tests as well, opening a PR, the pipeline associated to the PR. Once that PR gets approved, or before even the approval, you will see that the pipeline associated to my PR. So check out for static code analysis, there are tests for testing, then the approval of the PR and merging the code. And this is where the module pipeline will kick itself. And the extra step that you see in here is the release. So we'll, based on the git commit, that tool semantic release will decide if it's a major, minor, or patch version. Create the git tags and push that git tags into my VCS, and afterward you will see that I have a new version pushed into my own TFC PMR registry. So without any further ado, I'll try to speed things up. I've noticed that some of my colleagues recorded the demo. This is a nice idea. Maybe on the next talk, this is what I will do. So first thing first, testing. So as I mentioned, I love Terra test. Maybe at some point we will use Terraform in a native way to create tests. The purpose of this module is to create an S3 bucket. So this is my code, really simple one. It creates an S3 buckets in my AWS account. And in here, I have a fixture that mimics calling that module with some specific inputs. And what I do in my test, briefly, pointing my test to my fixture code. I have the ability to put some options. Here, I'm destroying all what I instantiate at the end of my test, thanks to the defer function.
It looks like Yassine, that we lost a video on that again. So sorry.
Okay, that's strange. Okay, I'll stop sharing and reshare again. Apologize for that.
No worries. Wouldn't be a live event if we didn't have a few bits and bobs go the wrong way.
Okay. Tell me if you guys see my screen.
All right, that looks good now. Yeah, I can see your code now. Thank you.
Okay. Yeah. So this is my Go test. Again, apologize for that. I do a Terraform destroy at the end of my test just to always start from a clean state. Terraform init and apply to deploy whatever I have in my fixture. And at the end, what I do, based on the output, I make sure that I have the right ARN with the right S3 bucket ID. So if I go execute that, this is exactly what this code will do if everything works fine. There you go. And you see exactly what this test is doing, thanks to the logs that we have over here. So at the end of the test, everything will get destroyed. So the tests are independent in nature, and you can compile and compose any test scenario that you want. This is really the basic one, but you can have test setup and test tear down afterward to set up some inputs or some specific scenario for your module. As you can see, the test passed. So the next thing that I want to show you is the commit hooks that I have. So this is my S3 bucket code. I'll go ahead and just disable versioning in my S3 bucket. And if I try to commit this file, Chekhov doing the static code analysis will scream and won't let me commit that file. So get that. Okay. course. This is a live demo. So I'm trying to commit. See if I can move this one. Yeah, I'm trying to commit, and I have some pre-hooks installed on my repository. And as you can see, it screams saying, I won't let you commit because you have some security checks that is not being respected. And the one in question is this one. Check AWS 21, ensure all data stored in S3 buckets have versioning enabled. I can even have another scenario where I will introduce some really ugly formatting over here, running the same thing. Now, Terraform FMT will say your file is not formatted correctly, which is really helpful before you commit everything to your VCS and just waste your pipeline resources. You conduct locally and you have a faster feedback loop. Now that everything is in place, the next thing that I want to talk about is the pipeline itself, or the pipeline definition. As you can see, there's no pipeline code. This is for GitLab, by the way, I should mention it. All the pipeline definition resides in a template. So with that, you alleviate that burden from your developers, and they don't need to care about how the pipeline is being constructed or even know the details behind it. And you can bake in that definition or those 2 lines in the project template. So whenever you have a new module, you instantiate your project template and you have already a skeleton of how it should be your pipeline, and you are ready and good to go. So assuming that that I will open a PR, I'll introduce just a fake thing. Of course, I didn't fix what I had previously, and this is good. And you see the execution live. So I've talked about semantic release, and this is the standard that you need to respect in your commits message. If you want to enforce it, if you don't want to learn it by heart, as I do, you can have a tool called commit citizen or commit lint, just to make sure that you respect that standard and you have an interactive way to have your commit strings the proper way. Say test 1, 2, 3. If I push, I should be able now to open up a merge request in my GitLab. There you go. So I will open up quickly that merge request, and you see that there's a pipeline associated to my merge request or pull requests. There you go. You see that pipeline, and inside that pipeline, you see that I'm doing several steps over here. So security static analysis and a test to execute the test that I did previously manually in my laptop. So I'm not going to wait for this one to be executed, but I'll show you a previous execution, so I won't consume more time. And you see here the 2 types that I was talking about, the merge request or the pull request pipeline and the master pipeline. So whenever we do a code merge, there's another pipeline that is being executed. If you go inside, you will see the steps: security static analysis, test, release. And from the list that I shared with you guys, you can compose any pipelines that suits your need with the proper steps and alignment of the steps as well. So this one is a nominal scenario that succeeded from A to Z. And at the end, I have that release step that takes my commit message, as you can see in this line over here. Analyzing commit, this commit, and it decides that with this commit, the next version will be 2.4. Previously, it pulls the previous tags and decide that the next one, since this is a minor one, is going to be 2.4. And automatically over here in my project, I can see the list of tags that I had before. So 2.4 is being pushed into my VCS, and the assumption is my 2.4 should be here. So this is TFC, and this is my private registry. My Super S3 module is here, and I have not only the documentation baked in, but as well all the input and output. A link to my code source as well. And my 2.4 is not here, but you can see the previous one that I pushed prior to this talk, 2.3. So what we have seen so far is the ability to push secure, reliable, and battle-tested modules. So later on, you can compose your solution to spin up a piece of infrastructure using a self-serve kind of mechanism, or even using another pipeline, as my colleague showed before. And this concludes my talk. What I want to send you guys as a message is your infra code is as important as your app code. Automate your workflow to catch bugs and problems early. Otherwise, it's going to get expensive and somebody will need to debug problems at 3 a.m. in the morning. Invest in your team's tooling and workflow to give them a better developer experience so they can iterate, innovate quickly, and deploy with confidence in production, perfect every time. And thank you. So I'll take questions in the chat, and I'll share probably the code source as well later on in the day.
Great. Thank you so much for that talk. I love the focus on treating infrastructure code as seriously and with as much care as application code. So thanks for speaking with us today. It was a great
Thank you
talk.
so much.
And no problem.
Thank you so much.
Up next, we have Thomas. Hello, Thomas. Thanks for joining us.
Hello, Jason. Yeah, great to be here.
Great to have you. So you're going to be talking to us today about learning Terraform while building a reference repository of code examples.
Exactly.
Yeah.
Story how I learned these things. Yeah.
I'm looking forward to it. We'll give the floor to you. Thank you very much.
Thank you. Okay, so hello, everyone. I wanted to talk today about an open source project called Terraform Examples, and to tell you a story of how I started contributing to that project. So to start with, just a little bit more than half a year ago, I started a new job as a cloud native engineer with container solutions. And then when I joined here, then I thought at this role, probably I need to learn a few things that would be important. So I thought Terraform would be something really important for working with cloud, and for sure learning about different cloud providers, especially the three major, most widely used cloud providers. I had quite some prior experience with things like all things operations, DevOps, config management, but those specific areas I thought I really need to learn more here. And actually, I didn't know where to start. Just to tell you a little bit about how I felt at that point, it was like I was a little bit worried that maybe I lack some basic knowledge around cloud and infrastructure's code as well. And also, I was a bit disoriented, to be honest, because learning about all things cloud, it is a huge space. So I really didn't know where should I start with this. But at this point, just second week into the job, I've seen this message from a colleague working with us in container solutions. So this was from Ian Mile, who is a well-known author of a few different technical books. Among those, there is Learning Git the Hard Way and also Learning Terraform the Hard Way. So what Ian said was, why not to start a project, open source project called Terraform Examples, with the aim as to create a really, really simple repository of examples to illustrate different kinds of Terraform functionality. And yeah, at that point, this really got my interest. So I was interested what is the idea here and how Ian described it. It was that, okay, the theme here, it is all about saving time. And we can imagine two different kind of users who would use this project. So one user is someone who is in a hurry, basically, and needs to get some feature of Terraform to get it working as quickly as possible and then to iterate on. And another possible user is someone who is just learning Terraform and wants to have some examples to play with. So I thought, okay, it seems I'm just this second kind of user. Let's see what I can do in this project. So basically I said, yeah, I really want to contribute here. And while doing that, I want to learn all about cloud and all about Terraform as well. Wasn't sure where to begin again, but what I thought was that, okay, actually I have quite some experience with Kubernetes. I know this area really well, and I'm also super interested in all things config management. So why not combine those things together? And actually, I started by working on some very simple at the beginning examples of how to use Terraform to automate Kubernetes. Okay, from here, let's jump into that repository, and I will show you the simplest possible example that I started with. What we can see here is our Terraform examples repository. There is a number of different providers that we use here and that we give examples. If we take a look to the Kubernetes examples and then the resource type config map, we've got some simple example here. And then inside this example, there is our main TF, where we can see this structure of typical example in this project. So before each block of code, we give links to documentation to help users to then deepen their knowledge. If you need to iterate on it, add something more, you can follow the docs. We start by configuring the provider to say what version is required. And then we move on to configure the resource itself. So what we can see here, it's like we use resource names that should be self-explanatory. Then, and after that, a very simple, like shortest possible list of attributes to actually create such resource. Then let's give it a try. I have a kind Kubernetes cluster running here. I have this example. We've got our main TF, and we also have two helper scripts. Those are run sh and destroy sh. What those scripts do, it's basically to run all the commands needed to apply the example. So if I do the run sh, it will do Terraform init, then Terraform plan, and then Terraform apply. If it would be a real cloud provider, it would handle also all the authentication needed for the cloud. But in this case, with Kubernetes, it was not needed. We can see the resource was created. It was a config map. And let's take a look into our cluster. So we've got a config map created. With the contents that we've just configured here. Okay, so that was the simplest possible example of what we have here. There are, of course, way more examples there. Some of those are more complex. So, for example, working with Kubernetes, we might want to create a few different resources at the same time and combine those together. You can see this, for example, in deployment and service. But let's keep it for now to keep on time. To talk only a little bit about, again, how we structure things here. So everywhere we've got links to documentation. All the content, we try to keep it as simple as possible. We use names that are unique across all examples so that you can combine multiple examples together when building your solution. And the attributes used here, it's also like minimum set of attributes. A little bit, again, about main principles. It's all as simple as possible. Self-contained, so limited to one file. And clear. Those names of resources should be verbose and unambiguous. What is the structure of the whole repository, the whole project? There are two main areas. One is to showcase different kind of Terraform providers, like if you want to work with AWS, Google Cloud, whatever else, any other cloud provider. So then you would get examples for different resource kinds there. And the other thing is different features of Terraform. So let's say you want to learn how to work with Terraform modules. And then you've got a very simple example, how to create a module and how to create a consumer that would use that module. That's the basic structure. And then another interesting thing about the project. So a few weeks into the project, a colleague joined us to create a web interface to this project. Let's jump into a browser very quickly. So you can not only just clone the project and use those files from there and scripts from there, but you can also browse in a browser. And there is a very nice search feature as well. So let's say I want to look for how to use the for each feature in Terraform. If I search for an example here, we can see two different examples, and one of them is how to create AWS instances with for each. And then if we go there, we've got AWS instance for each. And we can see here how to use the for each feature of Terraform with the AWS instance resource kind. So it's yet another way to use those. You can also just copy-paste code from here. Okay, let's jump back into the slides. The next thing I wanted to talk about is our CI pipeline that we've built into the project. So it's related to what Yasin was just talking about. So it's a good practice to test and check your Terraform code. So basically, we wanted to do it automatically, and in the pipeline, we've used GitHub Actions for that, and we've got jobs like to automatically run Terraform lint, to run Terraform validate, Terraform format as well, and also we've got those providers jobs which function is actually to apply each of the examples on the real cloud provider to check not only if we have a correct Terraform code, but also does it really work with the cloud provider. So by doing that, we can speed up the development process in this project by automatically verifying all the code. And then going back to my story, how did it go for me contributing to this project? What kind of progress did I make here? I started with those simple Terraform Kubernetes examples, then moved on to playing a little bit on how can I use Helm with Terraform, how to create different Google Cloud resources, how to use different backends for storing Terraform state, and then also worked on this CI pipeline, on those scripting. From there, I moved on to reviewing pull requests to help others as well, and then became a project maintainer. So it meant I started to facilitate project meetings and also helped with onboarding for new contributors to the project. And then I'm near to the end, but what have I learned in this project? So first thing was that contributing to open source, it feels really, really great. Like, it's great to be able to share what I've learned with others, and also to share something that could be useful to others. That was really good. Then I've learned that you actually don't need practically any prior experience before you can start contributing. So I was able to learn everything that was needed along the way, and that was really great. And the last thing is that even with such a simple project, it actually gave me opportunity to learn quite a few things. So I've learned about different Terraform techniques, about different cloud providers, then how to use GitHub Actions. And I've done quite a bit of bash scripting as well. Then the most important part, what we can see is basically a collage of all the people who has contributed to the project so far. So thanks to all these people, basically we've got now quite a big library of examples there. We've got a very nice automation for the CI. We also have a great front end. So yeah, a really big thank you for everyone who already contributed. And then to end with, just last thing, how can you contribute here in this project? I would say the first thing would be you can just give it a try, see what's there in this project, see how it works for you, and please give us feedback. Do you think it is good, or maybe we should improve something? You can create issues if you see any bugs or improvements needed. And we also have a list of open issues. So if you want to work on some pull requests, you can take a look on those issues and choose something to work on. And with that, I wanted to thank you all for listening.
Awesome. Thank you so much for joining us today. I always love kind of seeing like a good call out slide. It's just always great to see when people get credit for all the work they've done. And this was a great session. Thank you so much.
Thank you. Thank you for having me.
Yeah, thank you for joining us. We're short on time, so we won't be able to do Q&A. So we'll be going straight to the next speaker. So I'm excited to welcome up Andrew to come give us his talk. I'll just hand it off to you and you can get started.
All right, awesome. Thanks, Jackie. I'm really excited to be here today to talk about our journey as an organization from open source to enterprise and how that relates to a developer experience and ultimately to ship software in the enterprise. So yeah, welcome to my talk, Developer Paths with HashiCorp Enterprise. We're going to It's tackling organizational complexity to deliver software in the enterprise. Outline of this talk, we'll do a short journey with the open source versions of the stack. And I'm going to mention a bunch of challenges we had as an organization in terms of tech, but also people organization. And I'm going to go into enterprise-specific features for platform as a service building. And a few of the fun facts I learned that may not be as obvious to folks looking at the enterprise offering. And then I'm going to go into where we are today and do a little bit of a summary. Thanks for having me again. My name is Andrew Cornies. I'm the head of infrastructure automation at 2Cows. This is our organization. Our organization is made up of basically 3 different business units. 2Cows, if any of people who have been around for a while can remember the name for the first download sites on the internet. We've evolved a lot since then. And our 3 main businesses are fiber, building actual fiber in the ground in the States at the moment. We are also a big domain registrar with Hover as our first party brand. We are a domain wholesaler with the OpenSRS platform. And we're also getting into mobile enablement services as of late. So let's start with our journey for working with the open source stack. If you guys can remember, GDPR deadline was around May 2018. This gave us an excuse to do some new development on some new microservices to kind of tackle the requirements that came out of the GDPR mandate or ruling. So that got us a bunch of developers on the domains platform to develop Docker-based apps. And we originally were going to go with Docker Swarm. I believe we were encountering some issues with that. We weren't quite happy with, based on the complexities of learning that. But then we also we just started looking at the HashiStack because we had already used Vault and Consul in a previous context. And so because we were having trouble with Docker Swarm, we naturally chose Nomad. I believe it was 0.8 at the time to do our Docker-based deployments. And so we managed to meet the deadline more or less. And by the end of 2018, we saw Vault, Consul, and Nomad. It demonstrated good value, and it powered a significant portion of the domains business. And so now coming into that new year, 2019, the infrastructure team was hard at work at delivering a private cloud in 2 different regions of the north of the Americas. OpenStack based. This was pretty exciting for us internally as DevOps practitioners to utilize Terraform, because prior to that there was no providers based on the infrastructure platform we were running prior to that. This started an era of us as DevOps people, combined with a team of devs working on business apps. We would start terraforming a bunch of OSS stacks, so open source stacks for our various environments. This quickly turned into a lot of stacks. You can see kind of try to divide those stacks into different projects. This is sort of like these are groupings of different environments and team stacks to just, facilitate the different environment deployments in a pipeline. So you can kind of like, you can see how there's a lot of resources being created here. But, there are advantages. So pros for many open source stacks within our own organization, within our own private cloud, you get full isolation per environment, which is, I think, a good thing in a lot of ways, right? You get dedicated resources for your workloads. So all your VMs aren't, or all your jobs aren't contending with other jobs on the same virtual server or hardware. You have a lot of autonomy in terms of if you've, created a Terraform stack, an Hashi stack, and you are running with that and you're managing multiple environments, you're ultimately responsible. You kind of take ownership over that. And you have that autonomy to run that stack. And we were at the beginning trying to do internal Terraform module reuse based on an OpenStack provider. This was, I think, a good idea in theory. Now, I'll touch on that in a second. And this idea of like day one productivity for folks who would just take this Terraform module and they would run with it and run with it in their environment, in their project network space, and they would be productive on day one. So that kind of leads me to the challenges that we experience, the technical and the organizational ones. Cons. I think some of us, not all of us, but some of us bit off more than we could chew in terms of, okay, now we have a lot of environments, we have a lot of compute and storage resources being taken up. And remember, we are running private cloud, so that is an issue. We don't have infinite scalability. And our Terraform modules, they tended to be error prone. This might have been some execution on our part with using Terraform provisioners, and now we see some of those provisioners coming out of Terraform proper now. And general config management, so where Terraform ended, where did your config management tool begin sort of problems. And there was various levels of knowledge around those workflows. These things require DevOps knowledge, right? They require DevOps knowledge to maintain, and if something goes wrong, and if you don't have that knowledge, what do you do? Which leads me to the outage recovery. We've had instances where we have internal problems with your network, or a compute host goes down, you lose a node. All those things can happen and can contribute to a loss in quorum. And so you have that. You also have the ACL system. You also have just policy knowledge around the Hashi stack that takes a while to master, I think. And all of this requires a lot of cognitive overhead. It's complexity. And so I come to this idea of day two operations, right? Teams were not prepared to deal with outages when they happen. So we had network or compute failures. Sometimes our, say, console or Nomad servers, they would all be placed within the same compute host. That would go down, cause outages. Some folks who upped these stacks didn't know how to necessarily deal with that because they hadn't had a lot of time to master them. And ACLs in some cases were completely disabled for convenience. So, this is not great for security-wise. You're basically just trusting your entire internal network based on anyone who can be on the VPN to, not mess anything up. So that's a problem. And in various cases, there were instances of no console or nomad backups happening for most of these open source clusters. So day 2 challenges, I kind of categorize them into four things. Management over time. Clusters that run applications need to be maintained by folks with domain-specific knowledge as your usage grows. Security, right? I mentioned the ACL thing. We had little knowledge, or at least spread across the organization. There were folks who were knowledgeable of this ACL system, but not in all of these teams. Little security led to relying on internal trust. That I mentioned the outage recovery, domain-specific knowledge is required to recover from outages like Raft Quorum, as well as disaster scenarios with your backups. And the support challenge, right? Who do teams turn to for extra support? The autonomy seemed really great at the beginning when everything was working. And this is what our organization looks like. I shamelessly stole this from the Vault Enterprise webpage, but this accurately describes how our business looks. We have different business units. We have teams within those business units. We have sub-teams within that team. So this is our organizational challenge. So think of this and think about that slide I showed earlier about all those open source stacks being generated. That's a lot of resources and a lot of things to manage. And I'm going to go do a quick, not segue, but quick plug on team topologies. We use this framework as a way to organize our engineering teams. I think the basic things you need to take out from this is there are four main team types, 3 different interaction modes, and I'm kind of focusing on that platform team horizontal bar there that supports everything on top. And so, having said that, we at the beginning of I think 2020, we started this initiative to reorganize in this sort of topology, and this brought another organizational challenge. People moved around, and applications and stacks and other and other teams were kind of left, sometimes left without DevOps or Ops people at all, but we still had to maintain things that were running. So some common themes with all of our teams, I think, is secrets management, right? All teams need to deal with secret management, but they don't necessarily have the expertise to manage something like Vault themselves. We talked about so there being some complexities when you use these things over time in outage scenarios. I think everyone needs job scheduling. All teams need to deploy applications, whether they are web services, crons, or microservices. So in our case, I mentioned that we had teams lose DevOps members completely due to our team topology reorganization. So they'd be left with little or no dedicated ops people. And the final theme, I think, here is that regardless of all of this other, all these other challenges, I think everyone really wanted to focus on just writing the business applications, focus on shipping the software rather than the infrastructure to ship software. So how can the enterprise editions help facilitate a platform team topology? Like what are the buy-ins, right? Some of the things I think about are, does it do multi-tenancy? Will it reduce that cognitive load overall if we have folks more rely on a platform team? But then there's the whole autonomy and governance trade-off. These things are a lot of the times they're at odds with each other, right? You have folks who are very maybe senior level engineers who want all the autonomy in the world and trust, which can be great, can be really great for velocity. But you also have a governance issue, in that some of these teams may not do all of the things that are required to make a security person happy, or even just overall monitoring of a system may have varying levels of usefulness. So we see this sort of at odds thing between forging your own destiny and kind of working more closely together in a more organized fashion to kind of reduce the cognitive load on the teams that need to ship software. So what are the other buy-ins? Would enterprise editions help solve our open source challenges, like management over time? That one might be more team topology related. We need to create a team to support management of these things over time, so that may not be a specific tech thing. Security, would the enterprise editions help us increase security? Maybe. Outage recovery. Again, that might be something a little bit more around education and the support of a team and to help with outage recovery scenarios. There's also very specific tech level things that can help in the enterprise world around outage recovery. And support, not just like inter-team support, but also external support. How can we, if we really want to invest in HashiCorp tech, can we get outside help? We can't do that necessarily with the open source versions, right? We rely on the goodwill of maintainers, and you can have varying degrees of success with responses and whatnot. So, and that might not be good enough for your organization. And last but not least, multi-region. This is, in my experience, this is not really a thing that's thought about right from the beginning in terms of application design. But this is very much a thing that we're trying to make easier within our tech organization. Which leads me to Vault. Let's talk about the very specific things now Vault has helped us to do. Vault Enterprise, just to clarify. How has Vault Enterprise helped us kind of touch on those points? I think we heard a previous speaker talk about Vault Enterprise namespaces, right? I like to call our platform a Vault first platform, which starts with the Vault namespace. This is sort of the first thing that people see or do as a human logging into a system. This is the first thing they do in our platform is log onto their Vault namespace and check it out. These namespaces are cryptographically segmented from each other. They provide multi-tenancy segmentation, so that's great for the multi-tenancy item. That's great for the security item. But it's also great for the autonomy piece because namespaces have all their own secret backends, their own policy management, their own auth backends. It's a vault within a vault. And so let's talk about the multi-region problem. you can only find this in Vault Enterprise replication between sites. This is a really nice experience, or a consistent user experience for folks having to work in multiple regions. You seed your secrets once, and they appear on the other side. There is a primary and a secondary. There's performance replication, and there's disaster recovery replication. Which leads me to my first fun fact about Vault. So, which is not overly obvious when you are looking at Vault Enterprise, namespaces can have their own namespaces. So you can create this hierarchy that a parent's namespace can control a child namespace. So that's an interesting thing. We've had a couple of gotchas with at least Vault 1.5.7 in terms of setting quotas and whatnot. But that's just something we're working through with HashiCorp as well. All right, let's talk about console. Console namespaces, same thing. They provide the multi-tenancy namespaces. That means teams and environments and projects get their own service catalog and ACL policies and tokens. And those tokens are bound to register in that namespace only. And we have Console Enterprise in terms of the namespace and ACL consistency. We really want that. Those namespaces are a logical grouping that goes beyond our data centers. So it's like it's that concept of a project or a logical grouping that can work in multiple regions. WAN Federation replication makes that a really great user experience again for that problem of working with multi-region. Which leads me to my second fun fact about Console Enterprise, not overly obvious, but Console Enterprise namespaces, they require a parent policy to work, defined in the default namespace of your console server cluster. And also, it's also not overly obvious, or at least to me it was not, console network segmentation works differently than console namespaces. They are two things that kind of tackle a similar problem in terms of segmenting workloads, but one is configured much differently than the other thing. So keep that in mind. Keep that in mind when you're creating your namespaces and you're working with your different console gossip pools. And last but not least, Nomad. Namespaces and quotas. Again, that namespace thing is really, really useful for us in enterprise, multi-tenant platform. Namespaces and quotas allow for multi-tenancy and governance across the shared cluster of machines. Further segmentation and scale can be achieved through dedicated clients, metadata, and Sentinel. And I want to go into that a little bit. Sentinel in action. Now, this is not a Sentinel policy. I have links to it down below. I found out about these Nomad guides just out of opening up an issue on Nomad itself. Someone was really quick to respond and tell me that this is how I could achieve what I wanted to do. Because we're doing a multi-tenant platform and we're using the same Nomad masters and multiple environments, we needed some way of job constraints, and that's we use the namespace value, and we assign that value, that same value, to the Nomad clients that we either generate automatically with the cloud provider or we Terraform ourselves. But we need some way of enforcing the constraint on a job so that we don't have folks scheduling work on your Nomad clients in your own space. So Sentinel is the only way that I know of right now that you can enforce a policy to say, I want to make sure these Nomad clients have the same metadata value that matches my job namespace value. The same thing with Nomad Enterprise. We need that multi-region consistency. The federation deployments, this makes deploying a job using the multi-region or the region stanza super simple, and that's a great win for cognitive load. With the replication, you get shared policies, and global tokens can be used across data centers. And this fun fact deserves a slide, just to illustrate. With Nomad Enterprise, everyone, I think people who are used to Nomad by now knows about the Vault stanza. You can specify a namespace, a Vault namespace to match your Nomad namespace with Nomad Enterprise only. So that's a pretty big win in terms of the integration between the two things. All right, that leaves me with where are we today? Like, how did we implement this internally? We have two modes. Developers and DevOps people can use to interact with our HashiCorp Enterprise clusters. One mode is just submit a job and don't worry about the Nomad clients. This means that we can have a shared pool of Nomad clients. They can still manage all their jobs within their own namespaces. So when you get a shared pool of resources, it doesn't mean that you actually share a job namespace logical grouping. So that's a nice win, so that you can have a namespace that utilizes the shared cluster, or mixed with a namespace that also schedules work on dedicated clients. And we found this was useful for like these use cases, teams that have limited or no DevOps resources dedicated to a project, really simple services that people just wanted to throw at a scheduler and run, ephemeral services, anything that doesn't require storage or anything like that, and something that has already the ingress into the cluster kind of already set up for you, so you can reach the service that you've launched on that shared cluster through an ingress or load balancing convention that we've set up internally. Pros with this method are, you manage a job HCL only. There's no infrastructure. You get managed upgrades with this. So our team manages this, the upgrade of this cluster, and you don't never really have to worry about it. I guess the trade-offs are teams do not have control over these Nomad clients. So basically, whatever drivers are available on that shared pool, you need to work with. And we don't recommend running any jobs with persistent storage in this mode, just because it's a shared mode that, workloads that require storage require a little bit more configuration and a little more thought up front. And we have the second mode, which is our self-hosted mode. Self-hosted mode, I was just kind of describing earlier with that Sentinel policy and that Sentinel constraint that we set in place, where you can terraform your own or create your own Nomad clients however you want, attach them to the centralized scheduler, and run your jobs on those dedicated clients. Use cases. Teams that have their own dedicated DevOps members. Projects that require a higher degree of service isolation use this mode. Project and team require their own console KV catalog, and that was one of the things I forgot to mention in the previous slide. In that managed mode, you have kind of one shared catalog in console. So in this mode, you get your own catalog. You get complete management of your Nomad clients connected to the Nomad servers. You get your own namespace for console namespace for your own service catalog. You get to manage your own storage plugins. If that's a new thing that's come up for Nomad. That's pretty exciting stuff. You can use CSI storage plugins or use your host volume configuration. But this mode requires that you do your own kind of ingress load balancing into that cluster of machines. Requires DevOps knowledge and separate cloud management for that. So what we really wanted to do for this developer platform as a service is what is the quickest way to Nomad? Nomad jobs are the right amount of cognitive load for developers who also have to deal with business apps. Our new platform team topology manages the rest of the enterprise stack. So that burden is on the platform team and not everyone who needs to ship software. We're doing some experiments internally, an internal tool being developed called Mortar to kind of see what it feels like to have some more self-service around namespace generation, stack generation, and then the quickest way to Nomad, right? The quickest way to Nomad and those dedicated clients. And I'm really excited about the Nomad Pack announcement that happened with the latest version of Nomad, and definitely going to take a look at that. So in summary, I'm just keeping an eye on the time here. I think we've really tackled a lot of these problems or these challenges with the enterprise investment, and we've really seen it work over the past year. More and more teams are getting onboarded with our internal tooling, and yeah, I'm excited to see this thing grow. Thanks very much.
Thank you, Andrew. It was a great talk. As a former HashiStack runner myself, I always like people spreading the word.
Yes. Awesome. All right. Take care. Thanks again for hosting.
Yeah, thank you so much for joining us today. And our next speaker coming up, I can't speak today either. The next speaker we have joining us is Sebastian, if they are ready.
Yeah, I'm definitely ready. Hi, everybody.
Wonderful. Thank you so much. And I guess we'll just hand it off to you and you can get started.
Perfect. All right. I just want to make sure you guys can see my screen. All right. Hey, my name is Sebastian Maniak. I'm an entrepreneur, consultant, advisor. I actually own a couple companies, S14 Inc., where we do consulting services, Maniac Ventures, and a new company recently that we launched was Crypto ATM Bank of Canada. And I'm also a professor at Sheridan College teaching applied network securities itself. So what I wanted to talk about is really in the security space and how are we using some of the HashiCorp tools, specifically kind of cybersecurity mesh. So right now, ranked #1 on the Gartner's top security and risk management trend of 2001 is this thing called cybersecurity mesh. You guys seeing my screen move here? Oh, it's a little delayed. What is a cybersecurity mesh? Well, it's machine authentication and authorization. It's machine-to-machine access. It's human authentication and authorization. And of course, what I want to talk about is human-to-machine access itself, right? Identity really is the core of Zero Trust. And I got this off the HashiCorp site. In order to verify everything, the core building blocks for this is going to be identity. Everything that we're going to do is centered around machine identity or human identity. When I refer to human identity, I welcome my linebacker, which I call boundary. My linebacker, boundary, just like a linebacker, are members of the defensive team. Linebackers are most versatile players really on the defensive side. They're defensive linemen and defensive back. So in my view, boundary is really defense and boundary is versatile. For my company, it actually provides a secure way to access our hosts, our EC2 instances, and our critical systems without having to manage credentials or exposing our networks. With boundary, we actually eliminate the use of VPNs, so our consultants and our contractors don't have to VPN on the network. They just use boundary to connect to our instances. It provides this intelligent proxy that creates a granular identity-based access control for dynamic infrastructure. And the workflow layers security controls and integration at multiple levels to help us monitor and manage user access. So when we started our company, Crypto ATM of Bank of Canada, we started using Boundary to provide access to our consultants, right? Boundary kind of provided us this simple way to verify users, to have secure access to our EC2 instances without exposing our network. It helped us build this open source workflow, really that just enables us just-in-time role-based access for dynamic infrastructure. Right. When we deployed Boundary with Vault, we wanted to make sure it's easy for us to manage onboarding and offboarding users. On a typical week, we have maybe 3 to 4 or 5 different consultants join, and leave to perform small little tasks. So we integrated with Azure AD so we can provide this easy onboarding when those consultants require access to our servers. We started actually using Boundary with 4.0 when they added Vault integration for brokering of Vault secrets, right, to the Boundary client via either the command line or the desktop. So our consultants have the capability of using whatever machine they want, as long as they have access to a command line, or they can download the desktop client. They can connect to any of the EC2 instances that we have deployed for them. So let's quickly talk about, or a high-level perspective of the Boundary architecture. The Boundary architecture consists of these controllers that you'll be deploying, a Postgres database, your KMS to store your root and recovery keys, and these workers. So when we deploy workers in production, we actually split them across availability sets. And I just want to credit Joe because I actually stole this picture from him. I really liked it. It was very simple. These Boundary workers really just make a proxy connection to our targets, either be in AWS, in Azure, but they're able to SSH. We can do HTTP curl commands through them. We could RDP. We can connect to our Postgres databases. And for the human or the user to interact with these targets, they can use the GUI, which I'll show you guys, and the CLI to really proxy into those EC2 instances, right? So from a demo perspective, I kind of built this demo out using the HashiCorp reference architecture in kind of this repo below. But really, we have 3 controllers spread across 3 availability zones, and then we have 3 workers. We have an ALB configured that's managing the controllers to load balance us to the appropriate one for persistence. Then we have our targets, our EC2 instances. In this case, we built 2 for this lab that allows our client or human to connect. And then we also deployed Vault because we wanted to do credential brokering, right? So let's take a quick look. Let me share my other screen here. And click this demo. All right, share. So I think I should be sharing that. Perfect. So in my web browser, just want to quickly show you some things that we deployed. So here is our demo environment deployed in AWS. We have our controller. We have our target hosts, target host 1, 2, 3. We have Vault deployed. We have another controller and a worker. This is the worker that's going to proxy the connections on here. We can tell that these target machines, they don't have public IP addresses. They're all private. We keep them private. We don't want anybody to log into them until they're actually authenticated through through Boundary itself. Right. So let's take a look. This is, once we deploy it, we have our load balancer here, or URL that connects us to Boundary. We can just log in. And here we have our Boundary admin GUI interface. In here, we have different projects. So just for this example, I have a core project, just core infrastructure, with a set of users, in this case, just an admin user and authentication methods. Just for this demo, I have literally just a password authentication method, which I'll show you how it's done, authenticate to the CLI. When I click on projects, I have my core infrastructure and I have my sessions. So these are existing or terminated sessions that logs for any user that's logged into. We have our host catalogs. So a host catalog is really a collection of hosts or host sets. So for example, I have a host set or a host catalog of AWS servers. I can click on that, and under host sets, I see 2 of my Linux servers that have their ID, and they actually have the private IP addresses in here, as you can see. Once we have host sets, we have targets, and these are really just like our Linux servers or our F5 machines maybe, or whatever devices we have in the cloud. We can click on that and we can see we have the actual target ID, what the source IP address is. If I scroll down here, where is it? And then what we also have is this credential source. So because we're using Vault to provide our credentials, we've configured Vault here with our Vault address, our token, which is already, it's gone here, and a library that's associated with that host catalog or those targets itself. So let me jump on my other screen and I'll show you how we authenticate through the command line. Perfect. Let me just make this a little bit bigger. So because this is a lab, what I want to do is kind of just show you the process of how we authenticate through the CLI. So first thing I'm going to do is I'm going to export my Boundary address. So my Boundary client that I have on this machine can talk to my controller. Then once I'm connected, I actually can figure out a method. So when I give access to some of our consultants to be able to connect to Boundary to manage some EC2 instances, they have either the desktop app or the web client. They can actually just list all the methods they're allowed. So if this user, okay, I'm allowed this method, here's my ID. So now I'm going to authenticate. I have a simple kind of password in here. So I'm just going to paste this where I'm doing Boundary, authenticate. I have my login name, little password, and here's the authentication method ID. If I'm using OICD, right, Azure AD is going to pop up and I'm going to authenticate that way. So let's log in. So now we have successfully authenticated to our controller, to our Boundary system. We want to make sure we take a look at maybe some of our scopes, right? So here's a scope. So what is a scope? Well, you know, scopes are really the foundation part of Boundary. They allow users to really partition resources and assign ownership of a resource to principals, right? And there's really 3 types of of scopes. We have a global one, organization one, or project scope itself. So if we take a look at our scopes, so let's go Boundary, scopes, list, scope ID. And we take our ID here. We're going to go equals and paste it. We have that project. So in the GUI, when we saw the project core infrastructure, and this was the ID itself. Now I could take a look at, as the consultant, well, what kind of access do I have? I've authenticated through Azure, and now I want to understand what targets you know, the person let me into. So let's go Boundary targets, list, scope ID equals, and then I'm going to paste this command. So right now I see a lot of things. I'm the admin, so I do have a lot of actions to be able to perform on this project. but I see my target ID and my Linux servers, and then I have my Vault server itself here. So I'm just going to copy this, and I want to SSH into this device. If I have Boundary installed, I can just use Boundary Connect to SSH into it. So pretty simple. If I do Boundary Connect SSH, I'm going to do username, Ubuntu, and my target ID equals, I'm going to paste that out. Oops, I spelled target wrong. Target ID. Boom. So what happened now was that I trying to connect to this host, but because I have Vault credentials configured or Vault brokering, it actually spits out the secret, right? So in the current version of Vault, it doesn't do this automatically for static secrets, but for dynamic secrets, you have the capability of automatically getting the password pushed in here. But right now, for just static secrets, it gives me the data and the password itself, where I can paste it, so I don't ever have to remember this password for this EC2 instance. And then I'm able to log in to my host, manage it without a VPN. So I'm being really proxied directly through the worker into this host itself. So exit. As an administrator, right, I can also look at my sessions. So if I do show my sessions, it will show me all the sessions that I've had before, that I've done for this machine. If I want to see, let's take a look at the red session. So if we want to get more detail on specific sessions, we can read this user ID in here, and we can understand, oh, you know, this consultant, right, logged here, disconnected here, logged in here, disconnected here. We have a full trail of when that user and that token and that access was allowed and used itself. So next thing, what I'm going to show, hopefully, let's see if this works, if I can share my desktop. Well, that might be too big. I'm going to show you guys the actual app. So where's my Boundary app? This is perfect. So this is the desktop application that some of my users can download. Really, they download this app. It works on Windows, Mac, and Linux. They're going to select the organization that we have deployed. So in this demo, it's just called Maniac Academy. I'm going to put in my password. So I'm authenticating to the controller, and it's giving me a list of all the targets. So it knows that I have access to this Vault server. I have access to this Linux server. If I don't want to install the boundaries commands, I can use this GUI to connect, and using whatever tools I have. So in this case, I'm using a Mac, so I can use SSH. So let's see if this, I want to show this up, but let's just click on connect. So I'm going to connect to this Linux server inside of the app. It gives me an actual proxy URL and a port to connect to. And then if I just look at the raw data, it actually it went to Vault and grabbed the thread. So password is happy hacking. So we know the port is 52765. So if I switch over to my command line, and if you're using PowerShell or curl or putty, you can actually use those tools itself to be able to connect. So I'm just going to share my other screen here. Yes, perfect. So now that I've connected on that port, literally I can use the SSH command, -port 5275. Ubuntu is my username, 17001. Yes, I want to connect to, put in my password that I pasted from the app. and I'm able to proxy right into my environment. So let me exit that, and we'll take a look at how we actually configured this. So let me open up Visual Code. And everything we deployed here in this lab is deployed, wrong screen, is deployed in my repo. So anybody can take a look at the code itself. And here we go. It's not too complicated, but really we have our AWS infrastructure, we have an Azure infrastructure, GCP infrastructure, and then we have our boundary configuration. If we take a look at exactly what we just deployed here, we have our host catalog, which was AWS. We have our Linux servers. Those are just the private IP addresses for this demo. We have our host set that matches those host IDs. And here we have our, our temporary that we deployed for this demo, where we're grabbing credentials. So we created a special token and a policy in Vault to do this. And also we created that credential library where we're doing a path to Infradata AWS. So this is how, we as a company really are using Vault and Boundary to provide access to our consultants, and without the need of a VPN or even managing a VPN itself. I don't know if anybody had any questions, but that was the end of my presentation, just to demo out Boundary.
Awesome. Thank you so much for giving the presentation. I don't think we have time right now to do Q&A, but we really appreciate you coming on and sharing today. And I didn't actually see if there's any questions in chat right now in YouTube, but if there is, feel free to respond to them there.
Awesome. Take care.
Thank you so much.
All right. Up next, we have Luis, who's going to be talking to us about understanding Nomad network patterns.
Hi, everyone. Let me start my screen share here. Cool. Hope you all can see my screen here. My name is Liz. I'm an engineer here at HashiCorp working on Nomad. And today I'm going to talk about something that comes up pretty often, which is like, how does Nomad do networking and how, what kind of patterns there are. I tried to do slides about this, but it got so confused that it's better to just do them live and then you follow the progression of the mass. So I'll be trying to draw the slides as I go. Hopefully things will make sense. So before I begin, let's give a quick intro to what Nomad is. Not everyone is familiarized. So basically imagine if you have your app, and then you have a bunch of machines that you want your app to run on. What you do is you need to manage and make sure your app is running on your infrastructure, make sure if it crashes, it comes back up. So it's a lot of work that you need to do. So that's exactly where Nomad comes in to help you. So Nomad kind of sits between your app and your infrastructure in a way that will abstract away the exact details of what's running where, so you don't have to worry about it. The problem is that you do have to worry about it sometimes, and those times are exactly like networking. So you don't care what's running where most of the time, but when things need to talk to each other, now you need to know where things are running and how to communicate with them. So that's usually one of the first big steps that people starting with Nomad hits. And just to give a quick intro of the vocabulary that I'll be using. So when you're defining your app, you normally is going to create a job in Nomad. So you create a job, and inside a job, you have groups. So you can have multiple groups inside the job, and your group is going to group multiple tasks. So inside of group, you can have multiple tasks, and your task is like what you're actually running. So your task can be like a Docker container or like a Java jar or whatever you need to run. You're going to define that in the task, and then your group can have multiple tasks. When you're actually running on Nomad, so when you submit this job, your group is going to become an allocation. And at the group level, you can define your count, which means how many allocations you're running. So let's zoom in a little bit on your, on your machine, like understand what the allocation actually is. So when you run the allocation, Nomad is going to create sort of like an isolated space for all the tasks inside that allocation. So in this example, we have 2 tasks here. Nomad is going to start basically 2 processes. And since the allocation always run, so every task in allocation always run in the same machine, like Nomad guarantees that this is going to happen. That's our first basic networking pattern. Like how does one task talk to another? Well, since they're in the same host and in the same network namespace, then you can just like talk over localhost, right? So that's like the first networking pattern that you're going to find in Nomad, and probably the easiest one. Is just like connecting connecting tasks together, right? So if you have 2 tasks on your group and you want them to talk to each other, so for example, you have a main task and like a sidecar proxy or something like that, you can just go over localhost because they'll be running on the same machine on the same network namespace. Cool. So that's the first and easiest pattern. But things only get interesting once you get multiple machines, and then you have like things running on different places. So let's kind of draw that now. So imagine if you have 2 hosts here that, and then you have like allocations. So for example, you have your app running over here, and then you have your database running over here. How do you connect your app to your database? Well, as you've seen before, your app allocation will have a task running, your database will have a task running. So what does Nomad actually do for you in terms of networking? Well, when you're defining your group, meaning how your allocation is going to look like, you have this block that you can define in your job spec called network. And so you're going to define inside your job, you're going to define your network, and inside the network, you can specify which ports you want to use. So let's have a port for a database that is going to map to port, 3306. So there's like a MySQL database. So you have this on your job spec. So once Nomad reads this and gets this information, what it's actually going to do is it's going to take a port on the host. So like your machine has a bunch of ports assigned there. So Nomad is going to pick a port that is available and is going to make that connection for you. So here we have port mapping to port 3306. So Nomad is going to pick any port that is available on the host within that predefined range that comes in. So you're going to pick a port and it's going to connect to your task, and also assign like a host IP. So imagine this machine has like IP 10.025, for example, and Nomad picked the port, 22.104 on the host that gets connected inside your task. Let's say it's a Docker container, for example. So inside the Docker container is 3306, right? So that's what Nomad does for you. It does this mapping of host port to task port. You could also specify a static port here so that it always maps to a specific port on the host. But that's usually, it's good to avoid this because you might have port conflicts or things like that that will prevent you from scheduling things. So normally try to avoid static ports unless very specific scenarios. But in general, Nomad will assign a port for you dynamically. So now the question becomes, okay, I have an IP and I have a port, but my application can like move around, the IP can change, the port is dynamic. How do I actually know how to access? Like my app needs this information. Where do I get it from? Well, that's the second thing that you can define inside your group, which is a service block. So once you put a service block in your job, you're going to have to define a few things, but the main things are like the service name. So let's say you have a service name called DB and which port to use. And this port is going to map to the port we have here. So now we have a port DB that, remember, becomes a dynamic value at the host. But when you're defining the job, you can use the port name here, and Nomad will do the right thing. So once you have this service block, what Nomad would do is Nomad would talk to console. So now imagine you have also have a console cluster connected to infrastructure. So now Nomad will get the information that you have here in your service, and is going to automatically register in console. So inside console, what you're going to end up with is sort of like a phone book of sorts of your services. So all the name, IP, and port, which is like the basic information that you need to connect, will be stored inside console. So now we're going to have a name DB. The IP is going to be the IP of the host here. So 10.0.2.5. And then the port is going to be this dynamic port on the host as well, right? So this is what gets stored in console. And now your app can go from console and read this information over. So like Nomad can go into console, pick this information and provide it to your app, so that when your app needs to talk to the database, it just goes into console, finds that information, and just makes like that direct connection to the right port. Okay, so this is what's called service discovery. And it's kind of like the second pattern for networking Nomad. It's like almost like finding the catalog and finding information there, right? So you read from console those values, and Nomad make sure that those values are up to date. Now, how do you consume those values? Well, console provides you like an API through a few interfaces. So there's like a RESTful API if you want to use directly from your app. You can also use things like console templating to render out dynamic values based on the data in console. Or you can use like the DNS interface that console provides as well to read out those values from their app. There are also some native integrations that tools have. So for example, Trafic has native integration with console, so it can read the console data directly. Fabio is another popular tool that also has this sort of native integrations. So that's how you pull data out of console into your app so that you can find this route here. Cool. So that's like the second pattern, and probably like the most common pattern so far used in Nomad. So if you want to connect things running on different hosts, you're going to need console just to keep this information and propagating this data to your apps. Now, I mentioned the static port here that is not very good to use unless like for specific use cases. So let's talk like which use case would be useful to have this sort of static port. Again, imagine you have multiple machines running, and then you have like your app running over here and over here. But at the end of the day, what you have is like you need your users to be able to access the app, over like the internet, for example. So how do you go from the user through the internet to your app? Normally, like if you're like in a cloud environment, you might have like a load balancer sitting in front so that the data come in. And then you might have a layer of sort of like ingress control or proxies that you have running. And then your load balancer is talking to all of them. And then that ingress will redirect the traffic to the appropriate allocation. So like that's normally how the network flow is going to be. So it's kind of like similar pattern I've seen before, but it's kind of special in some sense because you're doing traffic ingress. So in this case, you might want to put like a static port here, usually like port 80 or 443 or things like that, so that your load balancer can always find the right port without needing to resort to console. Because the connection here from your ingress to your application will just go over to console like we've seen before. And this connection here from your load balancers to your ingress hosts are just going to be over a static port so that it's a stable port that the load balancer can always hit. So this is like we normally use something like Nginx, Trafic, or other like popular tools to do the startup proxying. You just need the extra layer of console to do the upstream connection and configuration. Cool. So that's like another pattern that is pretty common on Nomad. People usually get tripped as well about like how do I make my connection, or how do I expose my app to the users? Well, it's just like service discovery, but a little bit specialized because you're using a specific proxy or you're using like static ports to make that connection more stable. And then the next pattern that I want to talk about is like, imagine, like there's all this sort of like registering information, reading information back. There's a lot of like manual things that you need to do. But imagine that, let's draw again that scenario where you have two machines. One of them is running your app. Then one of them is running your database. Now, if you need to register information, read it back, why not just, it would be much nicer if there was like this like secret box or like magical box that would just do this for you. So like if your app needs to talk to database, you can just talk to this magic box that will be running on the same allocation, right? So as we've seen in the first slide, if they're in the same allocation, all of this is going through localhost. So your app talks to this magical box and say, hey, I need to talk to the database. And then somehow magically, your magic box can talk to your database magic box. And then your database magic box talks to your database again over a local network connection, gets that information and ships that information back. Now, since these are like magical boxes, you also get a lot of like nice things. So for example, imagine if these magic boxes also knew how to encrypt the traffic automatically for you. So you don't need to worry about going over like public networking because all the data is automatically encrypted. So if you have a world like this, things would just work and you don't need to worry about what's running where. You just need to ask your magic box for this information. And that's exactly how console service mesh works. And the way that it gets implemented, or like how you deploy this in Nomad, is that we've seen the service block before. But now when you're doing, for example, when you're declaring a service for your app, you just need to provide a connect block. And in this connect block, you define your sidecar proxy. And inside your proxy, you define your upstreams, meaning which other boxes you want to talk to. So inside the proxy, you have upstreams. And your upstream is going to define your destination service. So for example, the app needs to talk to the database, so it has a destination for DB, and the local bind, I think it's port, which is which port to use for this local connection here, right? So if you put this on your job, what's going to happen is Nomad is going to read and notice that this block exists, and it's going to automatically deploy this magical box inside your allocation. So every time your app runs, Nomad is automatically going to deploy this magical box. And then console, well, Nomad is going to read the whole service thing, as we've seen before, and ship that to console. But now, since that we have this connect blocked, console is going to talk to the local console agents that are running inside of each host here. And it will provide all the information inside your sidecar proxy so that it will automatically configure it so that this box can talk to this box, right? So this is very neat. So now console will automatically configure the magical box for you so that all your connections become basically automatically and transparent to you. And as we mentioned, there are nice things that you get from it. So for example, you get automatic mutual TLS encryption. So over any type of networking. You also get things like intentions. So you can define rules saying that app can talk to database. So this is approved. But if database tries to talk to app, you can reject this. So this is sort of like, so intentions is sort of like a firewall at a more like human level or a more application level. So they're easier to define and they don't rely on specific IP and ports since those things are dynamic. So this pattern is called service mesh. And it's probably like the newest sort of pattern out there, and it's pretty cool. And things just like magically work. It's called service mesh because everything that has that magic box sort of becomes isolated from everything else. So if you want to use service mesh, you also need to set your network mode to bridge, meaning your allocation is essentially isolated from the rest of the network. So since they're isolated, you won't be able to talk to anything inside of it unless you have that special box. And your box will not be able to talk to things outside of the mesh unless the target also has that box. So that's where gateways come in. So if you need to have things from outside of your mesh talking to things outside your mesh, you're going to need a ingress gateway running out of space. So I'm going to put here in the corner. Hopefully it'll be easier to understand. But the ingress gateway kind of makes that connection from outside the mesh to the mesh. And if you need for things inside the mesh to talk to things outside the mesh, you're going to need what's called terminating gateway. And the terminating gateways would do the opposite. So you would take traffic from inside your mesh and then route them through things that are outside the mesh. So that's the fourth pattern we see. Very nice, very transparent. You might have harder time debugging when things go wrong just because there's like so much going on. But once you get used to the underlying actions being happening, you kind of get a feeling of like where things could go wrong. So if your app cannot talk to database, for example, you might want to debug like connection per connection. So can your app talk to your proxy? can your proxy talk to the other proxy? Can the other proxy talks to the other service and things like that? But once it works, things are just like magic, and it's very nice to use. There are other more advanced things that you can do. For example, you can use CNI plugins to auto-configure your underlying network and things like that. I won't be going over those because they're very kind of specific to different plugins and drivers that you're using, but Nomad also supports CNI plugins. And that's it that I had for today. Thank you.
Thanks very much, Luis. That was a great tour of some of the networking capabilities in Nomad. I especially like the focus on the mesh and the ins and the outs. Was something I struggled with when I started to do some of that wiring. So I'm sure others who are watching got into that. Yeah. Thanks for your time today. Over to you, Jackie.
Yeah, definitely. I think you're already off screen, but if you hear me anyway, just be sure to check out the chat because there's some great comments about your talk on there, Luis. And I'm going to introduce next is Mark coming up to speak with us. And I will just hand it off to you so you can get started if you're ready.
Sounds great. I sure am. Give me 1 second. I'll get my deck shared here. And should be this one. And give me 1 second. We'll go do the presenter view, and away we go. Is that looking right? Sorry, I'm doing this on one screen. I normally have about 3 or 4, so it's a little bit awkward, but we'll get through it. Yeah, you guys are seeing everything. Okay, cool. So my name is Mark LeBlanc. I'm a delivery leader over here at Arctic here in Toronto. Spent a few years playing around with the HashiStack and some of our cloud journeys that we work on quite a bit. So what I'm talking about today is just around the idea of legacy services on service meshes. So what is that exactly? So I kind of threw some terms up here that come to mind when I think about what it is, where this idea came from. So we're talking about service meshes, we're talking about microservices, we're talking about Kubernetes. And what do they all have to, why does it matter? Why does it matter? The question kind of came up, we were thinking about a while back. Everyone today is talking about microservices, service meshes, really rapidly changing infrastructure. And the big question was like, what about all the other stuff that's not there yet? So that's where this talk kind of came from. That's the premise. We're going to do a bit better explaining the story here. So what we're seeing in the industry, what we're kind of encountering is there's a huge push to go from these monolithic, these static applications over to a more highly dynamic configuration. We're seeing this span different cloud providers. We're seeing this span across to private clouds and different platforms. People are going serverless. They're kind of all over the place. And where they're coming from, if we think about where we're coming from and why service meshes have kind of come to be, if we look at the traditional approach to networking, we had a highly static footprint. It was scaled, it was built for a certain size. We would put a large networking infrastructure. It would be there, it would be static, it wouldn't change very much. It would be very ticket-driven change processes. So if you needed to make a change to upgrade a device BIOS or whatever, you would have to put a ticket in, you go through a change process, take a long time. And there's very complicated firewall rule sprawl. So that's kind of where people are coming from. That's the static monolithic applications that we've seen for the last little bit. Where we're going, if we think about, let's talk about Kubernetes use case for a moment. Everything is dynamic, everything is ephemeral. So we have these services that are coming up, they're living for short periods of time, they disappear, they come back online with a different IP address, maybe in a different availability zone. The network perimeters are a lot less clear, and we're seeing a lot more predominantly east-west traffic across this infrastructure. And so to answer that, service meshes started becoming a big topic. I think when I first asked someone about Consul, it was described to me, this was a few years back, well, Consul is a backend for Vault. It's a key value store. That was kind of my first introduction to Vault. And probably, I think it was mid 2018, about Consul 1.2, I think, a component of Consul called Connect was released. And that brought service mesh capability to Consul. So why are we looking at service meshes? Why was Connect so interesting? Well, we're bringing service discovery. We're getting more rapid ways for our platforms to discover these services as they come online. We're getting increased observability. We're getting really fine-grained access control through ACLs. There's things like intentions in Consul that I'll show you in the UI. And we have secure service-to-service communication and traffic governance. All really neat things, but I'm not going to focus on all these today. Today is really about that legacy service and why does it matter. So these are the things that service meshes are bringing to the table. But the important thing is that it's happening at the platform level. So we're taking the complexity of making sure that things are baked into the application layer. We're pushing that down to the platform level and making sure that it's just there by default. So that's an important part of this message, that once a service is on a service mesh, it has these features available just by default. So one of the patterns we see with service mesh, and especially with Consul, is putting them on Kubernetes. I don't know that we've worked a project in the last 2 years where service mesh isn't part of the discussion. Maybe it's not part of the ask, but it's definitely part of the conversation. When people are moving microservices, they have to have that answer. How are you going to serve that traffic out, or serve that access out, and make sure that it's secure and make sure that it's getting where it needs to be. So Consul on Kubernetes is really nice. It's one of the nicest things to work with. It's super easy. You can install it with Helm. There's a really nice official Helm chart for it. You can set up the auto sidecar injection. And it really fits that dynamic services model for discovery. It does it really well. I know there's a bunch of stats published around how quickly Consul can get these things advertised. I don't know them off the top of my head, but they're very well documented and out there on the interwebs. So what it looks like when we deploy this in Kubernetes, you have service, it has a sidecar proxy, it's got secure communication via MTLS over to a neighboring service that you're trying to connect to through the sidecar, and that connects to service B. Service A talks service B, straight line, makes sense. Starting in Consul 1.6, and this was about probably mid-2019, I think, Consul added another feature called Mesh Gateways. And this gave us the ability to spread that service mesh across data centers. And I did grab an architecture diagram off of the Consul site, and I'll just go over some of the points really quickly because it's kind of interesting. So at the top here, we can see that we're defining the mesh gateway to be federated across the two data centers, that dashed blue line. But what's really interesting is the data plane that's represented by these three colors at the bottom, the yellow, orange, and the blue. And probably the most important line to take a peek at is this blue one that is showing the point-to-point communication. That's one of the main things that I think is really interesting with service meshes, is the point-to-point communication that's secured by MTLS that we get when we start enabling this type of service. So if you sort of think back to what I was saying a couple of slides ago, I was talking about how easy it is to work with Consul and Kubernetes. It's kind of, it's a dream, how easy it was to just kind of get running with it. This is what it kind of looks like. This is a pattern I think that people assume we'll be going with. Put a Consul cluster on one Kubernetes cluster, put it on another, enable the gateway, away you go. We have a federated Consul mesh across two clusters. It makes sense. You're going to have these highly dynamic services in both clusters that can do service discovery really quick. We can secure it. We can do all kinds of neat things with service meshes. But the reality of what is out there is we're left with a blend. People aren't automatically saying, yes, I want microservices, and then tomorrow they have microservices. They have all the answers. No, what we're really seeing is we have some legacy services, some monolithic application or service that's sticking around, as well as those microservices, those newer services that they've deployed. I'm sure if this was a live audience and I polled and said, does this sound like something you're faced with? There'd be a lot of heads nodding. So if we step back and take a look at what's that high level architecture of the federated service mesh, this is what it kind of looks like. And if we kind of forget about the fact that it could be Kubernetes on the left or the right, or VMs on the left or the right, or serverless, this is the architecture. It does not matter. Because Consul has the ability to be injected into containers, we can run it on VMs. This is what it looks like. So if we had on our right-hand side here, if we had VMs, we can install our Consul cluster there, we can enable the mesh gateway, and we connect that up to GCP, which could be running a Kubernetes cluster or VMs or whatever it is you have. So that's kind of the points I wanted to get across, but I wanted to take a look because I wanted to showcase a couple of quick things. One of the things I wanted to show was, again, how easy it is to get services on a service mesh in Kubernetes, because I think that's really cool. And then what I want to do is just show some of the communication that can happen across that federated link. So let me get back to this platform so I can switch the screen I'm sharing. And it should be this one. All right. Now that it's shared, I have to actually find it. Here we are. All right. So here's my repo that I used when I was sort of setting this up. Now, take a look in I have a Kubernetes cluster running that I've deployed Consul on already. So I just wanted to show a quick look at what that looks like. Various things in various states. I also have a number of VMs that are running. So let me just explain what I just showed here. On the top, these are the pods running in my Kubernetes cluster. This is the Consul cluster running on a GKE node cluster. These 5 servers down here, Consul 0, 1, 2, 3, 4. This is the Consul cluster running on VMs and GCP. These are VM-based install. If I pop over to the UI, what I think is neat anyway is from a single spot I can see my entire environment. So I've logged into Consul 0 on the port that it's running on, and I can see both sets of environments. So one of the best practices for Consul is when you're setting up a data center is that it should not go beyond the physical boundaries of that data center. So what I've done is I've kind of made the assumption in this world that this setup, my VMs are one data center, my Kubernetes cluster is the other. So I switched to the DC1, which is my VM-based install. I can see my nodes. If I switch back over to the GKE install, we can see the different pods that are running to get the different nodes and the server that's running. Now, we have no services running here other than Consul itself and the mesh gateway. What I want to do is we're going to put 2 services on there. And this is a demo app off of the Consul site on one of their repos. We have one that's showing a little bit of dependency between accounting app and a dashboard app. What those look like. So if you've worked with Kubernetes, we've all seen these YAML deployment files. So we have a service that we're going to deploy. It's called counting. It's going to run in port 9001. And then the really neat thing that makes this happen so seamlessly is just this really simple annotation to do the connect inject. Set it to true. The dashboard one, the one added thing is we're defining an upstream. So there's a dependency on that counting application for this one called dashboard. So this is the dashboard YAML. This is the counting YAML. So let's go ahead and deploy these. Watch for those to start. So one's ready. So if I pop over to the UI, we can see that the counting app, the counting service is now available. And the dashboard one's running there now. So I pop over here to refresh. Okay. So I'm not sure why the dashboard one is not showing up like it did an hour ago, but that's okay. Because what I want to show, now that we have this online, I want to pop onto one of the VMs. So remember that this is the Kubernetes-based data center. We don't see it running in the VM-based one. So what I'll do is we'll just pull this up. SSH into that node. So what I want to show, if we ping that service, so the service name is .service, and then you name your data center. I get nothing. But if we query this from console, we can see that we get an answer back. And what's interesting about this come over to our Kubernetes cluster. I'm trying to make this so you can see it. I hope this isn't too small. I should have increased the font size. But I see the pod running here. I see the IP here. And that's what it replied with. So think about for a moment how pods can come up and down, and those IPs are ephemeral. So if this was a service that was scaling very rapidly, how would it know what IP to get? That's where console becomes really powerful, because it can do that discovery very, very quickly and make sure that the traffic's getting where it needs to be. So just to replay back what I just showed, from the VM on the left-hand side, we queried another data center, which was running on Kubernetes through console, and we found the service. Really cool. Close that one down. The last thing I'm going to show you is we're going to do something similar with a VM. I'm just going to show what it looks like to get a service online. We get the IP of that server. I've got a server ready to go here. This one called Demo App. I know what's wrong. Because I'm running a browser version of VS Code, my copy and paste command is closing things instead of copying. So sorry about that. Is this one? That is not the right name. For dot. There we go. That's better. So the process to get, so this is a server, no console installed, no app installed. What it's going to do, quickly throw the console binary on there. And then I have configuration. So I have two configurations. I have one that defines the client. So the base, this is how the console agent running on this VM, this is how it knows about the cluster and how to get on. And then I have a service defined in this one called front end. So let's take a look at that one for a moment. This is a pretty minimal config. So I'm naming a service called front end. I'm telling it it's on port 80. Now, in reality, you would want to have some checks, some health checks to make sure the service is actually running. Not going to bother with that for this demo. We're going to move these two files over to the console directory. Membership, I can see that it's there. I can see that it's joined. So I didn't show this yet. So console members, I see all the nodes in this data center. So console 0, 1, 2, 3, 4. They are all of type server. And then notice this last one that's joined now, it's type client. And if I pop over to the UI, just do a refresh, we can see that our service is there. So that's how quick and easy. We just did that kind of live. It took, I don't know, 2 minutes, other than the SSH difficulties. So if we think about what this might look like, think about that dashboard service that's running over in Kubernetes. That's not showing up. We could have a dependency from that front-end app that's running on VM over to one of these apps back here in Kubernetes. That's where the power of the service mesh and why it matters for legacy services. That's where it kind of comes together. So if you had a service that's running on-prem that's been around for 20 years or something, that it's complex, it's hard to move. Yes, you want to move it to microservices, but it's not going away anytime soon. This is how we can bring everything together to talk on that consistent connection, secured. We have the ACLs, we have things like intentions, we can do token-based access. That's why it matters. Now, if I switch back to, for anyone else presenting, don't do it with one screen. This is a pain in the butt. So that's kind of the talk. If I think about some of the other things going on with service meshes and some of the announcements around console, specifically, I think it was already mentioned today at HashiCorp, it was announced about the console API gateway. If we think about how we can federate our data centers, our on-prem, our legacy services, new microservices as they come online, and you slap something like an API gateway in front of that, that's really powerful when we can intelligently route our API requests to those backends. Over something like a service mesh and an API gateway. So that's where things are going. I think it's really interesting.
Awesome. Thank you so much for joining us today. Sorry, I was like, where's my mute button? Oh, no. But thank you for joining us today. It was great having you on. And I believe if there's any questions, if you're free to engage with them in the YouTube chat, that would be great.
Thanks so much.
Yeah. Thank you. Have a good one. Yeah.
Up next, we have Shlomo.
Perfect.
Welcome.
Welcome.
I'm audible?
Yeah, we can hear you.
Okay, perfect. There we go. Just get this right.
Oh, you got the swag. We're set. You're going to be talking to us about Terraform-driven GitOps using GitHub Actions.
Perfect. So welcome everybody to HashiTalks Canada. I'm Shlomo Bilak, CTO at Benchmark Corp. We are practitioners of DevSecOps, DevOps, predominantly using the CI/CD pipeline. So let me share my screen entirely. Share screen. Let me know when. Oh, I want to do the entire thing. That way I don't have the same troubles Mark was mentioning. Let me know when the deck is up.
All right, there we go, and can see everything.
Perfect. Okay, so what I'm going to talk today is really, as I watched the other talks, I noticed there's a lot of hands on keyboards. There's a lot of heroics. There's a lot of people working things through. And then sometimes things don't work out because humans make errors. So today we're going to talk about what we do with Terraform as a practice. And then we're going to talk about how things should be driven through a CI/CD. So we can create an engineered trade. So infrastructure as code is an engineered trade, which is not currently in place. You're going to see a lot of stuff today you've never seen before. And it's because I work with a lot of engineers that are literally setting the global practices. Okay, so let's talk about, I'm trying to create an analogy so everybody understands why we're trying to create an engineering practice around this, why we're trying to figure out better methods of implementation. If I was to build a bridge, I wouldn't start just by building the bridge. There's a lot of anti-patterns today within infrastructure as code. Most people take the solution of most convenience. I run commands. And when you run commands, things don't work out. It doesn't matter if you're on a conference and you're presenting, or you're in a client and you're, a soldier of fortune. When it comes to Terraform, things go wrong. So Terraform applies, and just running a deployment that creates a build isn't really what we should be doing if we're building something that needs to be consistent and reliable. So if I just do the build portion, do you think the bridges would be safe? No, right? There's drawings, right? There's validation, there's bylaws, there's all types of things that are done before we do a build. So why is this the most common practice in infrastructure as code? Many people interpret this as GitOps, but it's not really GitOps. So we're going to talk about what it should actually look like so we don't have these anti-patterns anymore. Okay, so if I check things before I build and I check things after I build, this is what makes it an engineered plan or trade. And we're going to go into what the pre-checks are to building infrastructure. Again, I'm making plans. I'm validating what I'm going to build isn't going to make an error or not work, because I don't want to be in a circumstance where it's not working, because it doesn't build confidence. It doesn't build confidence for customers. It doesn't build confidence when you're doing engagements. It doesn't build confidence when you're doing demos. That's not enough. So I'm going to do the build and it's going to be seamless and completely boring. That's what it's supposed to be. A build shouldn't matter. I don't need a hero. I don't need a SME. I need the orchestrator to do the work for me, and we'll get into that. I'm then going to check afterwards. If I'm going to put people on the bridge, I'm going to validate that that build meets my specs. And if it doesn't meet my specs, no one's going to use it because people could get hurt. In this case, you might have your SLAs impacted or your brand impacted. So what are the post checks? And we'll actually go into these. Then we're taking GitHub Actions. They are one of the GitOps experts. There's multiple layers to this, but the context is things don't go well when we use SMEs and heroes to do our work that know, Kubernetes perfectly, or they know Terraform perfectly. I want them to build their capabilities into an orchestrator so that bridge is built perfectly every time. It doesn't matter if he slept well or not. It doesn't matter who's on call or building it that day. The orchestrator builds it perfectly every time. Now, there's more to it than that. The orchestrator also supports the Git flow, the method at which I know what's going to be created based on the environment or the SDLC stage. What I mean by that is if I'm in dev, I might build infrastructure that's not permanent because that bridge isn't supposed to stay in development. I'm just testing it out. So I'm going to destroy it. But when it goes to production, I shouldn't allow anybody to destroy it. So that Git flow handles that context around it. Okay, so if you're trying to think of the orchestrator, people ask me what's an orchestrator. That is not running an infrastructure pipeline. An orchestrator is a CI/CD process where you deliver your infrastructure with the pre-checks, post-checks as part of a larger delivery to get to production from the moment you commit your code. And if you look at the top right, you can pick your colors and lay out the driveways seamlessly every single time if someone's actually built the orchestrator. It's just perfection. It's not about the guy who's putting the bricks inside. It's about the machine delivering it consistently every time. This is a little heavy, and I'm going to go into each of these. I just want everybody to understand that building infrastructure isn't about building the infrastructure. It's about the trade, the engineering trade around it. What modules are allowed is your starting point. I want a hardened creation process for that validation. When I do a code pull request and I want to merge something in, I'm going to do a lot of things before. These are the pre-checks. I'm going to check, I'm going to lint it. I'm going to do a security scan. Everybody's familiar with TFSec. I'm going to do a testing provider to make sure everything's functioning. I'm actually going to update the docs, and I'm going to check my format so I don't make a mistake of writing the wrong command in. These are the shift left methods so that when I have engineering plan, it's going to go as I see fit, and the pipeline's going to run it for me, right? In this case, GitHub Actions, and I'll actually show everybody. Image creation. Again, sometimes I need to know what I'm putting out there. It could be a Docker image. It could be actually an image of RHEL 8, RHEL 9. It could be Windows Server 2022. I want a hardened profile that I then deploy using my plan. I use my modules. This process is what everybody's familiar with. I have a Terraform plan. I have a Terraform apply. Do I do dynamic inventories to pass it on to config as code or Ansible? Probably not, but you should be. Do I integrate it with change management? Do I do all the pre-requests or pre-checks? And do I do all the post commits? Do I clean up? Do I do my post creation compliance scanning? Is what I created actually as I expect? Is there any vulnerabilities? And if it's not, tear it down, right? Don't leave it in place. Just a little humor here is like cleaning up matters. You cleaning up in the sense of development when you don't need to keep it. Don't leave services left behind. Or if you're installing prerequisite things, or you have files that are left on your runners on you need to clean them up, right? So this is part of the process. Again, Git flow is also part of it. So if I'm using GitHub Actions, I need to have ways that I merge from particular branches and set precedences around the engineering trade of infrastructure as code and deploying applications. It works the same way to prevent people from doing things they're not supposed to do, such as commit code from a developer feature branch to master. I've seen this so many places. Why do we do that? Solution of convenience. Does it actually give you confidence for production? Does it go through any particular quality checks or gates or a particular promotion of code? No, because we're not practicing. We're doing solutions of convenience. I press Terraform apply and I think I've done my job. But in reality, that's not what you should be focusing on. You should be making sure the Terraform apply is flawless. Okay, so I'm going to go into exploring it. What does the pre-checks look like? What does post-checks look like? So I've taken this from our GitHub Actions. I'll actually show the GitHub Actions in the next phase. But what you see here is I pre-install my tool dependencies so that I can actually validate format. I can do my docs. I can do TF linting. I can do TFSec. And then if it's all good, I'm going to move towards build, right? This is a trade. I'm not doing bespoke changes. I'm doing a rigorous methodology to make my plans before I build them, just as an engineer would do when they're building a bridge. If I'm building something, 5 seconds, added 2 machines. In this case, it's VMware. It could be any cloud, doesn't really matter. Any cloud is any cloud, private or public, if you use Terraform correctly, because it's multi-cloud capable. But the context here is, I don't care about those 5 seconds. And I don't care if someone does a Terraform apply. That's not a consistent method. It's, did I check everything before I built it? Did I check everything after I built it? So that I don't leave behind, orphaned infrastructure or content. And I don't create something I wasn't expecting. And I don't depend on heroes who know the infrastructure really well, because they make mistakes. Doesn't matter how great someone is. But if you take their capabilities and you put it into one of these processes, what happens in the end is you create a reliable and consistent method to deliver infrastructure as an engineered trade. And if you're not a good tradesperson, I wouldn't have them build my bridge, right? If someone just goes straight to building a bridge, I wouldn't trust them even if they were bright. I need them to do these checks. In the post checks, it's more about the cleanup. and maybe removing test infrastructure after you're done. Maybe you had some things that you're using to instrument some things. Don't leave behind anything that you were using to set up the environment. Don't leave behind anything that you're doing as prerequisites. And sometimes don't even leave behind your developer feature environments, because I'm done my testing. It worked. I don't need to keep it. Additionally, you want to go into something like getting compliance reports. This is an OpenSCAP report that's part of our post check. If I build something, I want to go and check that machine that it actually is, if it's a machine or whatever you're doing, different methods for different capabilities for containers or machines. But in this case, I'm just using a machine because it's the most common method today. I'm going to check if it's compliant. I want to know that what I built is safe and within the governance that I was looking for. That's a post check. It's not about the build. It's about the plans before and the post checking after to make sure everything's safe. I'm actually going to shift now into, hopefully my screen changes very easily for everybody. I'm just going to shift into here. Let me know if it's very clear and everybody can see. Can I get a thumbs up? I can't actually know if everybody can see. Are we good? Hello?
Yeah, looks good.
Okay, perfect. Sorry, I didn't want to go ahead if everybody can see. So what you can see here is I'm going to do a pre-install of all the tools I need to do what I really need to be doing, which is validating things. So this is all the types of installation of tools, making sure I can do the pre-commit checks. It might be JQ to parse JSON, whatever it is that you're doing, you're going to pre-install all your tool dependencies. So I have an engineered trade. It's not about Terraform apply. It's about everything that makes Terraform perfect, because perfect is what we're aiming for. And if it's not perfect, you're going to fix it and it's going to find it so you don't have unreliable results. At this point, you're going to do execute pre-commit check. All of these, you can even parse it to say passed. In reality, that's not actually what the output is, but we've beautified this so that people who are looking at this, who aren't SMEs, who aren't heroes, can still manage this and deal with, oh, okay, so formatting was bad. Perfect. I don't need to go through which line of formatting was bad right now. I just need to know that it failed on that and I'll work on it later. So you can see that pre-commit check is part of before I build my modules or before I build my infrastructure. Post checkout, there could be lots of cleanups. You could be destroying environments or removing environments if you don't need them. I'm just switching between things. But again, if I'm executing the plan and I'm adding 2 nodes or changing the nodes or destroying nodes, I'm very pleased that my documentation is updated. But this I don't care about. This is the part that I'm confident. This is not the part that should be dependent on me knowing what commands I run. It should be dependent on the pipeline always doing what's expected so that there is a reliable and safe resource produced. I just try to go through more of it. If I'm doing a build, obviously you need to have your Terraform ready. You need to have your runner ready. You might need to install Go because you need to do some other commands that need to be done. You go through all these types of things, but within the Terraform plan, there's got to be pre-commit checks and post-commit checks. Additionally, I think it's very important that you create very good documentation. Again, I didn't cover that specifically, but I think it's important that you document how everything is built. What are you going to do beforehand as an engineer trade? And then document the process at which you are showing how the merges occur and how people can promote code through GitOps, right? From which environment can I destroy, which environment promotes to the next. Again, so you have a consistent SDLC process that does one thing, builds consistently and gives you confidence as you go to production. If it doesn't do that and it's dependent on a SME that knows the right commands, again, end result is that bridge isn't going to last very long and you're not really sure you're going to get it. Again, you can produce a report. This is the report that you've seen. So I actually have all the windows from the screenshots. This produces an evaluation report of the infrastructure that was created. This was a RHEL 8 machine that I wanted to validate for CIS compliance. Guess what? We pretty much there, with the exception of etcd host because it's not actually running. It was a template. But what we're trying to get at is, I'll stop sharing at this point. What I'm trying to get at is, if you have infrastructure as code, make sure you create your plans, make sure you create your engineered trade so that you're not dependent on a single person or a few people that know what they're doing, because in the end, it's not consistent. Technology is not consistent when it's orchestrated by people. Technology is consistent when technology orchestrates itself. So with that, GitHub Actions helps us at Benchmark deliver, consistent environments, heavily compliant environments, and very repeatable processes that don't have failures. I'm trying to change the global practice here, and hopefully others start adopting this beyond the Terraform apply, because it's an anti-pattern to create without pre-commit and post-commit checks.
Struck by mute again. Awesome. Thank you so much. I really loved your energy going through this talk. And when you put your hat on, I was like, oh, I need to do this too. So I got a shout out to
I can't
Katie
pull
with
it
the hugs.
off. I can't pull it off now. I got messy hair, so I'll keep it on for the day.
Oh, now it's on for the rest of the day now that I've got
You
hat
got
hair. But thank you so much for joining us today. We don't have time for Q&A, but happy to have you in the chat if there's anything that's going on or anything you'd like to share. And yeah, thank you so much.
Thanks, Jackie. Thanks, Jason, for having us. Cheers.
And I will let Jason introduce the next speaker, who I've heard likes giant robots. So that seems really cool.
Giant robots. Next up, we have Xian. I think I said that maybe close to right. How'd I do?
Yes, that's correct. It's Xian.
Perfect. Thank you, Xian. And thank you for joining us today. We're happy to have you join us in from the West Coast. And you're going to be talking to us today about the evolution of managing TFE workspaces, managing it all in code and at scale.
Yes, that's correct.
Awesome. We'll give the floor to you. Looking forward to it.
Okay. Right. So just making. Yep. Great. Right. Hi, everyone. I hope everyone has enjoyed the selection of talks today at HashiTalks Canada today. I definitely have enjoyed it myself. Today, I'll be giving you an insight into my team's experience with Terraform Enterprise, specifically our story on how we have dealt with workspaces at scale and what it has taught us about automation. So, just to preface my talk, that opinions expressed here are solely my own and do not express the views of views or opinions of my employer. And also note that these workflows that are being presented today do only apply for projects that my team at SRCA works at and do not apply to the whole of Samsung Electronics. So just a brief introduction about myself. My name is Xian. I'm a senior cloud operations engineer here at Samsung R&D Canada, based in Vancouver, BC. I'm part of the cloud operations team, and I'm primarily responsible for some of the shared services within our cloud operations team. I've been working in software and operations for the last 14 years or so in numerous organizations, small and big. I grew up in Malaysia and studied and worked in London. And I've been in beautiful British Columbia for the past 9 years or so. If you have any further questions or comments about this talk, you can also reach me at my Twitter handle or LinkedIn. So you might be wondering, what is Samsung R&D Canada, or as we like to call ourselves, SRCA? SRCA is part of the Global Research and Development Division within the larger Samsung Electronics Corporation. Our team here is based in Vancouver, BC. We are just next door to Emily Carr University. And we manage the software engineering and technical operations for various cloud services of Samsung Electronics, including B2B NOTs, Samsung Pay, and Samsung IoT. Our teams here in Vancouver are not the only ones that work on those services, though. We collaborate with various other Samsung engineering teams across the whole wide world. So just to clarify here, when I speak about Terraform Enterprise, or TFE for short here, I'm referring to the self-hosted version of Terraform Cloud. Just keep that in mind when everything that I speak about workspace and TFE today also applies to TFC. Over here at Samsung, we have been using Terraform Enterprise as a key tool in our DevOps workflow. TFE has helped to move our DevOps culture forward with features like a friendly web UI, inbuilt workflows, and Sentinel policies. All of this has helped both automate our ops task and enable developers to dive into infrastructure as code with Terraform. So what is TFE Workspace, and why is it so crucial to our workflow? So let's just be clear here. There is also another feature in Terraform CLI that is used to create workspaces. That is not what we are speaking about today. We are instead speaking about workspaces in terms of workspaces used in TFE or TFC. By the official HashiCorp definition, a workspace is how TFC or TFE organizes infrastructure. A workspace contains your actual TF state file, which holds definition to all your cloud resources. It has configurations about how your Terraform workflow runs. It has variables that you want to set. Also controls how you integrate it with your Git repo, and much, much more. In other words, a workspace in TFE is the heart of your infrastructure. So what were the biggest challenges when one wants to manage TFE workspaces at scale? What do you do when you have a huge number of workspaces? At the time when we first started using TFE, we already knew we have a lot of workspaces that needed to be defined. But we want to manage these workspaces at scale and in code. During the early days of adoption, there was some difficulties in managing our workspaces at scale and in code. The Terraform provider that we can use to define all TFE resources, including workspaces, was still an early release. It was missing some key features at the time. In addition, we were still at Terraform 0.11, so any path to dynamically maintain the workspaces, it can get very complicated without those language constructs such as loops and conditionals. Then we had to handle the key question. How do we handle these workspaces at scale? When managing at scale for large, I mean very, very large number of workspaces, how do we do that? Simple enough, it could be define all the workspaces in a single TF state file under a single workspace. The big issue here is that the solution is that a single TF state can only take so many resources. In addition, HashiCorp's best practice states that you should not make a TF state too large. And again, the last thing you want to have is a Terraform plan or apply taking minutes or hours to complete. Which then brought to our next big challenge. If you have defined workspace in Terraform, how do you find the workspace to define the workspace? And how to define that workspace? So it can get very meta. It was a bit of a headache for us to think about this, how these workspaces get defined without getting into what this meme demonstrates. But we persevered and got an initial version of workspace management solution up and running. In our first iteration of the solution, and this is a solution that we still use to this day, we have a service defined the workspaces in YAML files. So this is all in code. These will then be taken in by our CI/CD pipeline that will be processed by a custom Python command line tool that we wrote. As you can see here, each service defined in a single config file. Our objective is to automatically create the workspaces, one per environment for each workspace. Our custom Python command line would read these configs and then make direct REST API calls to TFE to generate the relevant workspaces. The custom Python script itself would also configure standard configurations like a default Terraform version, credentials to use, RBAC access, and so on. And finally, all this ran on our CI/CD platform. Currently, this all runs on CircleCI Run itself. As a result of these efforts, we've noticed some key benefits. First of all, our TFE workspace setup was very seamless to our end users, the developers. So when developers wanted to start a new project that needed TFE workspaces, all they did was create their config file in the Git repo. The pipeline would generate their workspaces on the other end. But just like a duck, everything looks calm and efficient on the outside, but there's a lot of busy work underneath it. We are also able to keep our TFE workspaces all configured in the same manner. If we wanted to upgrade the Terraform version, we do it all from a single config file. And finally, because all our TFE workspaces were defined in code and readable, we had full visibility to what's being integrated in TFE. In some instances, this was a point of contact or discussion between dev and ops on what environments that a particular service may require. But we also noticed issues in this workspace. First, we had scaling issues. This time that we do a change, our pipeline rereads all the configs and applies it on all workspaces, regardless whether something has changed. This is great if you want to ensure that manual changes are reverted, but it had a large amount of API calls being pushed towards TFE. Another issue is that we have to play catch up to all new features to TFE, especially when it came to workspaces. So if we wanted to take advantage of a new configuration in the workspace, we would have to update our Python script to handle it. And finally, we had very large code maintenance. I mean, yes, we added unit test. Our teams all know Python, but it's still another custom piece of code that we have to maintain. And this prompted us to think of the next stage to our workspace management pipeline. As we looked into how we fixed these issues with our workspace management, some things have changed since our early years with TFE. First, our teams are more familiar with TFE, including the runs, the plans, and applies, and so on. The Terraform provider for TFE has vastly improved with a full set of TFE resources that it now supports. We obviously now have loops and conditionals from the latest version of Terraform. TFE now has run triggers that allows to link multiple workspaces together. And there are now custom TFE workflows that can be driven exclusively by the API. All that helped us move our workspace management to the next stage. So, as you can see here, we had decided to go back and define all our workspaces in Terraform core. So again, we have all our Terraform workspaces that we use to define resources in the cloud. We define all of these Terraform code, all these Terraform workspaces in code under a workspace category. This all to avoid overloading a single workspace. So we instead broke it apart to several workspaces, which I would call them workspace categories. But note this is a term that we use. This is not a feature that Terraform HashiCorp TFE uses. Of course, the conundrum comes then, which workspace do we find these workspace categories? Well, we have one workspace to rule them all, a meta workspace just to define the workspace categories. Again, this is a term that we use, not a term that TFE uses. We stopped there by defining this workspace manually. We set up this meta workspace directly on the TFE web UI. It's a one-time operation, and we would normally not update it that frequently. So as you can see, we defined all our workspace in Terraform code. This eliminated the overhead with custom scripting. In addition, we split our workspace definitions, or as I call it, sharding the workspaces. This helps to eliminate the possibility of overloading our workspaces, as mentioned, with too many resources. A great benefit to defining it all in Terraform code now is that changes will only be done on actual resources attributes that needed to be changed. This helps reduce the number of API calls that we would make to TFE. With trigger runs, we can help automate the changes to the workspaces and bubble up the relevant workspaces. One example being if you wanted all workspaces to have a new variable, you just update the meta workspace and have the trigger runs update the relevant linked workspaces. Finally, our meta workspace is managed manually as a one-time setup. Note the meta workspace itself is defined in Terraform and is linked to a Git repo, but the workspace configs, like the way it runs, integration with Git, are managed all in the TFE web UI. Just a disclaimer here that this workflow is still in progress. We are using it for new workspaces. We are still heavily relying on our version 1 of the pipeline, but we're starting migration to this new V2 of the pipeline. We have learned some lessons how we approach automation during our journey in TFE workspace management. First, you can't automate everything. There is a point where the return is just not worth it. A point to follow that certain seed or starting resources can start initially manually, just like our meta workspace. The other lesson we learned is to keep our tooling in automation consistent. Yes, a custom scripting gets us a quick win, just like our first version of the pipeline. But long term, if the goal is for low overhead and lower maintenance, one should try to use convention and tools that are already familiar with the team. There are obvious exceptions to this, but if your tooling works well, why add another complication? Finally, this is more of an appreciation than a lesson. We really value the features that Terraform provided to us. Our initial version of the pipeline could have been drastically improved if we added features in our Python script to selectively only change what needed to be changed. But why reinvent the wheel when Terraform already does this? The ability of Terraform to detect changes that are needed and only change that's a valuable feature to us that made us use Terraform not only for cloud infrastructure management, but for things like TFE workspaces. We use it for pipeline management, single sign-on, and so on. So this is the end of my talk on our journey in automating the management of our Terraform Enterprise setup. Reminder that everything I mentioned here could also be applied to Terraform Cloud in theory. I'd like to thank you all for taking the time to listen to my talk. And I also like to thank HashiCorp for giving me the opportunity to present our story. And the one last thing I'd like to add is that Samsung R&D Canada is currently hiring for multiple positions. Please do check out our website for more information. Thank you very much.
Thank you, Shun. I love that talk. The TFE provider and your journey to getting all that stuff mapped up is something that I think a lot of people are on the fence about. So I'm sure that many people will be able to take away some serious lessons and next step with that. So thanks for sharing with us today.
Yeah, thank you so much for joining us today. So our next speaker coming up, I've heard can solve a Rubik's Cube in under 3 minutes. And I would like to welcome Kyle up onto our virtual stage today.
Hi.
Hello, welcome. If you're ready, I'll just hand it off to you and you can get started.
Sure. All right. I assume everyone can see my slides. I want to start with a poll. I know it's a digital conference, but I always like to have people raise their hands. How many of you have more than 25 services at your organization? And then keep your hand raised if you know who owns each one of those services. Now, continue keeping your hand up if you know, without a doubt, they are using the most up-to-date practices. Things like all the dependencies have no vulnerabilities, latest version of runtime language, had a deployment in the last 30 days, proper dashboards with monitoring tools, all that kind of stuff. Now, here's the kicker. When you have an organization-wide campaign to improve or adopt something new, can you track that progress and ensure that everything adheres in a timely manner? So today, I'm going to show you how you can use a rubric as code to drive service ownership and maturity at your organization. But first, a little bit about me. Kyle Rockman here. Platform engineer at ops level. I develop our open source tools and integrations for our customers to use with ops level to make their experiences easier and more enjoyable every day. But before I get started, I do have a disclaimer I want to make. I'm working on limited information because I'm a human being, just like all of you. So I might be wrong about some stuff. All I ask is that you think about how these ideas might help you at your organization. So here are the major points that I want to cover today. We'll talk about what service ownership and maturity mean and how they can impact your organization positively or negatively if you're doing them. Then I'll introduce you to Ops Level, our product, and how it helps with these issues that we all face when we're working on microservices. Next, I'll cover how we went about building our own Terraform provider and some of the trials and tribulations that went with that. And then finally, I'll cover how the provider can be used to make a rubric as code so that you can drive service maturity at your organization. So Ops Level's mission is to help companies do DevOps better. And we think that service ownership is a foundational piece to that shift. So let's walk through what service ownership is, lay out why you should care about it. So let's start with the why, and it's really pretty simple. Microservices are everywhere these days. Some might even call it sprawl or chaos. There are a lot of great reasons for adopting microservices that I don't need to go into, but there are also a lot of downsides and risk. I think there are 4 characteristics to service ownership that I want to mention. The first 2 are kind of more like prerequisites or inputs. Autonomy. So teams don't want to be dictated to. They want the freedom and flexibility to make choices for themselves. But that's kind of in the face of accountability. So there has to be some sort of baseline requirements that must be met if they want that autonomy. And if someone else is on call for that service, that person on call shouldn't find it an undocumented mess and have no idea what's going on. I think the second pair of characteristics here are more benefits or the outcomes of embracing a culture of service ownership. Speed. Who doesn't want speed? Everyone wants speed these days. So with more autonomy comes that speed. Devs can ship faster, iterate faster, and as long as they're meeting those baseline requirements, it's okay. And then resiliency. If a culture of service ownership is strong, even when incidents do occur, teams should have all the context and all the know-how to respond and remediate without having an incident turn into a crisis. You can't drive any kind of change if it's not clear who's responsible. So service ownership has to come first. But once you have that foundation in place, your org is ready to tackle service maturity. So let's break it down into some more specific things. Service maturity can kind of be ambiguous and vague, but once you've got service ownership in place, it's really not that complicated. The secret to maturity, I feel, is continuous improvement. So we have CI, CD, and we want to kind of layer on top of that, always making it better. So what does that look like in practice? Well, service ownership is about giving engineers autonomy, but part of that service maturity is making sure there are still some guardrails, some standards that they can fit in. Standards and goals gives teams parameters to work within, and giving that extra context of why behind those parameters of why you want them to do something can make it view it as part of the org's mission, just instead of red tape that they have to jump over or get through. But we don't want to overwhelm folks. We don't want them to ask them to juggle too many things at once. So you can help teams by allowing them to focus and prioritizing those standards or goals in a list that you want them to, jump through the hoops A, B, C first, then D, E, F kind of thing. When it's time to do the work of improving services, a few things to keep in mind. You want to hopefully, at this point, it goes without saying, I'm sure we all appreciate some good automation, right? So we want to reduce the friction to get stuff done. And I also think that slow and steady kind of wins the race. We don't want to do everything at once because that just leads to burnout and things not getting done. So service maturity shouldn't be a static thing. Your tech stack and your org's priorities, your team's skill set, they'll all evolve. So service maturity has to adapt with that. So what is this ops level thing? Well, it's a developer platform for teams to own, operate, and understand the software they are ultimately responsible for. So how can ops level help you drive these foundational ideas to make DevOps work better? I want to show you a 2-minute video that showcases all the major features of ops level. And the reason that I want to show you this video is that some of the major features of the product will help make more concrete the rubric as code aspects in the later half of this talk with the live demo.
Welcome to this ops level introduction. In the next 2 minutes, I'll show you how our service catalog can solve questions of ownership and drive continuous improvement as you scale your engineering organization. Are your engineers relying on tribal knowledge or stale spreadsheets to answer questions like, what does this service actually do? Or which team owns this service? Whether these come up during routine feature development, or worse, during incident response, with ops level, devs always have these answers at their fingertips. Let's start by reviewing an individual service in our catalog. Here we have the shopping cart service. Devs can quickly see all its important metadata, like owner, language, and tier, as well as its linked code repositories. On the Operations tab, devs can quickly access all the tools needed to operate, monitor, and troubleshoot this service. And if a service isn't functioning as expected, check the deploys timeline for details of any recent code or configuration changes. With deep integrations and serious extensibility, build your catalog however is best for your team. Kubernetes, Terraform, our GraphQL API, or config as code with an opslevel.yaml file are all options. Then keep your catalog up to date with intelligent service suggestions based on your existing integrations sending data to ops level. With your service catalog in place as a strong foundation, you're now ready to tackle service maturity. Service maturity encompasses traditional production readiness checklists, but also much more. With our always-on checks, continuously evaluate all your services against your relevant best practices across all engineering domains. Checks can be as simple as confirming services are labeled with the right metadata and using the right toolchain, or as detailed as evaluating vulnerability scan results and SLO performance of a service. For service owners, no time is wasted looking for the right standards, and clear, prioritized next steps are always available for ownership tasks. For a top-down view of your architecture's maturity, check out our interactive dashboard. Easily identify which teams and services have made progress or which areas need more attention. If you're ready to solve service ownership, visit opslevel.com to request your demo and start your free pilot.
All right. So that's ops level. But that's talkvertisement, right? Let's talk about Terraform and how we can use Terraform to do all of this. So now that we know what ops level can do for us, and knowing that a lot of organizations leverage infrastructure as code, it feels like the perfect combination to allow them to manage their ops level data as code too. So we set out to build our own Terraform provider. Thankfully, making your own Terraform provider is a road well traveled, and there are many examples out there that we could learn from to implement our own. When looking at making a Terraform provider for your product, I think these are the most important pieces. You got to have a great handle on the data that your end users are bringing to the table, how they should best tie together that data with Terraform, and then it's really important to have a rock solid API client with full CRUD implemented, because the life cycle of Terraform resources requires that. So I don't know if this is a special or unique approach to building a Terraform provider, but the way that I started was with the end result configuration, what it should look like, what it should feel like. I figured that if I had the spec with what our users would write in Terraform, I could make sure that it was clean and concise, and then just build the provider to match that spec. Here are some early drafts of the configuration stanzas that I mocked to get a feel for what it was like. You can see we're defining filters and services, rubric categories and levels. And so I was able to kind of play with the stanzas and get them to fit together how best I think a user would understand them, not what the API client or what our API dictated. An interesting choice that we had to make was with ops level service resources. And it was actually in contradiction to the HashiCorp provided design principles. So if you've ever built a Terraform provider or read the documentation, they have a bunch of rules that are generally recommended to follow. And specifically here, there's two. Resources should represent a single API object, and resource schemas should closely match the underlying API. So when designing an ops level service resource, we had two options for how to handle tags on a service. If we follow the HashiCorp principles, this means we should look at service tags as individual resources as shown on the left. This does feel a bit verbose, but in our API, tags are a nested resource with their own IDs, so it was following the principles, and it works. But if we took a step back and think about the end user experience, we already had in the UI, we could actually opt to allow for an alternative way to specify tags as shown on the right here, which is way more concise. This means that the configuration is, much cleaner for the end user, and also mirrors what we have in our UI, what they're expecting. Since we could see the merits of both approaches, I started to apply a principle that we have here at Ops Level, which is go with the community. This means we look to see if we find this pattern in anything else already out there that is similar in nature to our problem. There is no need to reinvent the wheel, and following paths well trodden means that our users will have a more expected experience. I was able to find a few cases where the AWS provider does allow for both ways to live in tandem. They just have explicit documentation stating to not use both methods together. So if it works for AWS, it works for us. While the more succinct approach did require more code under the hood, I think it's worth the improvement in user experience on the right side. So I want to take a step back and shout out to the HashiCorp Terraform plugin docs repository. While I know there's a bunch of different documentation generators out there, it was really nice to have a simple and opinionated one written by HashiCorp. This allowed me to write full examples of all the resources and data sources, generate a full documentation site from Markdown files, before I even invested time in writing a single line of Terraform provider code. So I was able to share this documentation with our CTO. He could easily see how the configurations felt. I could get feedback on the designs without even having to rework any code yet. Through this process, we were able to find issues with how certain data sources were used before we had committed to writing the code for them. Once we had good consensus on how each resource and data source felt, it became a simple process of implementing the schema, writing the glue to tie it all together using our great API client. I did have the advantage that I was developing the underlying API client around the same time as the provider. So if I needed to make a slight adjustment to the client functionality, I could, which did help in a few edge cases where the ideal Terraform configuration didn't match quite as nicely to the API. Once we had the Terraform provider created, it was time to dog food it. I always recommend you use the code you write so that you can feel the pain your users experience. So we use ops level internally, and we call it the circular account, and this is where we found our next big challenge. You have a bunch of data already in the product, and while Terraform does provide an import functionality, what it's lacking is the ability to generate configuration stanzas. You have to write that all up front before you can actually finish out the import. So looking at the community, taking a page out of Cloudflare's Terraform integration, we then built a way to export all of the current data in your account to Terraform configuration stanzas with a simple one-line command. This meant that you could begin using our Terraform provider at any stage of your usage of our product. After some internal testing and dogfooding with our circular account, we finally felt that we had an end-to-end solution we could show to our customers. We've had several customers adopt a Terraform provider now, and they are delightfully surprised to see how clean and concise the resource definitions are, as well as full documentation and examples on day one. So now we're going to get to the live demo part, but I want to take a second to make sure that we pray to the live demo gods that this all goes as expected. So here is ops level. Here's my account with a bunch of sample data in it that we use to demo to people. The main important parts here are that we have different levels, gold, silver, bronze, some services, who owns them, what tier they are, extra metadata about what tools and tags they have. But what we're here to talk about is the rubric. So as you may have seen in the demo or in the video, a rubric is basically just kind of like a scorecard or a school rubric, where on one side we have kind of categories and across the top we have levels. And then it is someone's job to come in here and define what checks, what things you want to check for, what are those bars you want people to pass, and organize them into this rubric so that they can see it. So what that looks like from a service owner's perspective is they have a maturity report, and they're told about what checks are applying to them and what level they're in. And so you can see here we've got this service has passing everything, so it's given a gold star. So let's flip over to the Terraform and start writing, getting a check. You can put these checks into the UI, but we're here with Terraform, HashiCorp, HashiTalks. Let's do it with Terraform. So we have our Terraform provider. I'm using a staging environment. We have those services that are defined here that we saw earlier stanzas for. This entire Terraform repository was exported out of the account with our CLI command. So I have it all set up. I have it talking to the account, and we can go write some checks. So I'm going to start with tool usage checks, because these are just really easy to demo things. So we have a couple in here already that are already in that rubric. Some important points about it is they define categories and levels, who's the owner of the check, filters, which can basically be thought of as I want to target all of the tier 3 and above services. What that kind of filter looks like is with a predicate. So it's here, and we're basically saying, hey, if the tier index is less than or equal to 3, that's what I'm targeting. So what I want to do is make a new check, or add a new check to our rubric. So this is going to be a similar check to the ones that are already there, which checks for tools, but now it's checking for a specific tool category of runbooks, which a couple of our services don't have. So we're going to be a little cowboyish here since we are short on time, and we're going to run apply. And so it's doing the standard Terraform lifecycle here. We'll get the Terraform output, and we'll apply it, and we'll get a new service, and then we'll see what happens in the UI. API is being a little slow today. So there we go. We'll get our new check applied. And so this was in the gold level under the service ownership category. So if we flip back and refresh, we have gold category runbooks here. And if we go to our services listing, we can see that I think we had a lot of gold services before. We got a few less ones, specifically this one, I think. We go to its service maturity report. We can now see that it's running, and you can see this message here. This service doesn't have a runbooks tool. That's actually something default we generate, but in some of our checks, we allow you to specify, we allow you to specify messages that you can pass to the service owner so they can understand why this check is important, what they need to do to resolve it, any kind of data. It's marked down. You can put a bunch of stuff in here. So if we set up this check, we're going to see that this is a different kind of check. We have a bunch of different kinds of checks. This one is specifically called a custom event check. So you can send payloads at us, and you can use JQ expressions to pull out what the service, what service that payload is for, and then what is a success condition. These are really powerful checks, and they allow you to build integrations how you want. And we're building out integrations with other tools like PagerDuty and things, but this allows you to basically build anything as long as you can submit a payload at us and set up a check for it. So if we go back to ops level and go to our services list, we're going to have a lot fewer gold services now. What's happening under the hood is when a new check is added, the services get recalculated and they start failing checks. This has a runbooks tool. Where's our custom event check? What was it called? In silver level. It was this one. Oh, and it had a payload. It was not supposed to have a payload. What sending the events looks like is a JSON payload that you send at an integration endpoint. And I think it's green because I tested it before. But what it's doing is this payload is used by these JQ statements. So we're digging into services and we're finding the name, and that's the service selector. And then we're digging into services, making sure we're targeting the correct one and seeing if it has an escalation policy, and it's passing it. Okay, let me go back to my slides. That is the live demo. All right, so let's recap. I hope today that you've seen the power of behind tracking service ownership and maturity. I hope that you were able to understand how a solution like Ops Level makes it easy for everyone at your organization to feed into this service maturity, both if you're the person writing the checks and if you're the service owner, making it easy for you to know what's going on and what you are being asked to do without overburdening you. And lastly, I hope that the behind the scenes look at how we built our Terraform provider and the live demo of its usage gave you the confidence and direction to empower you to make your own Terraform provider for your organization, whether it be for something new, something external, or even just writing a Terraform provider for something internal if you're a much larger organization. So I want to thanks again, and I'll be in the chat answering questions. One of my other co-workers is also in there answering questions likely, and I hope everyone has a happy HashiTalks Canada.
Fantastic. Thank you so much. And thank you for wishing us a happy HashiTalks Canada as well. Oh, words. It's like quite pretty far into this event so far, so brains just are emptying now. But yeah, thank you so much for joining us. And if you're watching, you have any questions, please do drop them in the chat so we can keep talking to you and going through with that. And yeah, I'm going to hand off to Jason to introduce our next speaker.
Thank you. And I loved that little bit of alliteration / tongue twister also. Yeah, 4 o'clock Eastern time. Let's do tongue twisters. Up next, we have Ravi Lachman joining us.
Hey, what's going on?
Thanks.
I was trying to say the tongue twister too. I was like, I'll just stop before I come on.
Yeah, I've broken all my coffee consumption rules for today, and we're still going strong. So it's great.
Me too. Me too.
There you go. You're here to talk to us about defining and enforcing policy as code. Yeah,
That's me. Yeah.
awesome. We'll give you the floor. Looking forward to it.
Okay, appreciate it. Well, hey everybody. Well, thanks for attending my talk today at HashiTalks Canada. I'm not going to say that 4 times fast. So today I'm going to be talking about Terraform and Shippa, how to define and enforce policy as code with Terraform and Shippa. So the title will allude itself. So a little bit about me. Oh, that's what it is. I'm Robbie Lockman. I'm the field CTO at Shippa. I spent a lot of time in engineering efficiency and developer experience space, previously as a chief architect at a firm called Harness, and really excited to be talking to everybody today. And so what I'm going to be talking about today, I'm going to be talking about 3 main concepts as they kind of show a demo. So it's going to be dev, verse, and or ops, right? And so depending on what side of the table you sit on or what part of the organization, we all have different expectations. And then continuing the evolution as something as code, right? So Terraform is known as infrastructure as code. We have a concept here at Shippa called application as code. So kind of supercharging your IAC experience, taking a slant towards the application stack. What does that look like? Why even do it? And what's some return on investment for you? And then finally, how to integrate Terraform and Shippa. So using Terraform to spin up all the necessary Shippa resources so you can manage your application stack. So it's kind of a duality, right? You have to manage the manager. So we'll kind of show that with Terraform and Shippa, or I'll show that. So dev, verse, and or ops, right? So where do you sit on the table? So there's quickly, like there's anything, there's expectation and reality. So if you're a DevOps engineer, you're really focused on the development pipeline, right? You want to make sure that you're supporting your internal customers, the developers, as best as you can. You want to be able to iterate and evolve your infrastructure quickly, right? So that's one of the core benefits of IAC. Funny infrastructure of days gone by, and I'll actually touch about that in a little bit. Was pretty static, but now it can be viewed as kind of dynamic. Also, as a DevOps engineer or platform engineer, you're there to enforce standards and policies, right? And so making sure that folks don't have the run of the mill, and I can make sure that certain quality and security postures are ensured. And then kind of sliding that over to the development side of the table. If you're on the dev side, it's, hey, your main goal is to iterate and develop and deploy fast, right? So trial and error or software, you want to make sure you're getting feedback as quickly as possible. And also, if you choose to, having self-service, right? So some people might say self-service, like self-checkout, can be a little frustrating, but usually a good goal, at least where you can get to some sort of environment that you have good confidence by the time you go to production, that stuff will work. What kind of ends up happening, though, if you talk about reality, is that if you take a look at modern pipelines, you can get kind of complex, right? Like, if you parachute, imagine yourself as a developer parachuting into a new team and you have to deploy something for the first time. That's pretty daunting, pretty scary, right? If you have direct access to production, that's scary because you can mess something up, or you have to jump through several pieces of change management. That's also scary because you don't know how much you have to do. For example, going back to what ends up happening with the DevOps teams, they kind of create complex pipelines. And also, what I see more often than not is that DevOps teams are the old release managers, right? And so they're hand-holding, like, oh, let me help you get you through the deployment pipeline. And it can really be a lot of babysitting, right? And so the internal customer experience for your development team or developers, it's a complex process to work through. And also, what is the end of it, right? I mentioned again, you're deploying something for the first time, or like me, the 100th time. Processes can change. And there's this kind of like relationship with the DevOps team that they become the bottleneck, which is unfortunate. And so let's talk about the march to AAC, right? And so going from static days to infrastructure as code to now application as code. So kind of a decade ago, and I'll pretend I'm a developer throughout this example. So like a decade ago, let's say I was on a development team or a development manager. There's a few things that I need, kind of day in, day out to kind of get my job done, right? Hey, I might be deploying a Java application at JBoss. I might be maintaining our team's Jenkins instance, and we have an artifact repository with JFrog that I have to maintain. And so, but all these are on static VMs, right? And so as we kind of march towards production, system engineer, actually the picture of our founder, Bruno, I just like to pigeonhole him as a system engineer sometimes, is that if you're taking a look at, even environments that are in prod, they're still statically provisioned, and there's several different types, right? So I need a JBoss environment, I need a web server, I need to modify the load balancer. that are all speaking different languages. And now, how long does this take? Well, it might be preached to the choir. It might be something, why are you bringing this back up? Still, wounds are fresh even several years ago that it took weeks to get a VM. Look, I don't know why networking people always took so long. It took like a month to make a networking change. And then if the middleware engineers are a little bit more snappy, right, they can get me a new Node.js in about a week. But it took some time. And 3 sets of people did this, right? And so it wasn't one person doing all that, or depending how big or small your firm is, maybe it was one person, but typically that type of domain knowledge took a couple of different people. And so now we're marching in towards the IAC world, right? So tools like Terraform are out there. And really, one of the big benefits is that is repeatable, right? And so by having these 3 benefits here, that you're really reduced once there's available infrastructure, you're really being able to do stuff on demand now, right? So that's kind of the world we're living in for the infrastructure. Hey, clearly it's repeatable. Because if something's repeatable, it means it's consistent, right? And then also because it's code, you can call it, or it's integratable. So it's very commonplace to be calling Terraform in your CI/CD process, or it's very common to be laying down infrastructure at deployment time for your applications, right? But there's kind of a changing role now. If you take a look at what a modern software engineer or this quote unquote full lifecycle developer that goes through, right? And so there's adage that if you write it, you run it, or if you build it, you operate it, right? And then depending on your organization, I'm very pessimistic about that, but that's what I see more and more happening out there. So the full lifecycle developers, in charge of the whole lifecycle, versus now the changing role of the system engineer is being a platform engineer. So let's say your target infrastructure is Kubernetes. The platform engineer will make sure that there's sufficient capacity on the cluster for your workload to get placed, but also making sure there's tooling in place to onboard and offboard your applications, right, or your deployments. And so this is kind of how the changing face of application development and platform engineering has been going. But there's one thing that I kind of alluded to that changed the game is Kubernetes, right? And so instead of having several different languages, if you go back a couple slides about, there's someone who's deployed JBoss, and then ModJK, and then web server and F5 rules, Kubernetes kind of squashed that, right? And so Kubernetes, if you're marching towards it or using it, it's kind of a similar language. A developer, an application infrastructure engineer, and a system engineer can kind of speak the same thing. But there's a few things that we're missing. But this is why there's a whole bunch of complexity in there. Now there's code, where there was code not before, right? So instead of someone modifying F5 rules or load balancer rules, you can wire that into a service mesh like Istio. Now it comes into an area of expertise. Like, actually, ironically, my biggest outage was a networking related outage. As a software engineer, they let me deal with networking and prod, which is another story for another day. But that's typically it, right? Like all this expertise is getting shifted around that. Well, if it's in a Kubernetes manifest or a Kubernetes resource, that who's actually in charge of authoring that? And so what's actually missing, right? So let's say there even was that expertise that was disseminated across, kind of state of things here in 2021, right? Like still as a software engineer, I'll start from bottom up. Like Kubernetes or any piece of infrastructure is an implementation detail to me, right? Like my main job focus as a software engineer is to deliver feature and functionality, right? In a particular that benefits the business. I know that just falling back on my outage again, like I clearly know that traffic has to come in and traffic goes out of my application or my service, right? Now there might be rules around that, and I can easily describe you that, but understanding how that's wired might be for me. And also, I'm not a kernel engineer, right? Getting into the low level details of how these objects are made or created or managed, or what on earth is Kubernetes or another orchestrator doing to kind of fulfill those requests for you? It's beyond me, right? And kind of like the platform engineer now, poor Bruno here, is that there's a litany of tools that his team or their team have to use, from deployment to service mesh to packaging to rules. To reporting, to cluster management, like the list goes on and on, right? So that's kind of what's like kind of that tangible piece that's that's missing today. And so I want to introduce a concept called AAC, application as code, right? And so this will be a little bit slanted towards a developer. And so as Terraform is IAC, helps with infrastructure code. Shippa helps with application as code. And so where does this marriage between, let's say, ISC and AAC, or even what is AAC, come together? Is that, well, with application as code, you can define a few things, right? Like, first of all, even that first define policy is, well, clearly, as a platform engineer, you want to put kind of some sort of limits on the resources that people can consume. So like, hey, maybe I'm keeping this Kubernetes centric now. So maybe Robbie's application can only have 4 replica sets, right? Or maybe Robbie's application might have, per pod might be bound to, like, say, 8 gigabytes of memory, 100, 1 CPU share, or 100 CPU shares. Like, you can define resource limits and consumption limits, and also other sorts of policies like security policies, right? Like, hey, Robbie's application have to pass, these particular CVEs or whatnot. And even having what is an application, right? Like that is that kind of an intrinsic question. Kubernetes land, a service is a load balancer, right? So what is the definition of an application? How can you logically define things? Hey, this is our payment application. These are the particular pieces that make up a payment application. And with AAC, being flexible of the infrastructure, right? So as new technologies come up and down, you can deploy to a VM or OpenStack or some sort of cloud driver, or even Kubernetes we're talking about today. That's kind of like in that definition. And then reporting also. So like, how do we get metrics out of the application? And so kind of AAC architecture here, kind of where stuff plugs in. If you're looking to follow an AAC type of model, imagine Shippa and our open source project is called Catch as a manager for the managers, right? And so kind of tying everything together that you might need in a singular definition. So, you know what? We have to deploy an image, or we have a CI/CD process that we need to call, then we have to lay down infrastructure. Kind of defining that in plain English, and also putting policies around that, right? So both the DevOps or platform engineering, people who author the rules, and the developers who have to be subject to those rules can kind of really clearly see, like, hey, these are the full steps that we need, or full visibility for my particular application. So kind of obfuscating some of that infrastructure. So Terraform and Shippa, where do they come together, right? So Terraform and Shippa. So there's kind of 5 wirings. I'll kind of walk you through the Terraform. We have a Terraform provider, and so kind of the 5 wirings that you need to kind of kick something off. And I'll actually kick it off and show you what's possible. So the first thing is we have a Terraform provider. If you don't have a provider, you don't have a chance. As my father would say, if you don't have a lottery ticket, you can't win the lottery, right? So we have a Terraform provider out there. To get also what's needed is, this is actually where the core power of AAC starts coming in, was defining a framework. So in Shippa world, a framework is the lifeblood of Shippa. So here we're deciding, like, hey, you know what? For our applications, we're going to be using a service mesh like Istio, right? It's who has access to it on the development team. How much can they consume, and so on and so on and so on. So it's very easily enforceable, and you can author all this in HCL, right, in code. Also, that particular next thing is we have to connect a cluster. And so assuming one of the chicken or the egg tech arguments is that we have folks who use Terraform to spin up a Kubernetes cluster, and then we get that information, and then we wire Shippa to that cluster. But assuming you already have a cluster running, it is just need a couple pieces of information, which any most tools will need to connect, such as the endpoint information and a service token to interact with the Kubernetes cluster on your behalf and for your behalf. And then kind of the fourth piece is, well, what is this application we're talking about, right? And so this might be, hey, you know what, this is a Terraform application, or in this example, it's called TF app. But it could be, hey, I'm deploying our payments portal. I'm deploying several aggregations of a particular application. That's particularly it. And then kind of the last thing you need is something, if you choose to use Shippa to deploy, now Shippa can deploy for you if you want. You can define an application, an image, a piece of source. We use build packs, or just tie into your current CI/CD process. And so let me actually go ahead and run this and show you what you get. So firing back up Visual Studio here, I have a completed example from soup to nuts here. So here we have a particular wiring to our provider that we need, and also an authorization token that I set up ahead of time to Shippa platform. And then this is basically it, right? This is AAC in its finest, right? Here's the definition of it. So it's saying, hey, this application will go to Kubernetes. I made it very simple. I didn't have any rules because I don't like rules, right? So it's like it's going to be available to the public. I give myself a limit of 5 replicas. It's going to be needed to use a particular endpoint like Trafic to allow ingress out, and also we're going to just skip some of the security checks that we have here. Also some wiring here. This is the wiring of our cluster here, that this 3 pieces of information that we need to create. And then also leveraging a framework, so like usage ownership. So all that can be provided. And let's go ahead and see, like the previous person said, pray to the demo god. So let's actually check this out and actually run this. So first thing is, make sure we have a Terraform plan. Looks like it ran successfully there. And so I'm going to be running on auto approve. Hopefully I entered all of the tokens correctly. So let's take a look here. Auto approve. Let's go for gold. It looks like things are being applied currently. So I'm deploying a WordPress application through Shippa. So if I come back to the Shippa cloud instance, we can actually start taking a look at things that are being created in the platform. So it looks like my framework's just been added. Certain things, certain pools have been added here. And so as that stuff gets created, I'll spend like 20 seconds talking about Shippa here. So this is this is Shippa Cloud. You can sign up at app.shippa.io or head there and register. And basically, it's kind of keeping track of everything, all the applications, all the infrastructure just related to the applications or where they are. And so currently what's happening is that I've created a framework called WordPress Dev. I made several rules inside of Terraform. So it kind of laid all this out for me here, which could be a talk for another day about what these rules are. It's actually going about and deploying an application right for me. And so with this particular application, though we're kind of running a little bit behind today, so I kind of speed it up, is that without anything defining like, very complicated Kubernetes manifest or whatnot, I'm actually able to deploy an application, which was WordPress, but by presenting an image, we're able to map out all of the particular items that your particular application has. So, hey, this is the configurations that were needed, or here's a load balancer or service address, here are the secrets and whatnot. If the application started up, lastly, it should actually have laid down a ingress address for me. So it might not have started. So we'll see. We'll see if it starts. So we'll just click on that, see if WordPress would start. But it looks like something is starting up if all of the events have occurred, which it looks like it has. And oh, look, it came up. Shippa actually created this address on demand for me here. So with very minimal Terraform, you can actually deploy a running application that's subject to several rules, and also providing a very clean internal developer experience. But that was about all I had today. We can definitely learn. Oh, actually, I'll just talk about our open source offering real quickly. Is that we also are an open source project. It's called Catch. Always looking for contributors. Love to get your feedback. Love to get your pull requested. And with that, thank you so much for having me on today and at HashiTalks Canada.
Thank you, Ravi. That was a great talk. And thank you for not setting Jackie and I up with a tongue twister at the end so that we embarrass ourselves. Yeah, it was great. Yeah, really enjoyed sort of thinking through that application policy piece.
Yeah, it's been great. Our next speaker coming up is Simon, and he's going to be talking to us about automated onboarding of users, projects, and workspaces. Welcome.
Hello, everyone. How are you guys?
We're doing pretty good. It's kind of been like a MC-a-thon today, but it's been really great. Enjoying all the speakers and really enjoying all the energy people are bringing towards the end here, because I know it's been a long day.
Awesome. Yeah, it's a lot of the talks I enjoy a lot. Like they've been really good stuff, lots of good content, and yeah, excited to be here. Thanks so much for the opportunity.
Thank you for joining us. And with that, I'll hand it over to you and you can get started.
For sure. Perfect. So I'm just gonna share my screen quickly here. And let me know when you guys can see my slides. Is that coming up?
There we go.
Perfect. Okay, let me, sorry. Just finding my notes. My apologies, rocky start. Well, for some reason I cannot see my notes, so let me just get back to it. Okay, so for the talk today, I pick an interesting topic. It's at least for me, is orchestrating Terraform Enterprise or cloud. The idea is to automate the user onboarding or teams, projects in the different workspaces. My name is Simon Garcia. I'm a delivery consultant at Arctic. When I'm not working and coding and all that, I'm really into sports. I play soccer. I do some BMX. Like to go for hikes with the dog and everything. So that's kind of what I do in my free time. Please, I have there my LinkedIn and GitHub if you want to connect. Happy to share some knowledge and also learn from you guys. So let's do a little bit of an introduction on this project. The idea came from like actually talking to a customer at one point where they say they had a need to be agile and keep onboarding their developers really quick without interrupting their workflow. They were like a small company, but a lot of work happening, and the developers were really quick jumping into different projects. The customer wanted to introduce a little bit more maturity and more like management around their Terraform work. So yeah, they asked me like what you can do there. This is something that for me I haven't done many times, so I decided to take a stab at it. There's probably a couple ways of doing it, but yeah, I just took a stab at it with the interconnection with GitHub. So yeah, let's go through it. So as I was mentioning, the goal of the purpose of this project is to facilitate the management and the onboarding process of users, expedite that process. So when a new developer or new operations guy comes into the organization, we don't have to wait for maybe the app owner to onboard them into the workspaces or into Terraform Cloud. So in this case, I'm leveraging the integration with the versioning code system. So in this case, I pick GitHub, and I think for companies that have that model of infrastructure as code, they commit everything to their repos, and they are heavily into Terraform projects. I think it's a good solution or a good idea to try to expedite that process. Again, some considerations is still a work in progress and some enhancement and some fixes that I still have to do, but I hope that you guys enjoy what I'm going to showcase right now. There's some prerequisites for what I have. So of course, you need a Terraform Cloud account and an organization. You can maybe get to the point where you can automate the organization creation and all that. But there's some stuff that I just wanted to have preset. You also want to have Terraform Cloud support VCS. In this case, the ones that are supported at GitHub, either the enterprise version and Bitbucket, GitLab, and so on. I'm using a management workspace preset already. So when I'm doing my work and my commits, it's gonna go through that management workspace and then create either the additional users, the additional workspaces, or teams. It's one of those things that you're automating with Terraform, but you somehow need to have Terraform already something in place to go through the automation. Otherwise, you may be using automated through the CLI or whatnot. And then for an organization, maybe a standard of like a base team access, so you have an idea of what your naming convention is going to be for teams. If you're going to maybe have dev and prod projects, which teams you have access to those different workspaces. Benefits and some use case for this project will be, again, the expedite the onboarding of like admins, developers, for companies that really go quick through their developers, or maybe they're a task company that hire specific developers or contractors for some pieces of work. That quick turnaround of like, okay, this contractor is done. Let's take him off and put the next one for the next piece of the project. It can get sometimes a little bit tedious to manage. So having some automation around that for sure will help. You maybe have a need to create Terraform projects and workspaces on the fly just for doing some testing or whatnot. So yes, you can do some of the stuff manually if the access is given, but might as well take advantage of the automation to quickly spin up a workspace and be able to do your dev or your QA, your testing, whatnot. With the automation, again, you'll be able to create your teams, manage previous teams as people go, take them out of the team and so on. The permission to the workspaces, maybe there's a new team that gets on board that is going to work on a second phase of a project, and you now want them to have access to that project or workspace, and you can do that. And finally, with the usage of the VCS integration, you can keep that as your little bit of tracking or record of what's happening, what changes are being made into your Terraform Cloud organization, as well as ensure that if you go through an approval process on GitHub, the permissions and the workspaces or whatnot that you're creating are reviewed beforehand, right? So not everyone gets like admin access right out of the bat. So the workflow that I chose and I started to develop here was to generate a pull request on that repo that will have like the variables or whatnot for the users, teams, and so on. From there, as I was mentioning, we'll go through an approval process where the application owner or a manager will quickly check like the permissions and whatnot. Okay, this makes sense. This exists. So okay, it's approved to merge. Terraform will pick that up with the right configuration on the workspace. We'll pick that up the pull request and apply the changes and create all the configuration. This is kind of how it looks on a visual. You of course have the option to like commit right through the main branch or the master branch, and of course that commit would also trigger the Terraform plan and apply. For the demo purposes, I'm doing a little bit of that just to expedite, but ideally, like you want to take advantage of the approval flow. Okay, so let's go a little bit through the code. Just want to explain how I get to this demo and how to get it working. So the first part is the user and team membership. So on the right side, I have a request for like 3 new users. I specify their email address and the team they're going to be part of. My code shows, and you're going to see this along my resources. I'm just leveraging the for each and the for nested for loop to go through each of those members, grab their email address in this case, to create the membership to the org. In a second resource, I'm going to be grabbing that team value and then working with that to add it to the specific team. At the end, if you do that through the GUI, this is done on the organization settings, and you go to users, you're going to end up with your users on the invited section until they eventually get the email and approve the invitation, create their account if they don't have one, and so on. Eventually, they will become active users. One of the differences that I saw here is once you do that from the GUI, you do have to specify a team out of the bat. So let's say if you're create a new team plus a new user, doing it from the GUI, like it requires like a couple clicks to make sure your team exists, make sure if it doesn't create it first, and then grab the user and add it to the specific team. Then my next resource block or request will be the teams and organization permission. So I have here a request for one team. I try to use as many of the values or parameters that the resource block allows you to configure. So in this case, I have visibility, which is you can set either to secret or organization. So what that means is if it's set to secret, only the members of that group can see the actual group or team. If it's organization, any other member can see the groups as far as they have that access visibility. I'm using here a switch, and I highlighted the admin. I use it as a switch in case if I want to give some admin privileges to this team, I'll set that to true and then specify what I want to give them. So maybe I want them to be a Sentinel admin or a workspace admin, and I can set that to true or false accordingly. This is how on the code I'm doing that. So I'm taking advantage of the dynamic block expression and the lookup functions. So what this for each is doing is basically looking for that admin flag. If it's set to false, then it's going to leave it empty. If it sets to anything else, in this case true, it's going to now apply the values from the content. So each of those sections is going to look to see if it's going to be true or false for the specific privileges. So that way, when you onboard your team, you can specify what actually should they have. Then for the team membership, now, as I mentioned before, there was a team value team value on the user configuration. So now I'm iterating through that as well and added it to the specific teams that they were just created. When it comes to those permissions, this is how it looks from the GUI, just for further explanation. So depending on what admin privileges you give, they will be able to have some of those tags. So in the GUI, it's just a simple checkbox. But that will, maybe you want to add a team that is an administrator for just the VCS settings, then that would be a use case for that. So I want to make sure I give some flexibility when this is happening, because you may have a large team that want to make sure, okay, well, only these guys can do VCS, only these guys can do Sentinel, and so on. Then we go into the workspace access. So on the right side, again, I have a workspace. They access like the values for that variable. One of the things I look at, okay, which team we're going to give access to which workspace. And as on this one as well, I use the access and the highlighted value there as a flag. On this resource, you can have either fixed permissions, so your access can be read, write, plan, and apply if I'm not wrong, or run, or admin. Sorry. So that will give all the all the access to all the below access to that group. Now, if I put it to custom, then I can select on that workspace what that team can actually do. So perhaps I want the admin to have full access, but when it comes to the developer team, I only want them to be able to play with the variables and run and they can do an apply. But when it comes to the state file and the Sentinel, like I want to make sure, maybe I don't want them to see the Sentinel mocks, or don't want them to be able to write to the state or just read it or whatnot. So again, adding some flexibility to that permission. Similar to what I did on the teams before, I'm leveraging that dynamic block expression and the lookup function to kind of switch over those values and make sure that I can specify that extra value if needed. Otherwise, if access becomes just admin, then I don't need to specify that extra set of parameters, because it's always going to be set or true for those. These are explain like from the GUI the permissions that are given. So for the runs, they can have read, plan, and apply. You can maybe have a group that is just set to do maintenance or maybe do some billing. In the case, and this is a stretch, but you have project managers, and they know like the project is completed, or for some reason we need to stop any work on it, and maybe there's some billing issues or whatnot. You can have that team to be able to control if the workspace gets locked or unlocked, and that way no further work can be done on that project. The other piece is the variables and the state versions. So whoever has that access can either just read the variables. Maybe you have an operation team that is there to troubleshoot, but the idea is that they don't mess with any of the variables that the developer team is working with. So they can troubleshoot and look at errors on the state, but maybe not do any changes, because the developer owns that project, and that's kind of their responsibility. Finally, I have my workspace request. So on your right side, I'm adding that new workspace, and for this one, it's a lot of settings you can apply there. I picked the ones that I think are maybe they meet some housekeeping requirements. So make sure that it has a good description. There's some tags on it that identify it, as well as some functionality. So if I want to make sure any changes can trigger the workspace run, or if I need to use a specific Terraform version, I can also specify that here. Additionally to that, having this automation that allows me to perhaps connect that workspace right away to the VCS, to a repo either on GitHub or another handle. So it saves you time from. I mean, you can create it. It's pretty quick anyway. So on the GUI as well, that you create a workflow type workspace, and you select the repo and so on. But if you already know which repo is going to go, and you can put it on a quick request and get it done, then it will expedite that creation process and ensure it's linked to the right project. There's an option even to do the auto apply or auto apply and then commit on the first on creation. So as soon as you create that workspace, if the code is ready to go, the run will automatically happen, and right there the user will have its project run. So let's say I have a developer say, hey, I already have the code ready to create a GCP instance in this case. I just needed you put it on Terraform, run it, and it's good to go. So this would be a use case where the guy doesn't have to worry about what's on Terraform Cloud or how to provision. It's just, hey, here's my repo, puts the request. Once everything gets approved and added, eventually he just gets a notification of, hey, here, your repo, your project is ready. Go and check your resources. This one is a little bit more bigger, but this is what I came up with as well. So similar to the other ones, we're using that for each loop to iterate through the workspaces, and then the dynamic blocks to set the VCS repo. Perhaps I don't want it to have a repo, and I'm going to be doing some manual work on it or whatnot. Then I can set that to none, and the repo won't take place. And it won't get configured. So let's do some demo time. Let me see if I can get out of here and show my browser. So I think here's the whole screen. So let me start quickly. Okay, so I have here just that management workspace that I was mentioning. I already have my org with some basic, the VCS configured. On the settings, I'm going to show you there's no no teams yet, no users. So the next step is me going through the request via Git. As I mentioned, in this case, I'm just gonna simply do the commit to the main branch just for timing purposes. So I'm just doing that on the side. Doing my commit now. And push. So we should see shortly that Terraform is going to pick that. There you go. It's going to pick that planning or that commit. I'm going to go to runs just to show you how that looks. One thing to note when I came out with this is I'm not using any variables on the workspace, but I'm leveraging the auto TFRs. So that way all the variables are set in that file and they get committed. It gives you that option to review everything that is happening from GitHub and not really have to like check the variables or their values on the workspace itself. Another way that I was thinking of doing this was through a secondary workspace, more call it like maybe a worker workspace that I will use to set my variables on the management workspace and so on. So that way my workspace in Terraform Cloud will have that documentation. That worked. The only thing that I found there is, I'm sorry, I'm just taking going off track here for a minute. But the issue that I found there is for run triggers, when I set this guy to, okay, maybe source yourself from that other worker repo, regardless of me setting this to auto apply, I have to come here manually. I found out kind of a little bit late in the game, but I stay with this current set. But that will be another option. Not sure if at some point this may change, but yeah, it's something that is also available there. When you do it that way, you do have to come back to your management workspace and approve that plan. So let's look at the plan. So right now on my auto TFVars, I have a couple users that I'm creating. There's some teams as well and their membership and 2 workspaces. So we can now let's look at that in order. So I now have 4 invites, and sorry, I pick on HashiTalkCorp.com, fake corp, but just for this demo purposes works. And then I have my teams. Right now it says 0 members, but if I draw in, I'll see that the member is attached to it. Also, the right permissions were set according to what I had on my TFVars as we saw on that request. And finally, I have the workspaces. One thing to note here is you can also go as far as automating your VCS integration and picking a different handle or that you want to check for your repos. In this case, I use my own for these 2 workspaces. And then I wanted to see tags. I wanted to see things like that as I was showing. So it's all there. Nothing will happen on these workspaces because they're empty. I only have a README on it. But that's kind of the gist. For me, it was a really really fun project getting it to there. A couple headaches, but yeah, I really enjoy it. But yeah, that's kind of the demo for now. There's a couple things that I'm working on it right now. Can't remember exactly what I changed, but on my permissions, I can only assign 1 team per workspace. That's on my code for sure that I need to fix, because initially I had it working. And the other one is I'm having some dependencies issues when I do the destroy. So it comes to either destroy the whole thing or destroy the ones that are dependent. Let's say if I have developers that are members of the developer team, then I got to make sure I delete all the stuff altogether. That's it for now. So let me get back to the slides. Perfect, that's up. Come on, buddy. Yeah, so I'll be on the chat if there's any questions. I hope you enjoyed this one and it's somehow useful for anybody out there. Yeah, thank you so much for listening and for your attention. And if you want to connect again, that's my GitHub and LinkedIn address.
Yeah, awesome. Thank you so much. And that was a great session. And thanks for also giving the shout outs I saw at the bottom of your thank you slide for hugs and learn and I think discuss. For the community, if there's things you're looking for, those are great places to check it out for resources from us. And yeah, thank you so much for joining us today.
Perfect. Thank you so much, guys.
Thank you, Simon. Up next, we have our last speaker, and my cat. He wanted to speak too, apparently.
We made it this far without a pet crashing. It's
pretty good.
Meant to happen.
Shazin.
Hello.
Hello. Thank you for joining us. You are the last speaker for HashiTalks
I know.
Canada. So thank you very much for joining us today.
Thank you for hosting me.
And without further ado, we'll turn it over to you.
Sure. I have already shared my screen. Are we good to go?
There we go. I think we can see your slides, but we're in, there we go. There we go. We had slide infinity for a second.
Oh, okay. So all good, right? You can see the slide and you can hear me.
Yeah, all good to go.
Okay. Welcome to HashiTalks by me. My name is Shazin. I'm a senior engineer working for Arteria. And today I'm going to talk about GitHub authentication managed by Vault. So before I delve into it, I would like to give a brief overview of what Arteria is and who we are. So we are into a digital contracting space, which means that we are trying to help the world contract faster, which includes drafting, negotiations, approvals, and even data extraction from existing contracts. We officially started late last year, and we have had a steady growth since then. We got a Series A funding a couple of months back. We also have had a steady growth with respect to our headcount. We are 30 plus right now. So to know more about Arteria, you can visit arteria.ai or visit our LinkedIn page. So let's jump onto the topic for the day. Git. Git is one of the most popular version control system. Like everyone else, we at Arteria use Git for our version control. We use GitHub Enterprise Cloud for our source code management. So last year, when we got a GitHub Enterprise Cloud license, the first question that came to our mind is, how are we going to authenticate users against GitHub, especially from a command line? So GitHub provides a couple of options for authentication, but they all came with a couple of challenges. One of the options is the HTTPS option, where you enter your username and password to authenticate. But we all know that username and password can be easily compromised. And it was against our guiding principle across the organization that we should always provide short-lived credentials. So one workaround that GitHub provides is to use PATs, personal access tokens, but asking users to create short-lived PATs every now and then is an inconvenience for them. So we thought about, we wanted another option. So the other option GitHub provides is the SSH way of authentication, where you create a key pair, a public and a private key, and you upload the public key to GitHub, then you authenticate. It is seamless. The problem again is that the credentials are not short-lived. So as long as your public key is on GitHub and you have your key pair with you, you'll be able to authenticate to GitHub. So it becomes very difficult if there is an attack across the organization. The access revocation becomes a bit difficult. You'll have to ask each individual user to go to GitHub and revoke the public key. That's not something we wanted to do. So what's the alternative? GitHub then started supporting SSH certificate-based authentication, I believe around 2019. So how does this work? You have to define your certificate authority, a CA, a custom CA, and add it to GitHub. Then you can sign the public keys of the users with this custom CA, along with details like your GitHub username. So this produces an SSH certificate, which you can use to authenticate to GitHub. That was pretty good because we were able to define the validity of the certificates. You can set it as 1 day, 2 days, or 3 days. Similarly, if there is an attack in the organization, there is a single point of revocation. All you have to do is go to GitHub, recreate the CA. So all the certificates that were signed by the previous CA becomes invalid. So that's pretty good. But like everything else, it came with a challenge. And that was, how do we sign the certificate, or who will sign the certificate for us? So going the manual way was definitely not an option. Plenty of risks. The primary one being that there is a risk of exposing the CA private key if I'm going to do it from my machine. And it's an unnecessary hassle for developers or users in general that you have to ask a human being to get your access certificate. And end of the day, we shouldn't be doing it because we are supposed to automate things. Machines should be doing it for us rather than us doing it. So we had to look for an alternative, an engine that can do for us. And we found Vault. Vault fitted all our requirements. It provides us a signed SSH certificate engine, which is pretty simple to set up. All you have to do is enable the secret engine, configure your CA, and once you have the roles in place, start signing. Pretty simple. But it came with a few challenges. The challenge was that we didn't want to expose Vault UI or Vault CLI to the end users. The reason being, we didn't want users to log into a system to get their passwords every day. We consider that as an inconvenience. And moreover, we didn't want to expose the underlying infrastructure because things could change underneath. So it's always good to have a layer of abstraction on top of it. So what do? So if you ask me, what we wanted at that point was, we had a couple of end goals that aligned to our principles across systems in our area. So when it came to GitHub, we wanted a setup where we can access GitHub without any credentials at all, if possible. If not, with minimal credentials. We wanted to avoid a secret sprawl where we had many different passwords for many different systems. The other being that we wanted onboarding and offboarding to be automatic. If that is not possible, at least with minimal manual intervention. So how do we do it? And we wanted to make sure that the system is secure when we do this. So we got thinking. We wanted to do this with Vault and implement the GitHub SSH certificate-based authentication. We got thinking and thinking and thinking. And then we came with this. I'll give you a few seconds to run through this. I am going to explain it piece by piece. So on the rightmost side, the black triangle, it's all familiar for us. It's Vault. So that is the integral piece of this whole structure. And I'm going to go clockwise. Then we have the application DB at the bottom. Then there's GitHub, where our code is stored. Here is Azure AD, where our user lists are stored. And then we have SharePoint, which is the file storage that we use. You can use any file storage for that. So let's see how an end user interacts with this system. Say Emma joins Arteria. She completes her onboarding process. She's all excited and she wants to get started, which means she needs access to GitHub. So what is she going to do? She's going to create a key pair, a public and a private key. And she's going to upload this public key to a private SharePoint directory that was automatically created by a process. It's a private directory, only she has access to it. Okay, so now her public key is in that private SharePoint directory. every night, a job runs that is going to pull this public key from there, get it signed by Vault, which means there is an SSH certificate now, and pushes that SSH certificate back into the SharePoint directory. Emma also does one thing. She syncs the SharePoint directory to her local, which means that every morning when she logs in, she has the latest signed SSH certificate on her machine, which means she doesn't have to have any kind of credentials in her system to access GitHub. All this happens automatically. So how does this work in the background? Let's start with Vault. We use AWS, and we use AWS EKS for all our deployments. So we were able to use KMS auto unseal with Vault. So what does this translate to? So for those who have used Vault, you must be already familiar that Vault has an unsealing mechanism where you need 5 different tokens. It's using Shami's secret sharing algorithm. We didn't want to store 5 different secrets. We were just 2 in the infrastructure team. So we got to know about KMS auto unseal. We used that, so there are no credentials required to get Vault started. We did something similar for the app too, that is in the middle. It's a Spring Boot app. We used the Kubernetes auth mechanism, which again means that we don't need to store any kind of credentials in there for the authentication with Vault. So what does Vault do? So as you see here, the app talks to multiple systems. For all these integrations, it needs credentials. And all these credentials are stored in the Vault KV secret engine, which is, for those who haven't used, is a very simple and secure way of storing your secrets. And then we are running the SSH certificate signing engine by Vault. So how is the signing process done? So we're using a Spring Boot app as the orchestrator. We call it the Secret Manager app. We use the Spring Vault project for integration between Spring and Vault. Like I said earlier, we use the Kubernetes auth mechanism, which makes it very easy for us for the authentication between the app and Vault to work. So this app does 3 things every night. The first job, it syncs user list between Azure AD and the app database. What does this mean? So assume it's the first run. The database is empty. It is going to pull all the GitHub users from Azure AD and it will populate in the database. In the subsequent runs, it is going to make sure that if a new user has been added to Azure AD, it gets added to the database. So once this job is complete, we have the full user list in the database. The second job syncs data between GitHub and the database. What are we doing here? Or why are we doing this? Because to sign an SSH certificate for GitHub, we need to have GitHub username in place. So we're going to fetch all the users of our organization from GitHub and make sure that those username gets updated in this database. So after the first 2 jobs, we have the full user list in the database, plus their corresponding GitHub usernames. Now we are all good for the signing process. The next job does the signing process. It pulls the public key from SharePoint for each user, fetches the relevant data from the database, goes to Vault, gets a signed SSH certificate, pushes it back to SharePoint. So this runs every night, which makes sure that every night the latest SSH certificate is there for every user in Arteria. And they all sync their SharePoint to their local machine, which means that every employee or every GitHub user in Arteria, when he logs in the morning, he or she logs in the morning, there is his or her latest SSH certificate for GitHub access. No credentials required. So how does this look in action? So I wouldn't be able to show you the nightly job, definitely, but we do run an admin UI where we can run this certificate generation logic ad hoc, because there are certain scenarios where we require it, like a new employee joining. So she or he doesn't have to wait till end of the day for the certificate to be generated. So this is a screen recording I did this morning. So I fiddled with the certificate a bit to have an older certificate on my local. So first I'm going to show you the validity of the current certificate. If you see, it was generated on November 16th, 5:59 p.m. and it is valid for the next 3 days. We generate 3 days valid certificates. So it's valid till tomorrow, 5:59 p.m. So now I'm going to go to the admin UI and generate a fresh certificate, which means that it will create a certificate, push to SharePoint, and I'll have it locally immediately. So let's go to the admin UI. It's a simple single page app that we built. I'm going to enter my RTA email address and click generate. So this does all those things I was talking about. So once it succeeds, it means that the certificate has been pushed to SharePoint, which means it has been synced to the local. So now if I go and check my certificate validity, you can see that it was signed this morning at 10:46 and it's valid for the next 3 days. So this is how it happens. Normally, we don't have to run this admin UI stuff because it happens automatically. So let's come to the benefits. From my experience so far, the primary benefit has been that the users do not have to store any kind of credentials for GitHub. To be honest, even the infrastructure team doesn't have to keep any kind of credentials for this whole mechanism to be running. And yes, the onboarding, offboarding process is minimal. We were able to achieve both of our goals. As you have seen, it's just the initial setup. From then on, it just goes on automatically. And all the certificates have short-term expiry. We create certificates which are valid for 3 days. And yes, if there is an attack, the revocation is pretty simple. You go to GitHub, recreate the CA that invalidates all the existing certificates. So folks, this is how we use GitHub in Arteria. It's pretty seamless, no credentials required, no going to secret manager server and getting your passwords. Thanks to Vault and thanks to HashiCorp for helping us to realize this. Here are the references for all that I've talked about. GitHub SSH certificate authentication. There's a blog by GitHub on how this works. Then we have the Vault components, the KV secrets engine, the SSH signing engine, how to do auto unseal with KMS, how to implement the Kubernetes auth method. Then there is the Spring Vault project, which is a pretty good project. It provides a very good integration between Spring Boot and Vault clusters. Then there is Microsoft Graph API, which we used for our communication from the app to Azure AD and SharePoint. Then there is GitHub GraphQL API, which we used for the communication between the app and GitHub. So that is it. If you have any questions, comments, you can put it on the YouTube chat. I know it's the last presentation for the day. I am going to leave you with this. Over to you. Thank you.
I had to pause to read the comic. I love it.
Thank you so much, Shazin. Thank you for walking through that pretty interesting use case, integrating like workstations to just have proper security. I dig it. And thank you for wrapping HashiTalks Canada for us.
Thank you.
If there are any questions, take them to the YouTube chat. For Shazin or any of our speakers, it seems a number of them are still hanging out there.
Yeah, definitely. And as is the HashiTalks tradition, you've seen Jason and I all day as the kind of front and MCs of the event, but we do still have people behind the scenes helping us out. So I'd really love to kind of pull Taylor and Katie up on the stage if they're here, so that we can kind of say our final goodbyes and thank yous to everybody.
Hey, howdy. Thank you so much. This is absolutely fantastic. Want to say thank y'all for coming and enjoying this. Same with our landscapers. Now is the perfect time to get some leaf blowing done. As you can see, I got to get out of here. So this ended at the perfect time. So thank y'all so much. This is a lot of fun. Lots of fun behind the scenes as well.
And thank you so much to Katie for organizing, if you want to say a couple words.
I was jumping in and I just realized I'm muted. I'm actually multitasking, trying to chop like the last talk right now before we end the live stream, and then I have to download it and export, whatever. Anyways, thanks everyone. Echoing Taylor, this was super fun. And Jason and Jackie, it was really fun to get to catch up with you today. And yeah, thank you all. Thank you all for your part, and thanks to our speakers.
Yeah, thanks for having me. This was a great day.
I'm glad you went from morning time to now it's dark outside your windows.
We did it. You can see like the last little bit of sunset behind my fiddle leaf fib, but
November in Toronto. It's
yes, 5 p.m. sunset. But yeah, really happy that we did our first HashiTalks Canada. It's just great to see like our local community and also, of course, our country coming out and sharing talks. And thank you so much, everyone who came out today and either spoke or supported or, yeah.
Thank
Wonderful.
you.
Thanks, everybody. We'll see you around.
Bye-bye.
Have a good one.